Giovanni? We can an email to where I consider you.
Oh, that's all right.
I've been reading your paper.
Oh, we can
We can talk more. We really like this paper.
I'm excited.
Are you gonna?
So we'll have a technical talk. We'll all series of technical talk this afternoon. I'll probably be running around. You live nearby? But definitely there's something.
I used to be. I used to live in downtown. Enjoyed coming around. Basketball game.
Yeah. Well, TikTok started some sort of data at the very beginning. It's not even
My wife and I rented that car. So we lived in but that's easy. Well, it's right down 5 minutes. You know, 30 minutes a year, 30 minutes a So you're still oriented? Well, if you want a nice drive, you basically go Monday or Saturday.
I would like to. I'd like to.
Really, really good.
I found out about
Yeah. No, I'm not. So I'm just going to do the intro stuff, and I'm not presenting it. It's not hooking anything up. Just going to have a few notes here of people.
Yeah, 1986. I came here to go to work for a little company called
Okay, everyone, we're about to get started. So if you'd like to find a comfy seat and sit down. It's requested that there's alternate seating for COVID-19 if you want to be good and correct and proper. Okay, hello everyone, and welcome to our first worldwide voice web. Delighted to have you here, both to the smaller contingent of people who are here in person and the hundreds of people who've registered to watch this online. So what is the starting off point of this? Where this starts from is that for people, the most natural way for them to communicate and the most long-standing form of communication is by using speech, that humans talk to each other to communicate. And that has been an extremely effective interaction mechanism. Now, obviously these days we have lots of other interaction mechanisms. We can write on paper or computers, we can text, we can TikTok, all kinds of things. But there are many, many circumstances in which the most convenient way to convey information or instructions and commands or to ask questions is to do it by voice. This occurs in many contexts when you'd like to be able to have hands-free operation of giving commands, or whether you want to do it at some distance, etc. And so what we're interested in here is how to create the technical infrastructure to make that possible in an open worldwide voice web. So the contrast that we have before us is between the World Wide Web, which was underpinned by open standards, which have allowed many companies to be developed and play on an even playing field, versus the current situation for voice assistants, where we have a series of walled gardens. In the US, the two biggest ones being Amazon Alexa and Google Assistant, but there are others like Apple Siri, Samsung Bixby. There are other ones, notably in China, but each of them is a walled garden, and we do not have an open infrastructure. And so to try and think about and address that, Professor Monica Lamb, together with a number of us, set about how we could start exploring having an open worldwide voice web. That reminded me I didn't really introduce myself, so I should say my name as well. Hello, I'm Christopher Manning. So I'm the director of the Stanford AI Lab and associate director of the Human-Centered Artificial Intelligence Institute. And we're not doing either of those things. Well, I'm in the long-standing natural language processing faculty at Stanford, founding the Stanford NLP group, and that's mainly the research that I can continue to do. Okay, so back to the main story. So a year ago, we started off having OVAL, the Open Virtual Assistant Lab, continuing work that Monica and her team had begun on having open voice assistants. And so today we're going to show you some of where that's gone and lay out the broader picture of a worldwide voice web. So we've got lots of stuff coming up today. So first we're going to have an introduction to this world by Monica. Then there's going to be a panel on how we need to have this for all the world's languages. Something I didn't mention, I guess, is that for many, many people around the world, their only communication mechanism is by spoken language. And so that will include Brent Phillips, Mark Dalton, Musa Doumbouya, and Chris Peach. We'll then have a panel on will there be a worldwide voice web, which will be moderated by John Markoff. John Markoff wrote the very first newspaper article on the World Wide Web, and also has been a prominent supporter of our World Wide Voice Web. And speaking on that will be XD Huang, Jerry Kaplan, myself, John Stein, and Jerry Yang, the co-founder of Yahoo. Then after that, we get to lunch, and then after that, we'll have another panel on the open voice information ecosystem moderated by Anne Grimes, with Ed Chang, Chris Dix, Hugh McGrory, Kathy Pearl, Lowell Robinson, and Richard Sosha, followed by a session looking at the representation of task-based dialogues, the open IoT ecosystem, and industry ecosystems for the worldwide voice web. We'll just keep going after that, and we'll have then tutorials looking at both the task-based voice agent technology and also a little bit about the conversational social bot that I've been involved in developing. So we've got a busy day in front of us, and I hope you'll enjoy it. So let me next introduce Professor Monica Lamb. So Monica Lamb is one of the leading faculty at Stanford with a prominent career, first in compilers, but then extending into other things, looking at open flow networking and moving for her current act into looking at ways of how we can have the kind of programmable openness necessary for having a worldwide voice web. So welcome, Monica.
All right. Well, good morning, and welcome to our first workshop on the World Wide Voice Web. So we have because of hybrid, we have a small audience here, but we are so glad to be able to see some of our friends of the open voice effort, and people we haven't seen for like 2 years. So before I start, maybe I will give you a little bit of the history of how we got here. About 2 years ago, we have the Open Virtual Assistant Lab held the first workshop, and it was a workshop on the open voice assistant. And it was an invitation-only workshop, and the room was packed with people from the industry as well as academia and also nonprofit organizations. We all got together and we shared our technologies. We talked about the research and techniques. And we also discussed the need for an open virtual assistant. Present in that workshop is Doran Weber, who is here with us today. Thank you for coming. all the way from New York, and Doran is from Sloan Foundations, and he came forward and give us a very generous support to help convert, the technology, the research results that we have developed using the national, with the National Science Foundation grant, and convert it into something that we can actually demonstrate and show, okay, which you will see later today. And also earlier this year, we received a very substantial grant from Vincent Chang, who donated the money through his Verdant Foundation. And because of that, we were able to hire a very good group, a very small but talented group of engineers to help us productize the research efforts. So we're very excited that we have a chance to take this technology from just the university to the point where we can put it in the hands of developers and and companies and so forth. So we have been, in the research, we have been working on this virtual assistant called Almond. And at that time, we have a design where we have a centralized repository of skills. Very much like Alexa and Google, they have a centralized repository. But it is open source, it is available for everybody to contribute to. And I was a little bit concerned about the scalability of such a design. But about 3 months ago, we just realized it's like we don't need to centralize it. We can keep it open and decentralize it, and hence we coined the term the World Wide Voice Web. Okay, if you think about the World Wide Voice Web is where you can get the voice content, and the virtual assistant is like the browser to this voice web. It's like through the browser you can now go and visit, go talk to different voice agents from different companies. And we're very excited about the idea, and this is why we organized this workshop to bring people together to think about this topic. And I want to show you how this can happen. This is very, very early. This is kind of like the first time we talked about this subject, and I hope that we can get a lot of people excited and help build this decentralized voice web. So to start, I'm just going to say something about the voice from a technologist's point of view, okay? This is really the third interface the computers have. It's only the third one. The first one, of course, being the terminal and the keyboard, right? And with the introduction of personal computers, we have the bitmap displays and the mouse. And that has been with us for the last, 30 years. And what we have is WIMP, okay? Windows, icons, Windows, icons, menu, and pointers, okay? And we've been using it for all these years. But now the computer is finally learning the human language. It's not us learning the computer language. It's the computer learning our language. As Chris said, this is how we communicate with each other. And it is going to be transformational. Today, you can look at our technology. It's a little bit clunky, and it doesn't do very well all the time. But with the advance of deep learning, I am very sure that it will just be a very natural thing for people to do when we can interact with computers. And if we look back, I would say within 10 years, we look back and we say, what is this WIMP thing that we had for so long? Okay, so we're very, very excited about this opportunity. And today, of course, we have all been using the World Wide Web, and now we can start thinking about the voice web. And Alexa kind of showed us what a voice web may look like, right? And you can think about the virtual assistant as like the browser, as I said. It's really the gateway to the voice web. And Alexa is not just a device that you can talk to Amazon with. It is a platform. And today it has 250,000 third-party skills. Google also has a platform, and they have over 1 million actions, okay? For each skill, there can be multiple actions, so it is kind of hard to compare, but they are really both very large platforms. And they do everything, from telling jokes, playing games, weather, answering serious questions, shopping, banking, what have you. Okay, it's just like what we do on the World Wide Web. And I took the numbers of what happened in the last 7 years since it was introduced, and you see that there is quite a growth of skills over the years. And as we are thinking about the World Wide Voice Web, it would be interesting to compare that to the World Wide Web. So I also plotted the growth of the World Wide Web in its first 7 years. Okay, what is interesting to see that it's at the very beginning, Alexa on its own grows faster than what we've seen in the World Wide Web. But by year 5, you can see the web growing. You know, it's bigger than what we had in Alexa 5 years ago, and the growth of the skills on Alexa are slowing down in the last couple of years. But if you look at what's happening with the World Wide Web, it just goes exponential, and there is just no stopping it. And now we have billions and billions of websites. And that's what we get to look forward to, I believe, if we decentralize and open it for everybody. So why is there such a difference between Alexa and the web? I think that there are 2 main reasons. The first one is that voice is much harder. It's not like everybody just put up the information on the web page. It is much harder. And Amazon has the AI technology, and they make it available so that a second party just simply put in basic information about how you connect to their APIs, and it will automatically, and Amazon provides the AI. Voice is difficult, even with the resources Alexa have. Currently, Alexa speaks only like 8 languages. So there is a limitation due to the technology. There's also a second very important difference, is that Alexa is a proprietary platform. It has control over what Alexa does, and it is pretty clear that it is an intermediary between the users and the businesses that connect through Alexa. And clearly, it can exercise self-preferencing. So for example, if you just say, I want to buy some toilet paper, we know where it is coming from, unless you explicitly specify where else you want to have the the product be purchased. And we also see that Alexa, like Apple and like the Google device, is charging 30% of digital goods sold through Alexa, and we understand it was like 15% for Google. So this is a platform. I mean, they provide a lot of good services, of course, behind it, and they also have, it's a platform that they control. It's just totally different from the World Wide Web. So what we envision here in the World Wide Voice Web, it is just like the web, it is open and decentralized. Everybody can put up their information, okay? Instead of web pages, we call these the voice agents, okay? And the browser is like the virtual assistant. And what we envision is that every website can put up its own voice agent. So for example, if I say open NPR, it will connect to the NPR's voice agent. And how do we do this discovery? We can just leverage the existing web. So what we are proposing here is that we use a well-known URI so that when we navigate to npr.com, we can just follow the link and we find the information about the voice agent. Okay, there is no need for a centralized repository that you have to go through in order to reach the different voice agents. We can just leverage the existing web infrastructure that has already been built up. So every company can put up its voice agents. But we just said it is really hard to create voice agents. We can see some largest companies doing them and putting them up. So this is where we come in as technologists, is to make that easier. So we have developed in our lab a very different way of building voice agents that don't require that doesn't require as much of an investment in both resources and manpower to create these agents. And besides putting this technology available for everybody to use, we also came up with this concept of a pre-trained agent. So we can pre-train an agent for a domain at a time and make it available as a default for anybody who wants to leverage that. So imagine that there is a pre-trained restaurant, food ordering agent. All the different restaurants just put up their menus and the API on how you can purchase, order online. Then we will have a generic agent that will converse with the users and make the order. So companies don't actually have to individually build their own voice technology. And I think that this will help make the technology, the voice agents, be easily adopted in practice. And for the browser, we have developed the Genie, which is an open source virtual assistant. It allows you to access all the agents in the WWvW, but it also have the most popular built-in skills, like playing music and getting weather and reminders and so forth, okay? And this is all open source. You have the open source client, open source cloud, and this will be just available for everybody to use in their own products. So what does that mean if we, with all this technology here? What we can see here is that if the technology is openly available, it would just enable voice services anywhere. Today, the smart speakers are in our home managing our IoTs. There will be solutions that will protect privacy, where information from the IoTs would just go local, be accessible through your own home with your own local gateway. Right? It doesn't mean that you have to use the local gateway at home. You can also tap into it as you are moving about using your phone or your AirPods and so forth. We also expect to see a proliferation of these speakers. So for example, you can imagine the cars, the hotels. These are great locations where you can use the help of a voice assistant. And with this open source technology, what this means is that these different companies can have their own specialized features, like talking to the hotel concierge or checking the tire pressure and so forth. But in the meantime, it is sitting with the open source software that allows them to tap into the World Wide Voice Web. So while you are driving, you can ask about the restaurants and where you're going to go, what is the weather, what is the traffic, just like what you are seeing on Alexa and Google today, except that hopefully with an open platform, we will even see a wider adoption and even more services that are available through the voice. So that is the industrial ecosystem. One of the driving motivations for this work is that we want to make this technology available to support consumer privacy, equal opportunity, which is two things that we kind of mentioned already, but also global inclusion and accessibility. And we see ourselves as a part of the open source, privacy-minded ecosystem, joining the Home Assistant, which is a private local gateway. We will talk about more. Other organizations such as Mozilla Voice, and of course, Wikipedia, the open knowledge repository that is open to everybody and every language. But with voice, there are a lot of social good projects that can be supported with this. And one of the topics that we have been exploring is how to use voice to address the information problems that we have today. How can we use dialogues to address information polarization and address the misinformation problem? And we are very, very happy to announce that the Sloan Foundation has given us an initial grant towards working on this open voice ecosystem. And you will hear today in the panel organized by Anne from experts in this space and talking about how voice can be used for information. It is also can be used for many other services, like humanitarian services. There are a lot of people who don't even know how to, who don't have access to the mobile technology because they cannot read the phone book and so forth, for example. And voice is a way for us to reach them, and because it is just a universal medium. And we also looked at, these are just topics that we believe will benefit greatly from voice, such as how we help the poorer families with preschool children education. How do we get to low-resource languages? How we do give assistance for the blind, illiterate, as well as the non-literate. If we just leave it to the profit-based organizations, we may not be able to get to these kinds of projects. So this is why we are very excited to make this technology available for everybody so that we can have global inclusion and accessibility. All right, so what have we got here? Genie is an open source privacy-preserving virtual assistant. It is available on the web. But more interestingly, it is also available now for the first time in a smart speaker appliance. And we're very happy that we have Baidu, who is our partner that supply us with these smart speakers. This is their product, and they have removed they have unlocked it so that we can put our own software on top of this device. And they have generously provided us with these devices free of charge. And what is also interesting is that we are talking about how we can potentially make it available so people can purchase them and do projects on top of them. So it is available on a smart speaker now. And the other thing that we're very excited about is that our virtual assistant has been bundled with the Home Assistant Local Gateway. It is one of the top 10 most popular open source projects. It has over 100,000 members in the community. And it is a local gateway. That means the IoT devices are just reporting locally on the device at home. It doesn't take it to the cloud. And because of the interest and the collaboration that they have garnered, it's controlling over 1,000 IoT devices. And they are shipping our assistant as the default voice interface to their community. So we will be seeing a demo of the Home Assistant and the Baidu smart speaker in a little bit. Okay? So what does Genie do? Well, Genie has the most popular skills like music, podcasts, radio, news, restaurants, search, weather. Of course, we have to tell jokes, reminder, and timer. As you can see, it does most of the things that people want. But there is more. It also, of course, handles the Internet of Things. And today, it can handle 15 different kinds of appliances and sensors. What is also more interesting is that these skills are all open source. They are available and for everybody to use. It is also designed in a way that you can substitute the databases with another company's databases, APIs with another implementation. So whatever we are doing is open source and applicable if you have similar services. So the concept here is that if we can standardize on the APIs and the databases, then all the work that we are doing in training these agents can be reused across the industry. So for example, we mentioned that we have mapped to 15, we have now the voice control for 15 abstract kinds of devices. With the help of the Home Assistant community, we are now controlling 700 different IoT devices. Okay, so in other words, we do we have the voice interface for one kind of device. It is open, so if everybody can just implement the same abstract APIs, they get all the voice control for free. And it is not just for IoTs, it is good for all the different skills that we have created, from playing music to searching news. And so this is what we've got, and this is really just the beginning. And we are working on other domains. So one project that we have, that my students are working on, is a ordering interface, so that we really want to help out the restaurants, which are all mostly low-margin businesses. And we can give them a a voice assistant that is just totally open. It doesn't take a cut on every dish that they sell. So that's the idea behind behind these open pre-trained agents. So what is Genie? I want to make sure everybody knows that with the little team we have, we are not building a consumer product that can rival the Alexa and the Google. Well, at least not yet. Okay, but with help, given that it is open source technology, we may get there. But what it is that we have a very small group of PhD students and engineers, and our focus is on the tools and standards. The goal here is to remove the technical barrier to entry to dialogue agents, making it available to everybody, and we will work to foster collaboration. Universities are a great way for doing that, okay? Because when we say this is open, we're not going to turn it around and say, oops, now I need you guys to pay for it. Okay, I'm going to close it. What we want to do is to keep this in the university until the point which it can be self-sufficient. And I believe that there will be startups that will support open source software, just like we have Red Hat for supporting Linux and so forth. So that's the idea. So if we can get the collaboration going, then we can scale to the WWvW. So those are the 3 steps that we have to take. All right, now let's go down to the next level. So that is what Genie is about. And so what we are building is the first end-to-end open virtual assistant experimental platform. As Chris mentioned, I did a lot of work on compilers in the earlier days, and my group built the first popular research compiler. And this changes the compiler field from theoretical studies to absolutely an experimental discipline. And the students that we graduate are ready to take on commercial jobs and building the compilers with state-of-the-art. This is what we want to see again here. There are a lot of researchers, and we are playing with different parts. It is very important to have one experimental platform where people can actually see what happens when you put the virtual assistant in front of real users. Then you are talking about the real problems that we don't see in academia. And by having this platform, it will change the speed at which we can improve on the assistance, on virtual assistants. The second thing here is that Genie is not just a copycat. It is just not an open source version of what is out there. It has very new and advanced deep learning technology. It has 2 claims to fame. The first one is that our agent is built to support dialogues from the get-go. It uses a single neural semantic parser that parses the user input. Today, if you look at dialogues, most of the systems out there are built with intent classification. Every step on the way, the developer has to say, I expect you to say these 3 things, or 5 things, okay? And if you go beyond that, it's like, sorry, I cannot help you, and it repeats the menu again, okay? But what we have is a semantic parser that allows you to get out of turn. It's not exactly what you expect, but since it is a one unified semantic parser, I can understand you when you say you want to ask about the weather as we are talking about hotel reservation. We can handle that, okay? That's what a neurosemantic parser can do for us. The second claim to fame here is that we see virtual assistants as a way to automate tasks. A lot of tasks that we do requires us to look at different websites. Suppose I want to pick a restaurant that I can get to quickly. I have to look up Yelp, and then I have to look up traffic, all right, to figure out what is the traffic like to the different locations. And here, with voice, we can start programming our assistant by referring to these things in just natural language and automate the tasks that individuals have. So these are the 2 main things that we have done that is not available in commercial assistants. We laid the foundation so that there can be a lot of research on top of the assistants along these 2 lines. So what have we got? We have built a full stack system. It was a lot of engineering, I must say. This would not be possible if not for the grant we got from Sloan and from Verdant. The we have a full audio stack, which includes the acoustic echo cancellation, voice activity detection. Then there is the WIC word. The WIC word is a lot of technology in the WIC word detection, and we are very happy to say that we have Pico Voice, a leader in WIC word detection, as a partner. And they were very kind to support the open source effort, and they give it to us license-free, and we can use it as, in our open source software. And on top of that, we have ducking, which says that when I start talking, you have to lower the volume. These are all the technical details that we wouldn't have gotten to if it is just a pure research project. And for speech-to-text, text-to-speech, we are using Microsoft, which is the state-of-the-art technology in this space. So that's the audio stack. Our focus is on the dialogue agent itself. Let me walk you through the main modules. Our system is a little bit different from others in that all the information about dialogues are represented in a formal language called ThinkTalk. It's a language that we invented in our lab, and it is the first virtual assistant programming language. And what it does is that we expect the neural network to translate the natural language directly to executable code, okay? If you want to query your database and execute operations and so forth, you say it in natural language, the neural network takes it to code, which is executed by the agent. There is no intermediary, and it also means that whatever the agent can do, we can represent, okay? You get the completeness. So we translate the natural language into ThinkTalk. The ThinkTalk, we have a ThinkTalk JIT compiler and runtime. The results are then used by the agent to decide what it does. And all the dialogue context is represented formally. We update the context at the end of the agent turn, and it is fed back in so that we can interpret the next user input. And this is why we can handle dialogues, okay? So this is the first time we are using a contextual neurosemantic parser for dialogues. So I want to just talk a little bit about ThinkTalk. And what we want to do is to propose this as a common representation. Having a common representation is very important for modularity, reuse, and interoperability. And as we mentioned, it is an executable programming language. It does database queries, API calls, programming constructs. It's complete, and it's also extensible. As the virtual assistant grows in its capabilities, we have to extend ThinkTalk. And we have extended ThinkTalk beyond transaction dialogues to handle on-the-fly customer support and interoperability across vendors and interoperability across assistants. So we mentioned the concept of pre-trained agents. Let me explain what it is. Okay, so we say that it's an agent that can be used for different instances of the same business. But the important thing is that we actually have a generator that helps you generate these pre-trained agents. So Genie, the pre-trained agent, allows you to supply APIs and databases, the schemas. You provide this information, we automatically generate you a dialogue agent. You give me databases about restaurants, I talk restaurants. If you give me hotels, I talk hotels. If you give me songs, I talk songs. As you see here, there is you don't have to hand code the dialogue one at a time. And this is very, very important. And how do we do that? So I'm going to go down the next level and talk a little bit about technology. If you're interested, there is a lot more details in the tutorials this afternoon. So here is the high-level idea. The way we managed to build this assistant with such a small group of people is because we synthesized most of the data. In order to get synthetic data to work, the data has to have very high quality. And how do we manage that? So the first thing is that we said we have a generator for different domains. We discovered that a lot of these domains would share the same abstract state machine. At the beginning, you say, hello, how are you? I want to do this. And they say, oh, you want, you start talking about what you want, and the agent looks up the databases and say, do you mean this? Or how about this? You kind of discuss which restaurant or which hotel or which song you want to play. And then you say, okay, would you like me to book? Would you like me to play? And then the user can choose to cancel and whatnot. That template turns out to be the same across all kinds of different domains. And with this information, that means that we can now create an agent where we take a generator that takes the abstract dialog state machine that I just kind of showed you quickly, and you can supply the different domains, and we just generate a lot of training data. Okay, so that's the basic idea behind how we build our system. The important thing is to generate high-quality training data, and for that we have two ideas. The first thing is that we have 900 English grammar templates. We automatically synthesize all kinds of questions: who, when, where, different expressions. It's like Japanese food restaurants that serve, or Japanese restaurants, or food that serves Japanese food, and so forth. We generate a lot of different expressions in different POS with just grammar, okay? We have 900 of such grammars. But you may say, hey, wait a minute, this grammar-generated stuff is usually very, very clunky. So to that, we turn to the latest state-of-the-art in natural language processing, and that is the pre-trained language models. There are a lot of pre-trained language models that understand language. They don't have the semantics. They don't know what they are saying, okay? But they know what words and phrases are similar to each other. So what we do is that we take the synthetic sentence and we feed it through these paraphrasers. And the one we use is BART-based, and we get back paraphrase sentence that sounds very natural. And this is the training data that we have. So this is how we synthesize the high-quality dialogue data. We also have to put in a few shots of annotated data. This is because natural language is really tricky, and this few shot is very significant. What that means is that we still have to do a little bit of manual annotation, but just a very small amount of it. That's the first big idea. The second idea here is that we are using a semantic parser that is fine-tuned, again, on pre-trained language model. So we don't really have to generate the world of data because the semantic parser trained on this model can understand equivalent expressions as well. And this combination is how we were able to build our agent. Let's look at some results. These are some experimental results that we published in our academic papers. So let's take restaurants. A lot of assistants help with restaurants. And what we show here is a pretty complicated test. We are not just asking what is the restaurant near here. We come up with some more complex questions, like what is a Spanish restaurant that is still open at 10 p.m., okay? That requires you to do more than just giving the answers, restaurants near here, okay? There are so many combinations that our synthetic approach, the approach to synthesize data, really shines. And as you can see here, it's like Genie can actually do better than a lot of these commercial assistants when it comes to the more complicated sentences, complicated questions. And I put some examples up, and you can see that they are, they are natural for us, but from the computer's point of view, it is a little bit more complicated. Okay, and that's where we are today with the technology we have. We talked about dialogues. There is a very famous benchmark called MultiWAS, and it has been around, and everybody was trying to solve the problem. To understand what is being said, it is a Wizard of Oz. That means it was two humans pretending that they are agents and users making the conversation. And it turns out that we didn't have a good answer for this in the past because all the the techniques are based on manual annotation. And we discovered that there were serious errors in the annotations themselves. With our effort, with our approach, we are synthesizing a lot of these combinations, and everything we synthesize is perfectly annotated. And this is the reason why we can get the best turn-by-turn accuracy of 80%, which is much higher than what everybody else is doing, using very expensively annotated data. And we do only about 2% of the original manual annotations. And it goes across the various domains in this benchmark. So what else? Well, we talked about the World Wide Web. Then we have to handle languages, okay? And if this is all the work that we have to do just to make English work, how are we going to get to other languages? And how are we going to get to low-resource languages? So what we show you here is an example, is like when it comes to, say, just restaurants. It is not just about translation, because every country has its own food, has its own locations. And now, how are we going to get the training data so that we can serve the people in the different, for different countries and different languages? And what we have added into our pipeline of synthetic data is multilingual support. We are leveraging neural machine translation. They are readily available. If you look at Marian, which is an open source translator, it works for 555 languages. But I have to caution you, is like a lot of these translators do not have very high quality. But it is open, it is available, it just is a matter of time for the community to help improve these translators. So what we have done is to show a cost-effective way of doing localization. We translate the English training data to the different languages, and we substitute the local entities. So it now learns the food, the locations, the actors and singers of different regions. And this is possible because we are using ThinkTalk. The ThinkTalk representation is source language independent. You just have to substitute the entity name. It is how the computer accesses the databases, and it will all work. And that means that when we put out our pre-trained agent on restaurants, I don't really care whether it is English or Chinese and so forth. You can put up the information, and if we do, with the right training with ahead of time, we can now serve the information across different languages. So we translate automatically. We add a few shots of manually translated data, and we got to about 5 to 70% of English on restaurants with just about 1 day's worth of professional translation support. So this is very, very promising. And we believe that this is the way for us to make voice agents viable for low-resource languages. So let me summarize from what we have been talking about technically. The Genie Assistant is really a demo of new principles. It is not ready for prime time. And it is built with just 13 people, 3 part-time people. And there are 2 basic ideas. The ThinkTalk virtual assistant programming language is a formal interface between human language and machine. And it supports task automation. I will talk more about that in the afternoon. I don't have the time to do it now. And we are hoping that this can become a common representation that allows everybody to work together. The second idea is how we can do scaling with this multilingual pre-trained agent generator. The concept of a pre-trained agent means that I build it once and applies to different companies of the same kind. We also have a generator to help you create these pre-trained agents, and we use automatic training data translation to get to different languages. So that's a summary of what we were talking about technically. It's very, very high level. More detail is in the afternoon. So what does that mean? Let's take a look at the ecosystem of all the different kinds of companies that have something to do with voice. There is at the bottom the chips and the connectivity. There's devices and sensors. There are lots of companies, lots of players. Then there is a system gateways of many kinds. And also, of course, the content provider and the commerce that is performed on top of that. This is what is available on the web today. But when it comes to voice, we have to access it through these two major players, as they in America, which is Alexa and the Google Assistant. So this is where we are today. What does our technology do to this ecosystem? In WWvW, Genie is not yet a third player. It is just a component. We have componentized it. And you can embed Genie anywhere, everywhere you wish. Okay? It can be used to build agents. It can be used to build assistants. And so with that, we see Alexa and Google being they will remain two major players, but there will be other players as well that will deliver these virtual assistants. And the good news for the content and providers and people doing online commerce is that there are many more people that they can reach. And it is with open competition, then there will be more of a fair competition that they can have instead of what we have today. So what do we have to do? There are lots and lots of work to do. There's standardization. We are planning to submit an IETF RFC draft on how we can use well-known URI for voice agents. We want to standardize on the think-talk representation. This will allow everybody to work together. We want to create more standardized abstract schemas and APIs. Today, we are using a lot of the information, a lot of the standards in Wikidata, in schema.org already, and we want to push that forward. So I see WWvW as a time for us to do a lot of standardization of schemas. Okay? We have to continue the work on the research and development on Genie and the tools. We have identified a lot of very important research topics from error recovery, multimodal assistance, more agent initiative, and adding empathy to our assistants. And we have to grow the ecosystem. And this workshop is just absolutely just the first step. And so I have a call to action here. Is like I want to appeal to everybody here listening to join the ecosystem so that we can absolutely build this WWvW. I want to say that this work, what we have done, has already been supported by a good number of partners. We have mentioned a lot of the parties here. Brave is a private search engine, and they're providing us with the APIs. AlphaVantage is financial data. Baidu with the developer kit. Home Assistant is our partner in the gateway. Pico Voice has generously, they are a small company, and they have generously supported us with this license-free wake word for the open source project. Smart News allows us to provide news free of charge to our users. And they have also put in a lot of engineering power to work to make this happen. And also Yelp, they give us more extended free access to their APIs and even getting to information that is not normally available without us paying a cent. So we have great partners. And again, I want to thank our sponsors, the National Science Foundation, the Sloan Foundation, Verdant Foundation, as well as the Stanford Human-Centered AI Institute. And we also want to thank ServiceNow, which is sponsoring part of this workshop. And, of course, I want to thank everybody I have put the entire core engineering team up. Okay, it is a very, very small group. You have the 5 PhD students. I think they are all here today. And then we also have an engineering staff. We are very excited that Tony Espinoza has joined us full-time as the Managing Director of Social Impact. And he also brought along Neil Souza, his co-founder, in one of his startups. And the two of them absolutely led the charge to make this engineering effort happen. And we also have very a good support from the engineers, as we show here. Now, and he is going to walk us through the demos. So Tony is an entrepreneur. Both Tony and Neil have been in the Silicon Valley, and they have launched various products successfully with new technologies. And he has joined our lab to help us make the social impact. So Tony, please take it away.
All right. You know, when I was actually an undergraduate at Stanford many years ago, about 30 years ago, and I loved going to lectures because the professors were so passionate about everything they had to say. They were living and breathing this stuff. So, you know, being here again in that sense is. So I just want to tell you a little bit about myself. We're going to be setting up a couple little things while we get ready to walk through some of these demonstrations. Context for me, so that you have that. I think context matters. I'll be kind of coming back to that again and again throughout the day. But in general, I have done a number of things since I left Stanford in 1992. I've worked at 3 big tech companies as either a PM or a VP, driving product and shipping products. I've also started 3 companies, had 2 really strong exits. And for me, you know, it's like life is kind of cyclic. Have you ever feel like you've been here before? You know, I have been at Stanford before. And the more things change, the more that they sort of stay the same. I initially left Stanford to go work at Apple. And working at Apple at that time meant cutting edge technology. It meant things like working on an ARM32 processor, the very first one that came out of Apple back in 1993. It meant working on a new object-oriented data store and a new programming language. In other words, it meant a lot of the same things that I'm doing right now, all over again, in a new context. At that time, it was a product called the Personal Digital Assistant, one of the very first ones that ever came out. And we were basically the ones that pioneered the concepts that led to a lot of what we have these days on all these new platforms. My boss at Apple, who I loved, who's still there, super inspiring guy, did the iPad, the watch, what have you. He used to say, this is think back, 30 years ago, we would say that the stuff we were working on was going to change the way people lived, worked, and played. That's what we used to say to ourselves. That's what got us up in the morning to go to work and build these things. And on one hand, it's happened. It's amazing. You know, if you want to put the next slide up for me. But I think that looking back over 30 years, we've seen a series of things happen. So we started off making platforms. We went to distributed computing. We went to ubiquitous computing. We've got social, mobile, all these other things. It's become a part of every aspect of our lives. And I think the way that we learn, you know, when you separate our actions from the results by enough distance, it's hard to learn. But, you know, as Kierkegaard said, I think we live life forward, but we understand it backwards. So looking back over the last 30 years, I've realized while a lot of things have gotten so much better and are working and are amazing, we've learned some things about what it means to open these systems up. And these days, I think that we all know that most of the internet is driven off of this predicate of kind of mining data. You know, I think the analogy I've heard people use is that like data is the new oil, and we use AI to extract value out of it. So what does that mean for us as people? What does that mean for our privacy? Do we still have privacy as a choice? Or is it something that's, you know, well, I don't know if I have a choice. Will my children have a choice about it? And what that says to me is that technology is a tool. You know, it's a formative, incredibly powerful tool, but the people using it have to have an idea about what they're doing with it and what their purpose is with it. This mission statement here, for me, this is a quote from Aldous Huxley. I'll read it to you real quick. By these means, we may hope to achieve not indeed a brave new world, no sort of perfectionist utopia, but the more modest and much more desirable objective of a genuinely human society. So as technologists, for us to be able to accomplish that, it's not going to happen by accident. It's not going to happen through capitalism alone. It's going to happen because people care about the result being not just technologically utopian, but actually human. What does that mean? So this is the kind of thing that we think about in the lab a whole lot. And as I go through the demo, you know, I think that Monica covered a huge amount of stuff, and I'll explain kind of how I got involved at the beginning. But I want to kind of get some demos, starting off with Jackie Yang, I knew I'd do something like that. He is one of the really inspiring people on our team that crosses domains. He works with James Landay in human-computer interaction, and I think his real passion is for multimodal AR, VR experiences, but that means that he also is quite a kind of a wizard, actually, at putting systems together that span all this stuff. And he's been kind enough to offer a glimpse into his apartment, or dorm, where he actually has quite a sophisticated setup that employs Genie in his house.
All right.
Shall we take a look?
Sure. Should we start with like Genie stuff? So
Yeah. So inside of the web interface for Genie, we actually have a little cheat sheet. You can click on it in the upper right-hand corner. And I just thought it would be kind of neat to scroll through this and take a look. Huge range of different, you see the headings as they scroll past for different devices. Some of them are skills. There's a bunch of parameters in there to give you a sense of the kinds of things that are built into those skills. And a lot of these things, actually, it's kind of scary. Jackie, how many IoT devices do you have in your house?
like around 50.
50 devices in your house. Okay, that's pretty good. And what kinds of things do you have going on?
Yep. So this is my dorm, and then this is like an overview page I built with Home Assistant.
And what are we looking at here? What is this?
Yeah, so like I basically separate each one of my room into blocks in this web page. So there's bedroom, living room, bathroom, and then this is a little part about outside stuff. And then for each one of them, you can see like there are sensors, like this is bedroom humidity, bedroom temperature, air quality, lights, a bunch of stuff. And then there's like door, whether it's open or closed. And here's something that you can actually actuate. I can, for example, turn off my bedroom's light, and then if you go back here, it's probably going to turn off very soon.
Just to give you some background, so Home Assistant, if you're into IoT, there we go. It's like the ultimate Lego kit for being able to build, put all the connections together, and also to control the stuff. This dashboard is part of what they enable. I think Jackie actually designed this using the little Lego blocks that Home Assistant provides.
Yep. In fact, that's not now the only way that you can integrate all the stuff that currently only supports, let's say, Alexa or Google Assistant. Now you can support all of them in this one system. And what's really great about it is Genie supports it. So once you install Genie on this, it's really easy. It's like just to click install, and Genie will support all of the different type of IoT devices that you have at home.
And how does this relate to like privacy? Like, can you give us a hint into how this system is unique in that regard, as opposed to just hooking it all together with Google Home or Alexa?
Sure, I can have like a demo video.
Okay, awesome.
Yeah, so this is me working on the street, and then as everybody knows, in California, summer can get quite hot, and then this is a particularly hot day. And then I can pull off my phone, and then I can use this Home Assistant app. Now has Genie embedded once you install Genie. And then I can ask, what is the temperature in my bedroom? And then this will pops up and it tells me it's a little bit hot. And I can say, open window blind so that it adds a little bit more air circulation. And then it will actually communicate with Genie and then open the window blind. What's unique about this experience is that regularly with like Alexa or Google Assistant, when you're doing that, you have to communicate through cloud. Some information got sent to Amazon's cloud for processing. Whereas what we are doing right now with Genie and everything, because it's very decentralized, everything is actually hosted right back to my dorm. So I'm talking directly to the Genie server in my home, and no data got leaked into. Apart from the voice recognition part, no data actually got leaked into third parties.
Awesome. I think you've made a couple of other videos that demonstrate this stuff in action.
Yep, and then there are like the regular stuff, like controlling lights. So here's a quick demo on that.
Neil, do we have the audio up on this one?
I should have, but like for some reason it didn't work.
I'm not hearing it.
Okay, but I'm saying Genie, turn on the lights. And then this is me studying, right? Like as a graduate student, I study a lot and always forgot to rest and then stretch out. So here I'm saying, Genie, turn off my desk lamp in 15 minutes so that it will turn off my desk lamp and remind me to relax a little bit. Well, actually 30 minutes, I think.
I think it's just fun to see Jackie working, actually.
Yeah, so like 30 minutes later, Jeannie will say something like, I forgot, like your trigger has like arrived or something, and then it turns off the light, remind me to stretch a little bit. And then one more very interesting thing about Genie is that like if you use Siri or Google Assistant, it allows you to do some programming, right? But then the programming is all done in a GUI interface, which means that you have to say, you have to like at the end of the day, you think about it, like, I have those devices, these are the stuff I might be able to do. You have to think really hard to say, then I can program it this way. Like apart from like a very, very few extremely enthusiastic user, nobody's actually going to program it. But with Genie, and then as Monica mentioned, we can program with natural languages. And this actually allows us to program while you are in that situation. So here's a demo of that. So I walk into my bathroom. I forgot to turn on my bathroom ceiling fan again. So the room is getting really humid. And then with Genie, I can say, so here I'm saying, Genie, what is my bathroom humidity? Genie tells me it's like around 55%. So then what is interesting is I can decide to program on the site. I can say, Genie, turn on my bathroom fan when my humidity is about 50%. And then Genie will say, okay. And then I can think about, what will be a correct threshold to turn off? I said, Genie, turn off my bathroom ceiling fan when the humidity is below 40%. And then later that day, what can happen is like if I start bathing again, and then there's a humidity sensor. So like here, the water is turned on. And then there's a humidity sensor on my wall that can detect this humidity change. And then it can automatically turn on the ceiling fan as is shown here. And then later, once I turn off the water, as humidity drops, the humidity sensor will detect that it's below 40 and it will automatically turn off the ceiling fan. So basically, the uniqueness of using voice to program allows me to do all of this stuff while I'm in the situation, and then that's make it much easier for everybody to do programming in their home.
That's awesome. I mean, I'll just reiterate that for a second. What we're talking about is what happens when it becomes voice-activated, controlled, programmed. Some of this project actually was born out of end-user programming as a goal and opening those doors. And when we're talking about IoTs, things in our life, our cars, all of these things, it's very experiential. It doesn't really, can you imagine sitting down at a dashboard and looking at some graphs and deciding how to set up your ceiling fan? Some of us would do that. But it's way more natural to walk in the room and say, this is too hot, this is too moist, what is it? Okay, set it lower. And just let the computer figure out how to do the right thing, is kind of the concept.
Yeah, exactly. This is the dashboard. I don't think anybody in their sane mind will look at this and start programming.
Quick question?
Yeah, what about authentication? What if somebody else walks into the room and set up the room?
It's a great question. I don't know who's going to walk into my bathroom, but it's something that we'll have to figure out, I think, as we go along. What level of authentication, what are the keys, what are the mechanisms? Are there multimodal mechanisms like the awareness of your presence with your phone in the house, things like that? There are different ways that we might be able to key it. Awesome. Okay, let's move on. Thank you very much, Jackie. We're going to do a little quick setup here. This back up. Okay.
Hey, Jeannie. How are you doing?
Great. Thanks for asking. How can I help you?
Okay, great. All right.
Just a second. We're going to get this in too. Do you want to...
I'm on my slide, yeah.
What? Let's just mute it till you start talking to it. Go to the finance slide first.
We can go start right into it. Okay, so what I want to show you next, obviously, I think one of the things I've learned going from, industry back into academia for a moment here, is that in industry, there's a lot of transactions. And when you think about what a product is, you think about well, what do I get for what I'm paying, right? In academia, it works a lot more like a community, really. And in a community, I think that the definition, the currency, is not what do I get, but what do I give. It's really about contribution. You do something you believe in, you get behind it, you put your life into it, right? And so being in this environment, it's been interesting to think about, like, I reached out to Monica in December last year to check in. I was introduced to her by one of those VCs on the plaque over there many years ago. And I was looking at her keynotes. Some of you have seen some of those, looking at the site and just being like, wow, what she's doing is fundamental, could fundamentally shift the way that things evolve in this category of voice and interactivity online and access to content all over the world, et cetera. Sounds amazing. We went through all the technology a little bit, got a feel for like how complex the project was. Try to imagine in industry what you might invest if you were one of the big companies. Do you put 100 million in? Do you put $1 billion in? You know, even if you were a small startup, you go raise $30 million to do something like this. And so I asked, I was like, wow, you must just, this must be amazingly well funded. She's like, we do have amazing academic funding. How much do we have? It's like $1 million. It's like, okay, wait a minute, where am I? What year is it? But of course, I said it's an amazing challenge, honestly. It is also a testament to the technology. The technology, what the grad students have come up with, what Monica's come up with, what other professors have contributed, really is a game changer, right? To be able to tackle the big data problem, right? I did my first angel investment in a AI-based startup about 2012 or so, and of course, it didn't work out so great. They couldn't get the right data. They couldn't get the right amount of compute. It was $1 million a month to run the model. It just fell apart. It would be a completely different story if they were using the kind of technology we have. So I just want to tie things back real quick before we go into this demo to, I was an angel investor in a company called Napster back in the day. And when that system opened up, there was a saying that we kind of let the genie out of the bottle. You couldn't put the data back in the hands, the corpus of content, back in control of the people who control it. That brings me back to the privacy question now. Is the genie out of the bottle? And I think technology like this has the opportunity to reinvigorate the whole concept of what is privacy, who has control of the data. You asked the question about authenticating users. This is all the stuff that we live and breathe here. So back to the community concept that I brought up at the beginning. The way that we've been able to build Genie has been with the incredible support of, I think, like-minded companies, all sizes, huge companies, small companies, but companies that get that the value that they're contributing here is to something much greater than them. It's to something more than their bottom line, I would say. It's actually to the progress of all this technology and its ability to make a more human society. So Baidu provided this hardware to us in the form of a development kit. We're excited. I want to take a picture of the class 224V is going to get these things next week and be able to be building on this platform. And then we were looking at other opportunities to roll it out further to more developers that want to work with an embedded platform. We wrote our own C++ client here. Thank you, Neil. Thank you, Antonio, for all the hard work on that. And then it uses the same backend that we can access from the mobile phone you saw that Jackie was talking through a mobile phone device. It could work on any other platform. The other company that made this possible with an amazingly generous support was to give us a wake word capability for Hey Genie that I'll demonstrate today, and that is Pico Voice. So Pico Voice has an amazing platform that I highly recommend you check out. There's a developer console. You literally can go up, type a wake word that you want to try out, and download it right down to your phone or to a mobile device or to another ARM SoC of some sort, Raspberry Pi, for example. They support many platforms. And it's super lightweight. They're a company that is dedicated to privacy first, so edge computed AI. And yeah, I look forward to working with them in the years to come because I think they're very much in line as a community member in what we're trying to get done in the world. Okay, so the first thing I did was to try to think of how do you walk through all these different skills. We've seen a couple of them, right? We've seen Home Assistant. You saw timers. In our system, we actually call them monitors because they're kind of a system that is triggered by a condition, like when something happens, do this. And they run all the time. So you've seen one example of that. And we've got, like I said before, we had $1 million. We want to get 10 skills on a whole new hardware platform and do all this stuff. It's pretty ambitious. It also would be pretty boring to just walk through all 10 of them in one step. So I tried to think of like, what's a script that actually makes sense, you know? When I dropped out of Stanford, the first thing we did when we were working at Apple is we moved up to the city. And we all lived in this area near the highway called the Mission District. And there weren't that many software engineers there then. So I thought, like, what if we come up with sort of plan a trip to the city to go do some fun stuff? So let's see. First of all, let me get some music going. Hey, Jeannie, play my demo playlist. And I have a speaker back there that I can transfer to my Spotify account too, so that it's not blasting us here. All right, Neil. And okay, here, so planning to go to the city. You know, I was thinking of cool places that I used to love going in the city. Hey, Jeannie, ask Bing about Mission Dolores Park in San Francisco.
I found Mission Dolores Park Wikipedia. Mission Dolores Park, often abbreviated to Dolores Park, is a city park in San Francisco, California. It is located 2 blocks south of Mission Dolores at the western edge of the Mission District. Dolores Park is bounded by 18th Street on the north, 20th Street on the south, Dolores Street on the east, and Church Street on the west.
The one thing is that this is a live demo. I can't control the APIs. Bing actually gives me slightly different responses sometimes. Sometimes Yelp's API goes down. You know, the system wasn't trained to be spoken to through a mask. So the wake word is a bit of a risk. But hey, I'd rather do this than a canned demo and just show the real system. Okay, so we're going to Dolores Park, right? Let's see, what are the great places to eat? We should check with Yelp and find out what we can do for some food. Hey, Jeannie, can you recommend some places to eat near Dolores Park?
I see Tartine Bakery, Lijo Yacht Club, and El Farolito. Tartine Bakery is rated 4 stars, Lijo Yacht Club is rated 4.5 stars, and El Farolito is rated 4 stars.
All right, how many of you have been to Tartine? If you haven't been to Tartine, you have to go to Tartine. So now I only gave it 4 stars, and it kind of makes me wonder, like, how many reviews did that one have? You know, maybe I'll do a follow-up real quick. Hey, Jeannie, how many reviews does Tartine have?
Tartine Bakery has 8,186 reviews.
Okay, that's pretty serious. So that's definitely the plan. Let's go to Tartine. Let's see, what's next? But we're talking about San Francisco. Weather might be predictable, might not. Microclimates and all that stuff. So let's figure out the weather. Now, one thing I mentioned before, context matters. So on another assistant, you might go about this a little differently, but here's how I'm going to do it on Jeannie. Hey, Jeannie, what's the weather there?
It is cloudy today in Mission Dolores Park, San Francisco, California, and the temperature is 58 degrees Fahrenheit.
So that's a subtle point. I didn't mention where. It got the context from earlier in the conversation. We had established it through the thing talk. It had been passed. It's now sitting there as its reference point. Very natural, very helpful, honestly. I don't have to speak like long sentences to get what I need. Okay. Now, even better, I asked for the weather today, realizing I'm going on Saturday. And so I'd rather get the weather then. I don't trust the forecast around here. No offense to our friends that do all that fancy math to figure it out, but never seems to work out this far in advance. So I'm going to schedule it. Now, one thing to know about Jeannie is that it has a couple of user-defined slots. It knows your morning, and it knows your evening. When you first use it, it asks you. And so I have set up my morning to 8 o'clock, so I don't have to get detailed about that. Hey, Jeannie. Hey, Jeannie. Send that to me on Saturday.
All right, I will get the current weather in Mission Dolores Park, San Francisco, California at 8 a.m. on Saturday.
Not bad. So it slotted it in. I didn't specify time. It thought the morning. I'll get this weather report in the morning before I head into the city. What else is going on in the city? Maybe, let's see, when I was there, I used to love all the art stuff going on in San Francisco. Maybe we'll ask the news for what's the latest news on that. So, hey, Jeannie, tell me the news about San Francisco art.
Here is the news. Dinosaurs have next in the art of San Francisco painter Michael Curbo. Art showcase featuring resilience during COVID-19 opens in San Francisco.
Okay, so neither one of those was too interesting. I think we'll stick with Dolores Park, we'll hit Tartine. You know, and thinking back to the 90s when we used to listen to the radio, I used to listen to a lot of KQED when I lived in the city, and you can do that through Genie now. So I'll just say, hey Genie, play radio station KQED.
I played KQED FM.
Sponsorship of the KQED live stream by the Dolan Law Firm, representing people injured by the fault of others and by unlawful workplace discrimination and harassment. With offices throughout the Bay Area and LA, Dolan Law helps fight injustice. DolanLawFirm.com.
We're supporting public radio by running an
to
ad
everything
there for them.
from the literally
Anyway, so that works.
thousands of bridges, over
One more
1,400.
step. Maybe I want to wake up to the radio that morning, so I kind of have, you know, hey Genie, on Saturday, play KQED.
All right, I will play KQED at 8 a.m. on Saturday.
All right, pretty cool. Did a bunch of programming just like Jackie did, in situ, with the content, sort of ad hoc as I went along without going into any modes or what have you. Okay, one more skill to get to number 10. And that would be the modern equivalent of radio stations. It's you know, but we actually found a really cool one that's put on by KQED that we really like. So it fits the theme of like going to San Francisco. Hey Genie, play Bay Curious podcast.
I'm Olivia Allen Price, and I know you've got questions.
Where did all of the parrots in San Francisco come from?
The San Jose really deserved the nickname Man Jose.
What would it take to make Lake Merritt swimmable?
I've got a lot of questions too. I moved to the Bay Area a few years ago, and I love exploring all the things that make this place unique, wonderful, and sometimes dysfunctional.
Why does the SFMTA not enforce double parking laws on Sundays?
Bay Curious is a new podcast from KQED in San Francisco. It's a show about questions and the adventures you find when you go looking for the answers.
All right, there's 10 skills. Hey, Genie, thank you.
All right, let me know if I can help you with anything else.
Actually, I can think of one more thing. Hey, Genie, how about some salsa music for the break? Okay, thank you. Turn that off before I start talking randomly.
Yeah, I think I'm forgetting everything now that I'm under pressure here. So yeah, so we're gonna have Musa start talking about give his presentation, and then I'll ask them to talk about, let's see here, African Asia. So
Okay, so how are we going to
how they can
share this
collaborate with
path?
the Oval Lab. The next, and then I'll talk about humanitarian stuff.
Shared a slideshow before. It just play. Let's go with play.
Hey, it's like we're almost live here. But I don't think anybody else is here, so it just might be you and me.
Microphone and sit at the.
Sure, yeah, it's fine. Thank you very much for having me here today. Even though I get the privilege to present this work, it is the work of a team. I represent a team, and my wonderful collaborators are Lisa Einstein, right here, and Chris Pitt. We did a lot of this work during difficult times when COVID was at a very rough stage, and while there were political unrest in Guinea. Despite all those challenges, we work across the globe to make this project a reality. So I'm very honored to have the privilege to present it to you today. I met Lisa at an airport. We ended up being really good friends, and we started GNCode together, an organization focused on teaching CS in Guinea and in West African nations. Lisa introduced me to Chris. I loved working with Chris, and now he's my advisor. Without further ado, we are going to talk to you today about why AI needs to understand all the world's language. And we are going to do that through the story of two people, Ibrahima and Mariam. As a bonus, we are also going to show you how we built a very simple virtual assistant that understands 3 West African languages. And as a hint, the solution involves radio. While I was teaching CS in Guinea, teaching 4th graders how to code, I gave them the instruction set of a robot, a very simple robot that had these 4 instructions. Of course, my course was in French, and the instructions were avancer, move, tourner à gauche, turn left, ramasser, pick up the object, and déposer, drop the object. Students would write algorithms in their books and simulate code execution using physical objects. For instance, here, the pencil sharpener represents a robot. And using this type of game, students could debug and test their programs. However, there was one student who could not understand what we were doing. He could not play. This is Ibrahima. And I wonder, what was the problem? It was not a language issue. After all, he spoke Maninka fluently. He spoke it with his parents. He also spoke Susu and Pular, which he spoke with his friends. So he was already fluent in 3 languages. But he was having trouble with French. He was having trouble reading, writing, speaking, and understanding French. And that was the reason why he could not play. In fact, he was having difficulty in many other subjects in school. And French was required. It was the language in school. His native language, Maninka, was forbidden. And so he was having difficulties. Let's come back to Ibrahima later. This is another friend of mine, Mariam. I met Mariam in a small village near Fria, the town in Guinea where I was born. Mariam was really funny. She was extremely smart. I was really impressed by her mastery of the Susu language. She was very quick-witted. We had really fun conversations. She was also an expert at agriculture, especially pineapple cultivation. I really wanted to stay in touch with her, and so while exchanging phone numbers, she asked me help to save my number in her phone. I asked her why she couldn't do it. She replied in Susu and told me, "Muharanghay," which means I did not go to school. She already knew that when it comes to technology, her native language is worthless. She needed to learn another language and be literate in that language in order to access technology. Since Mariam speaks Susu fluently, you may wonder why wouldn't she use a virtual assistant? Unfortunately, languages like hers tend to not be supported by virtual assistants. So the problem we decided to tackle was that speech technology is not available to people who need it the most, people who use speech as their primary form of communication. In fact, when you look at the major commercial vendors of virtual assistants, none of them support any of the 2,000 African languages. None of them. And we wonder why. Reasons may be diverse. Some people may refer to commercial prioritization. Maybe people speaking those languages don't have a large enough population to be interesting commercially. Perhaps it is that people who speak these languages are not represented in tech companies, and so they cannot influence the direction of technology development. But if you look at the scientific literature in natural language and speech processing, the most commonly evoked reason is that these languages are so-called low-resource languages, meaning that there is not enough data to do with these languages what's possible with other high-resource languages. And so we decided to focus on this problem of low-resource languages. And it occurred to us that radio broadcasting archives are actually abundant in almost all spoken languages in the world. And so the question we asked ourselves is whether we could use radio broadcasting archives for speech recognition. The state-of-the-art way of doing speech recognition for low-resource languages is to train a speech foundation model in a high-resource corpus, and then transfer the learned representations to perform a downstream task, like speech recognition in this case, in the low-resource language. The hypothesis we wanted to test was, how would this approach compare to the approach, which is identical, but where the foundation model is trained on radio broadcasting archives? And radio archives are very noisy. They contain all sorts of noises, multiple people speaking, background and foreground music, telephone conversation, and so on. And so the research questions are, how would the foundation model trained on radio archives compare to the baseline model quantitatively and qualitatively? Our contributions are the following. 2 novel data sets that we hope will contribute to the development of speech technology for West African and other African languages. A speech encoder, a foundation model that can facilitate downstream tasks in West African languages. And the first ever speech recognition models for 3 West African languages, Maninka, Pular, and Susu. And finally, the prototype for a multilingual intelligent virtual assistant that speaks those languages and that can be used by even people who are illiterate. The two data sets are the West African radio corpus. It contains about 145 hours of speech radio broadcasting archives in about 10 West African languages. And the West African virtual assistant corpus is a data set that contains 10,000 utterances in French, Maninka, Pular, and Susu. These utterances, if you notice, contain a wake word and different keywords that are voice commands for a virtual assistant. It also contains spoken digits and 25 common Guinean names, in addition to words like mom and dad. The next thing we did is to create a foundation model, the speech encoder, using the radio broadcasting archives. As a reminder, this is how the two data sets compare. On the left, the data set trained to base the data set used to train the baseline model, the baseline WWvW, which is trained on LibreSpeech, a large data set of about 1,000 hours, compared to 6 times less data in the radio broadcasting archives. The LibreSpeech dataset is also very clean, recorded in acoustically sound environment, and contains read audiobooks, whereas the radio broadcasting archives contains a lot of noise. However, the radio archives are in West African languages. So the question is, how would the foundation models respectively trained on these two datasets compare? The quantitative results on a task of West African language identification showed that the West African WWvW outperformed baseline by a good margin. Looking at the internal representation of the speech recognition models created using the respective speech encoders, we see that the West African WWvW created a more coherent representation of West African languages compared to baseline. We also use gradient-based feature attribution techniques to estimate segments of audio that were most important for language identification. And we use this signal to segment important acoustic units. And when we visualize those acoustic units, we saw that the acoustic units that the West African WWvW focused on were more correlated to language groupings in West African languages compared to baseline. And these acoustic units were about 40 to 200 milliseconds in duration. So they are phoneme-like. And so we concluded that the West African WWvW seemed to encode phonemes that were specific to West African languages. We use this encoder to create the first ever speech recognition model for 3 West African languages. This is the neural network architecture. I can go in details later. But it contains 3 layers of acoustic feature extraction at different temporal scales. And it only has less than 200,000 parameters. When we compare the accuracy of the speech recognition models that uses either foundation models, we saw that there wasn't a big difference in their accuracy. Overall, the baseline model did slightly better. However, when people spoke in their native languages, the West African WWvW performed slightly better. We used the obtained speech recognition model to prototype an intelligent virtual assistant. This is the dialogue model of the virtual assistant. And it is sufficient for a task like contact management, so adding, updating, calling, and deleting contacts. Here is my friend Mariam using the application.
Kuruba. Nugin desafi. Mariam. Senni. Senni. Kere. Firi. Sara. Nani. Suli. Senne. Solo firi. Iyo. Koroba.
Mariam just added a contact.
Nohindefe.
And now she is going to call a contact.
Mariam. Nagli. Iyo.
Musa, this is Brent. That's so fascinating. What you guys did in the field. That's really amazing. I wanted to bring on Mark Dalton. He's from the UN and see what he thinks about this. What you're doing.
Sounds good. Yeah.
Yeah, it's really amazing. So I'm the moderator, Brent Phillips, and we have Mark Dalton and Chris Peach here. But Mark, you're seeing what Musa's been working here, and maybe you can comment on, the UN's view of voice applications and applications like these.
Yeah, thanks, Brent. Hi, Musa, and hello, everybody. And pleasure to be here. Hope you can hear me okay. I mean, first of all, that was an incredible presentation, Musa, incredible example. And I think probably the best way to explain what voice assistant technology can do in that sort of setting. So I was just throwing away all the examples I was going to list because I think you've displayed it all. I mean, I think, I had the great opportunity to interview Monica, I think back in June. And I must admit, my only exposure to voice assistants before then was watching my, at the time, 10-year-old son do his homework, his maths homework, by the way, using Siri and spending most of my time saying, you can't do that, you're cheating if you do that. And not really thinking through the implication of voice. And of course, he was saying, well, this is the way it's all going, Dad. And then zoom forward to a great conversation interview with Monica, who I think really set out a compelling vision of voice. And to put it into context for us, my background is a humanitarian. I've worked in pretty much all the continents of the world, and I've moved into the digital space, and I'm currently working on the digital transformation of peace operations. And I only mention that because in the humanitarian development and peace operations space, the protection of civilians, a lot of the challenges are very similar. And right now, we're very, very focused, almost obsessively so, around gathering data analytics, trying to structure data, trying to make sense of that, and also moving along the, investing in digital services for operations, but also digital services for communities and people that we're trying to support and help. So we're on this digital transformation journey, but there's very, very little discussion around voice. If there's any voice, it's generally in the shape of a chat bot trying to help you search and find information. We are delving and dabbling in radio in different ways, but nothing in the way you were communicating there. And I think what was compelling for me, certainly when I spoke to Monica, was that she was laying out really what an open source voice assistant would do. And just going through these capabilities makes you realize how game-changing it is. So number one, just the ability to search using natural language for knowledge. Who doesn't want to do that? And we were probably already fed up of typing and working on keyboards. If we can actually speak to the internet or speak through a computer to the internet, that's a huge game changer in its own. The languages, I mean, I don't know what else to say. That example was so brilliant about the fact that a lot of the technology solutions we've got are designed, obviously driven by profit primarily, and there is no profit or no perceived profit yet in designing around other languages. Well, there's hundreds of languages on the planet, and so that in itself, the ability to interface through multiple languages is game changing. The simplicity of using a one-stop interface, having it accessible on mobile devices. The open source design, as I just mentioned, designing for people, not for profit. The ability to instruct, as we just saw with Marianne, basically programming her phone. And really critically as well, the issue of privacy. And I think what became clear to me, speaking to Monica, was the fact that the way that an open source voice assistant would be designed is in a way that enables individuals to retain control of their own data. And that in itself is profound. And so I think taken together, all these really present something that is game changing. So certainly from a UN perspective, but from someone who's been, worked in many different capacities in different places of the world, yes, this kind of technology could certainly help UN and partner operations, but what's way more important is the impact it could have for individuals across the world, whether it's searching knowledge. I mean, it would almost be easy to write a list of things that you couldn't do with this. It would have such an impact. So maybe we'll just stop there. But happy to.
Yeah. Hey, Musa, is Chris Peach there with you on stage? I believe he's live. And Chris, I just wanted to segue in here. And Musa, you're both working together, and you're interested in STEM education and using AI to improve learning. And maybe you could talk a little bit about that and share your thoughts on humanitarian applications and applications in developing countries, and maybe from a technical perspective.
Yeah, I am here, and it seems if I talk, the owl will look at me. Oh, hi. Hi, owl. Yeah, so certainly one of the great opportunities is education. You imagine all the sorts of access that people could have access, or the sorts of learning experiences people could have access to. You mentioned your child who is learning through Siri. We would like that to be equal no matter where you are in the world. And in fact, the story of Ibrahim really inspired us. It made us think a lot, because Ibrahim is incredibly smart. Once he worked through the illiteracy block, he was able to program, which is a very high level of cognitive application. And of course, that made us think, well, if we can remove this barrier, we can get people more deeply, give people more deep access to education. But there was this other part that I think Musa, maybe even Rich, brought up, which is, actually, this is also another mechanism for Ibrahim to learn how to read and write by inspiring him to learn more and to become more involved in education. It seems like the downstream benefits are very large. It's a continued exciting opportunity.
And you both are there at Stanford, and we have the whole oval ecosystem that you're building there, and maybe you could speak a little bit about those components and kind of how you put them together and how you envision working with Oval more in the future, and how we could work with Oval, the humanitarian community. What's in it for us? What do you see the greatest benefits of all the work Oval's doing for the humanitarian community and applications like yours?
I would speak to the open source nature of it. I think this has been brought up, but it's critical. If we don't open source this, either it won't happen because it's not for profit, but then also the privacy concerns are not small. It might not seem like the first problem we're going to hit right now, but it's a problem that we will all hit very soon if we don't come together around a way we can do this without leaking people's privacy. Is there something you'd like to add?
Yeah, and so there is a lot of alignment in the two lines of works, and what our work demonstrates is that there is data available even for so-called low-resource languages, and that we can use it to train speech recognition models. And that would be a module in Oval and the Genie toolkit. And so for a path of integration, I think one possibility is to have a model that could convert any low-resource language into the ThinkTalk programming language. And once that bridge is built, I think integration should be a breeze.
Yeah. Hey, speaking about integration and standardization, Mark works for the UN, and you were in Congo, and when a needs arise in Congo, it's really cool to be able to just speak to your voice assistant, say, hey, I need help, and have that reach Mark through his agent, pre-trained agent. And it's really cool to think about how you can communicate across the network, across the distributed network and the worldwide voice web. So I like the possibility there of just being able to reach these people who you just featured there. And that this is really vital to the future of humanitarian operations. And I was talking to somebody before this talk, and he was skeptical that we'll see any progress on the voice front, but it's really crucial. These sort of initiatives are very crucial to the future of humanitarian AI and the future of voice. So
maybe I could
Mark,
also speak.
do you each want to like close on that point, or?
Well, yeah, you also asked another question which I think is very important, which is how can the humanitarian world participate in this project? And maybe that's hints towards a theme that's very deep in Musa's work as well, which is making sure that all the stakeholders are present in not just choosing which problems are important, but also solving them. So you can imagine Musa's work, and it wouldn't have been possible if you didn't have Musa there, who both knew the AI and also was very deeply embedded into the context. As humanitarian workers, you're deeply embedded into a context. So bringing these stakeholders together will lead to the solutions we need, not just identifying them, but also coming up with things that will solve people's real-world problems. So I'd say that's a theme to take away, one of the many things to take away from Musa's great talk, too. And this is a small thing, too, but I guess one of the reasons I'm here is to represent people who might not otherwise be represented, right? We make sure that when we make the worldwide voice web, that it speaks all the different languages, like Swahili and Malay, languages I speak, Malinka, French, the language that Musa speaks. And then I just want to put a small plug in for, I have a daughter who's deaf. She doesn't speak at all. And to think about how we could make a worldwide voice web that could work for all people would also, maybe you'd want to have that stakeholder present. And to speak to it quickly, there's this other wonderful language of ASL, so people who can communicate using sign language. And if we want to make this great worldwide voice web, which is a beautiful mission, getting all those voices, including the humanitarian voices, into these conversations is critical. If it's for everyone, let's make it from everyone.
Yeah, and thank you, Monica, for bringing us all together.
Yeah.
Mark, we're getting close to running out of time here, but I'd like to give the floor back to you. And
thanks, Brett. Just on Chris's point, although from my perspective, voice feels very, very much on the horizon next gen, that doesn't mean to say that we haven't been getting better working in innovative ways. And I think there's a really big opportunity here for some of our more advanced, some of our agencies have got innovation labs, accelerator labs. I think one takeaway should be to try and link this initiative Stanford up with some of our UN partners and just do that, who are very, very familiar with working in a dynamic, innovative way, and see what can be done. I think there could be some really interesting innovations around that.
Yeah.
So thanks very much.
And speaking about partnerships, this is an important point. The humanitarian community for the last 10 plus years has been working really hard to standardize how aid activities are reported and to improve ways of channeling aid activity information to machine applications. And this actually makes it possible to query, to ask Siri or Alexa or Almond, who's working where, what are their needs in real time, who are their beneficiaries. And it's really unique. And I try to get this across to, our humanitarian AI meetup group members that there's a real possibility here to take this data, this highly structured data, and apply it, to plug it into voice applications. And I think we're further ahead than the private sector on a lot of levels. So, I really applaud what Monica's doing. And I think these sort of pre-trained agents and the think talk, and you're really making it easier for all of us to come together around tech. So this is really great. Musa, since we cut you off first, I'll let you close the room.
Well, it was a pleasure to be here, and I'm looking forward to all the things, all the minds that came here today can accomplish together. Thank you very much.
Yeah, you're welcome. And thanks everyone for joining this panel. We've got another panel queuing up right now. So I'll turn it back over to Stanford, and thank you.
Thank you very much.
So Mark, see, now that we're still on the channel, in case anybody else is still out there, who else is doing interesting work in the field that you're really excited about? Like, do you want to plug anybody?
Oh, right. So we're still live, right?
Yeah, and there's the DEEP initiative, and it's just great what everybody's doing. Anyway, we're queuing up for the next talk, so
oh, I see.
Thank you,
Okay.
everybody. All right.
Great panel.
Yeah, thank you.
Okay.
And I think we're to leave, so
Yes,
I'm
okay,
leaving.
take care.
So
Good
I
to see
should
you.
just stay, correct?
Good to see you. You can stay. Yeah, take care.
So where are you, Mark?
I'm in New York, actually. Yeah, not in the UN building today, but nearby.
Hope we can find a way to continue this discussion we had.
Yes, I have been. I should reach out. We've been having conversations here. Yeah.
Awesome, thank you.
Okay, ciao. Hey, Monica.
Hello. Can they see me now?
Hi, XD.
Hello.
We're still trying to get organized.
Okay.
Okay. Oh, can you hear me now, XD?
I do.
Okay.
Yes.
Do we
That's
have
awesome.
more mics for folks? Okay, okay. Great. Why doesn't everybody gather around? Hi, Chris. John? How are you? Good. I'm John Markoff, and I'll introduce our panel. And I just wanted to say, before we get started, I guess my distinction and why I'm here is I actually wrote the first article about the World Wide Web, and that was, I think, well, it was in 1993, so almost 3 decades ago. And it was this interesting case of getting it all right and all wrong, which is why I'm really interested in this panel today. The lead to my article was, I think of it as a map for the buried treasures of the information age. And when I used the word buried treasures, I was thinking about information. I had no idea that I was actually right, and I was thinking about buried treasure. So here we are again, 3 decades later. First, let me introduce our panel. Oh, there I am. Okay, and we have first XD Wang, who's the Microsoft Azure AI CTO, and he also studied with Raj Reddy at CMU, I guess sort of at the beginning of voice recognition research. Next to me on my left is Jerry Kaplan, who's a research affiliate here at Stanford. He has the distinction of having co-founded 2 very early AI companies, Technology and Symantec, and he also founded GoCorp, which was the first tablet company. Chris Manning is next to Jerry. He is the director of SAIL and the associate director of HAI here, and is a specialist in natural language understanding. John Stein, who's over there, is a former Intel executive. He's the director of Open Voice Network, and what we share is we're both Oregon Ducks. So good to see you. And finally, Jerry Yang, co-founder of Yahoo, of course, venture investor, and a former Stanford CS student. Double E. Oh, I'm sorry. Double E. My mistake. Let's begin at the top. So pardon the pun, but I'd like to start with a meta question. Is voice the future of UI? Who would like to take a cut? It's sort of the broadest question, given what we've seen today.
So I think it's clearly too strong to say voice is the future of UI, that there are different modalities and different ones are going to be appropriate in different places, right? If you're a teenager wanting to communicate in the middle of your classroom under your desk, you're much better off texting on your phone than you are speaking. But on the other hand, there is a very broad range of cases where people struggle to do things with their mobile phones in ways that are, very inconvenient and hard, and they could do them much more seamlessly and conveniently working with a voice device. So I think there's a big part of the space for which voice is the most natural user interface.
Who else has a perspective? Okay, I'll ask you next, XD. Go ahead, John. No, I'm sorry, John.
Just as we look at consumer behavior,
the move consistently, inch by inch, and to Chris's point, it's not going to happen overnight, and it's not going to be exclusive. It's going to be a primary or an increasingly primary. But the ease of doing it, the convenience of voice, and when we think of whether it's, whatever screen we're using, we've been using a 19th century interface, QWERTY, right? We're in the QWERTY kingdom still, and I'm typing no faster than I did in 1974 using a Smith Corona. Again, we will be moving, as Chris said, incrementally to an easier interface, and in situations, in certain settings, it will be the choice.
XD.
Yeah, I think what Chris outlined was completely on point. Speech is great for humans to actually issue commands, but the picture, video would be great for consumption. So I believe that is going to be collaborative. It's a multimodal universe. It's a metaverse that you will be able to talk. You will see what is going on. You will immerse yourself. So that is the future of the web.
Jerry.
Is this on? Can you hear me?
Yeah.
Just one thing I wanted to add to the comments we've heard so far is there's one aspect of voice that I think is overlooked, but that I see is very important, that encourages me to use it more and more frequently, which is that you don't have to be at a computer. You don't have to move to be able to ask something or to get something done. I notice in my own pattern of use for this technology, I have an Alexa that happens to be sitting in a room. If I'm talking to my wife, a question will come up. I would never often break the conversation to go over, sit down, type it out, or even pull out my phone, which I regard as a bit rude at times. But just to be able to go, Alexa, ask the question, the fact that it's a distant, there's a certain amount of distance that you can use to operate this interface, is itself a very important motivator for its adoption.
Jerry, would you like to?
I was going to say something that XD said, which is I think voice has been underlooked relative to some of the other interfaces. So I think ultimately it's multimodal, but I think voice has a ways to catch up. And I think Jerry's point is extremely salient in the sense that I think there's an untethering of that interface that happens with voice that for the same reasons that a lot of times you don't want to use voice, which is that you don't want to talk when somebody else is in the room. But if you are in a setting in a conversation, then you don't have to get up and look up something or pull out a phone. That to me is a really powerful modality.
So the last demonstration raised a question in my mind that I'd sort of like you guys to explore, and that is that, I've been around long enough in Silicon Valley to watch each generation of computing extend to a broader portion of the world's population. It's like the crank turns, and as the cost falls, computing pushes out toward the edge. And now I think we're at about 50%, although I may be out of touch here with where we are. But I guess I want to ask the question, is voice the path to complete connection of the world's population? Is it the final turn of the crank?
Almost. Right. So it isn't the 100% solution because, as Chris Peach mentioned in his talk, there are some people who are deaf. So there clearly have to be different solutions for different people. But nevertheless, if one takes the large part of who are the people who are not using modern web technology today, the vast majority of those, speech is an extremely natural, convenient, easy to use interface, works great in noisy outdoor and diverse environments, and could provide a much more workable solution than what we have today.
Sure.
I think there's going to be a wide variety of new and different interfaces to computers in the future. I just mention too, I think that haptic interfaces, as odd as that might sound, for certain kinds of uses, I think will become very important. Gestural interfaces that involve just things like pointing. Or I happened to be watching the movie Dune last night, for those of you who've seen it, and there's this woman who's masked, and she communicates through sort of a form of ASL. I mean, these can be very good forms of interfaces once we have the technology to parse them and integrate with them.
XD.
Yeah, the fact that we are all using speech in the panel already made the point. The additional point I want to add is really there are 7,000 spoken languages in the world spoken, today. This is a huge, diverse community. Unfortunately, because of the globalization, every 10 years, probably, hundreds spoken languages disappear. And what goes with that is the community, culture, and everything. So just to preserve the diversity for the mankind, it's super important. The written language is not as rich and diverse as spoken language. This is just, the nature of, the humanity, what the world we are living. So in order to really serve everyone on the planet, you cannot just ignore speech. But behind the voice web, really the key differentiation is not just only the voice, but also the language associated with that. So that's really just one additional point I want to add.
Okay. Thank you. I'm curious about so in drawing, I'm going to draw parallels here. And before I get to parallels with the web, I wanted to draw the parallel with the progress in AI. There was a point when John McCarthy, who was director of the Stanford AI Lab, said that he thought that developing a thinking machine would be 10 years and $10 million. And then later, as it turned out to be a harder problem, I think was it 2.5 Einsteins and $2.5 billion? Anyway, it proved to be a harder challenge. So here we've made all this progress in voice, and it really is stunning. And yet, we're clearly not where we want to go. And I want to ask you about barriers to the next generation. What are the technical or other kinds of barriers that have to be, or the most significant ones, or the ones that need to be broken, that require breakthroughs that aren't solved yet?
I'm happy because I kind of see the body language of everyone in the panel. So, yeah, I can see that a little bit. I think if you look at the AI, the perceptive AI, we already made a tremendous progress, whether it's speech recognition or computer vision or gesture. But the cognitive AI, like language reasoning, understanding broader context, then the progress is smaller by comparison. So the real hard crown jewel would be the language. If we can really understand the language, we can read 24/7, and you can accumulate the knowledge and the reason that add on top of that. Can you imagine there will be a million Einsteins created, understand everything in the world? So that day will come, but it's actually going to be a little bit off. But on the perceptive AI with a limited language capability, that is what we are having today. I think it's just amazing because on the well-defined task, whether it's a speech recognition or translation, they're all getting close to the human parity level. So now that horizontal capability can be really, really leveraged to go deeper. And the language understanding is the barrier. So you need to marry that vertical depth and the knowledge with the horizontal capability. That's mostly at the horizontal level on computer vision, whether it's autonomous driving or speech recognition. So this is the golden opportunity for the society. I really think the effort that Stanford is initiating is going to really accelerate and revolutionize how we deal with the web in a more immersive and natural way. I'm excited to see the opportunity.
Other thoughts on barriers?
Great comments from XD, and thank you. And to raise the question is the right one. I'm executive director of the Open Voice Network. We're a Linux Foundation open source community dedicated to how do we make, to the question that Monica has been leading here, how do we make voice open? How do we make voice inclusive? How do we make voice trusted? And we look forward to sponsoring the work of Stanford, Oval, Almond, and the like. I think it's marvelous. But to your question of dependencies and barriers, Yes, the technological, of course. But there's also, I think, the big, let's call them societal and governance questions. There's the business questions. Right now, it's difficult to find business leaders in Mahogany Row, C-level executives, who would turn around and say, this is essential to my business. It's a toy. It's something my nephew demonstrated last year at the holidays. Doesn't it play Spotify or something for me? It's so understanding the potential of voice, and then when those executives begin to uncover what voice can do, then there are all the questions of, oh my God, who owns the UX? Who owns the data? Is this going to be private? Is this going to be protected? Or is someone going to sell me my data back because of the arrangement of working on a proprietary platform? Is this open? Is it interoperable? All these questions that are business structures standards, those are all huge issues that we collectively as a group, and especially in the business community, will need to overcome for this to be realized. As XD said, as the technology advances, and it will, there is at the same side the whole parallel track of, let's call it societal business governance development that will need to happen.
Other thoughts? So XD gave a great answer on the technology, but yeah, two aspects I'll just mention. I mean, getting closer to the business side, as John was mentioning, I really do think at the moment that speech or in general natural language understanding, because you can do things by texting interfaces as well, is just enormously underexploited relative to where the technology is now. I mean, that's partly an issue that we've trained up hundreds of thousands of JavaScript developers who are good at sort of banging out web GUIs, and so that's what everyone does. But I think there's just enormous opportunities there. And in terms of where the technology isn't, I think one of the huge areas is actually, realizing this promise of spreading this technology out to the thousands of the world's languages. That for things like speech recognition, we can do a fantastically good job now in major languages with lots of data, and a lot of the challenges are developing the kind of self-supervised learning approaches, the kind of stuff that Musa was talking about earlier, to actually be able to extend the promise to the less resourced languages.
Just taking your question somewhat literally, what are the frontiers or boundaries of things that I have no idea how these can be addressed. To me, the next big advance might be from individual utterances or a small number of utterances to dialogue, and dealing with those questions of how do people cooperate in conversation, how do you engage in conversation, what does that mean, how do you deal with an AFRA of references back to, what are you talking about, what are you referring to if it was 3 sentences back or something you were doing earlier. To me, there's not much known about that, and that's an area very ripe for fundamental research.
Jerry.
Just on the other side of that is the application side, and I think if you look at the kinds of companies we've been involved with, everything from audio AI companies that are trying to take orders for McDonald's order to noise cancellation and enhancement, audio enhancement, to really being able to work under kind of industrial, like fixing a jet engine, for example. You're doing something with your hands and you got a headset and you got high decibels going on to, even like settings like this where there's multiple speakers, multiple interactions. I mean, voice has always been kind of a solitary or one-to-one kind of a application environment where I think where it's probably the most effective is a dialogue. Like think about a crowded restaurant sitting around a round table or a conference table. I just think AI has the fundamentals to solve all these problems, but have we done it in a way that is truly easy to use? Sort of all the consumer side of it or the enterprise grade. To me, that's still a little bit ways to go, and it's advancing really rapidly. Though I do think there's tons of companies out there that are really trying to solve these problems.
John?
If I may add just one thing to the great comments that Jerry just made, extraordinary things being done, and a number of use cases out there that people say, you really? Voice can do that. But one of the major things and one of the real values of this conference is addressing this question or redefining what voice is. It's not just a skill or an action. It is a much broader opportunity of independent, interoperable, open agents, billions, not hundreds of thousands. And so part of the value of this, and to what Jerry was speaking to, and a challenge for all of us, is communicating what's being done, what's possible, and what the future of an open interoperable system would be. And Monica, thanks for the leadership in that. Critical.
So there are moments when I feel like I haven't been around for 5 years, which is true. You know, when I left to work on something that was not about the news of Silicon Valley, there was this thing called Web 3.0. And I thought it was about the semantic web. And I come back today, and there's this thing called Web 3, not Web 3, and it's about the blockchain. So what happened to the semantic web? And are there points of contact between what was the semantic web and a worldwide voice web that are significant? I guess this is a question for Chris or XD, perhaps.
Yeah, so the semantic web never really took off. I mean, you know, there are bits of it. There's schema.org, and in some places other kinds of RDF and things like that. I mean, this is perhaps a slightly controversial thing to say, but I think it never took off because the assumptions of it were just wrong and fundamentally different to the assumptions of human language, right? That the semantic web was essentially the last hurrah of logicians saying that what we want is a formal knowledge representation language to underlie the web. Whereas what's actually been successful on the web is human language. And human language, you know, it's this imprecise, funny thing where we use it for sort of emotive expression as well as sometimes conveying careful ideas, such as in a physics classroom. But the wonderful thing about human language is it can span that broad spectrum of preciseness. It can be very brief because it incorporates context around it to know what people mean. But by saying things more carefully, you can also be more precise. And I think that is actually just what you want as a communication system. And, you know, what's billed as logical precision doesn't actually work as a method of communication information exchange.
Yeah, I agree with what Chris said. And I just want to add, probably the search engine fulfilled the semantic web. Today, if you go to Google or Bing, you can really find almost anything you want. And the underlying technology of using search to fulfill the dream of the semantic web is partially fulfilled. On top of that, I just want to highlight for the mobile search. Voice searches take probably like 25 to 30% of the traffic. This is already happening, right? But the voice today is treated as just a modality added on top of the search. So what I'm most excited with this new initiative from Stanford is really just amazing. You are going to create this pre-trained agent and get the semantic parsing and integrate with voice capability to accelerate the progress. This is going to really change the way how the semantic web dreamed about but couldn't realize.
Jerry raised this point. Jerry Kaplan raised this point. So where are the systems that know about state and turn interactions into true conversations? And why has that been so slow? At least in the main sort of consumer interfaces, it seems like the systems that I interact with know no more than the question I just asked. And is that going to change in a significant way? Is it technically impossible or difficult? What are we going to see and when? I know in the gaming world, I mean, I've seen experiments with this, but I haven't seen it as a deployed technology yet.
So Jerry is right that this is a much less developed area, and it requires maintaining context so that you can understand what objects are under conversation, what assumptions have already been made and shared between them, and how to interpret following utterances in the context of what's coming before. I mean, things are definitely starting in that direction now, right? If you read the sort of Amazon Alexa press releases that bringing dialogue is what they describe as their major direction going forward. Other companies like the Semantic Machines work now inside Microsoft Corporation, modeling a longer dialogue is a large part of what they're doing. But equally, it's a big part of what we're exploring in the Oval project is actually sort of making it dialogue first, whereas most of the current technology, whether it's Siri or Alexa, started from this place of single command, which just isn't how human beings and most interactions work.
Jerry next.
Well, if I can say, I think one of the reasons that it's so challenging, just one of the reasons, is that we don't really have, to do it well, you have to have some kind of model of your conversant. You need to understand what do they know, what have you talked about. So you need a theory of mind, so to speak. That's dignifying it more than it needs to be, in order to have a proper conversation. And when the web is voice as an interface has come out of the tradition, I guess you'd say, of simply asking a query and getting back an answer, and not having some kind of ongoing developing context or developing understanding of who the parties are, what they know, and how they want to work together. So without having that kind of a sort of cognitive model, I think it's going to be very difficult to get. You can get a couple of sentences in, okay, we're talking about a restaurant. When you say, where is it, you can figure that out. But this goes way deeper than that and will be a very difficult and fundamental AI problem to solve, I think.
The speech scientists that are working with us in the Open Voice Network certainly point to all the great things that Jerry and Chris just said. Context, that is what's been said, difficult, critical, but difficult. But there's also the element of it's not just speech to text and the words, but it's the tonal and sentiment understanding of how it's been said. So now we add in that additional variable. Very difficult, but indeed, if I say it like this, it's different than if I say it like this. And that's all part of developing a dialogue that we would want that is kind of human reflective. Very difficult, it's out there, people recognize it, but it's inch by inch, step by step.
So let's turn to the political question of creating, or the business question of creating a World Wide Web. There was a point in the late 80s and early 90s where, this is what led me to my belief that the visionaries are always wrong, where if you went to any of the big corporations, they would show you how the world was going to be one of islands and not of open standards. And then everything flipped, and it was largely the web that drove that, and Linux and TCP/IP. There was a whole set of open standards events. And so, I guess the broad question is how, simply put it, how good is the World Wide Web's evolution in history as a model for what we're proposing here, the idea of a World Wide Voice Web? Where are these things similar, and can the same path be followed, and where is it substantially different?
Well, I guess that's why you have dinosaurs like us here. I guess my perspective is not so much like open versus closed, or proprietary versus open and shared. I think in sort of technology adoption or business world, the criteria is which one can scale faster to critical mass. And I think in the late 80s and even the early 90s, until the HTTP protocol came along, all the all the information was really done in a very inefficient and if they were proprietary, they were done in a way that was never going to truly scale. And so I think the web was at that time the best way to scale up information dissemination, right? To the point that the slide Monica put up early on is just that you saw that exponential growth. And then I would argue that it kind of went away in the last decade. If you look at now, we have sort of these vast company owned sort of walls of data and protocols, whether it's operating system defined or sort of company defined. So the web today, or the web is largely, as we knew it, like in the early '90s, it's largely gone, or at least very, very different because of the underlying data and because of sort of the relationship that people have through their personalization with the services. And that because we never really opened up personalization on the web, as people got used to services, that openness went away and became scaled through these private companies. So I don't know if we should just look at whether voice should be open or not. And there's obviously a lot of people that sit around and say, well, open is better, right? But I happen to believe that. But I also think we should ask the question of, is open going to accelerate something faster? Because if Alexa and Siri and Google is going to continue to drive adoption at a much faster rate than an open world could, then no matter how open things are, it's just not going to make it. So I would look at it less from people lamenting the good old days of the World Wide Web versus now. I would just say we missed the opportunity to scale, and if voice is going to be that next thing, let's not miss that opportunity.
John.
Great points by Jerry. And when we think,
that's your job. So
no. I think you're making great points, and just some data to back up what Jerry just said. There's a platform that is now reaching or available in 58% of all U.S. households. That's scale. That's very serious scale. And so it's going to be, hybrid, and I can talk about where it's going to end up and all that. But we're at a point of societally trying to make a decision, what future do we want for this technology? Because de facto standards and de facto realities are being created as we speak. Again, if we define voice as an interface to a personal services platform, which we could, then there's a winner. Have the band play and we'll march off the field. So, yeah, we're at a really critical point. I think, John, to your question, the model of where the web was in the days of the browser wars is instructive, but we're in a different time here. We're in a different place. And I think the presence of the platforms and the use of voice by those platforms to getting where there are, we're in a different reality. We can be taught by the past, but we can't follow it.
Let me just push it. So are we at the point where we're at a duopoly and that's the end of the game? Where are you on this?
We are currently in what is approaching a duopoly, but the United States is but one nation in the world, and we oftentimes forget that. And second, we can't give up. We shouldn't give up, and there needs to be options. And I think, John, what is going to be pushing the options, and I'm slightly pushing back to Mr. Yang, who's far smarter than I am, is going to be the needs of business and enterprise, because they're going to look and say, I have no desire to give up my data. I have no desire to give up my UX. I have no desire to give up my persona. That's, I think, the counterweight. And as the faster that business and enterprise will come into the game, the faster it may move.
XD, do you have?
Well, I think this is a fascinating discussion, but I just want to remind people the technology changes so much, and the next web could be metaverse. So if you want to actually really have the voice interface, you got to really, embrace metaverse. I believe that Zoom or Teams will be the browser to the metaverse. So you can actually wear Oculus or HoloLens or not wear anything. Because the Teams or Zoom, you got the camera, audio, microphone, everything, and you can create it, you can immerse yourself. That technology is going to happen. So the openness or close, that is actually, unknown, because the metaverse is going to be different again.
Jerry Kaplan.
I'd like to make a point of encouragement for the efforts that Monica and everybody's doing here, to point out that it isn't game over because there are two players in the marketplace. And you don't have to beat them in order to accomplish your goals. The fact is, the presence of a competitor which has some perceived advantages will affect the behavior of those big players in order to drive them in certain directions, cause them to do things they would not otherwise do, and you can accomplish your goals without having to be the dominant platform. You merely have to be a plausible alternative platform. So if you're good at privacy, that's going to get these big players to work on privacy. And if you're good at incorporating a wide variety of multi-domain activities that they do not, that's going to encourage them to do it. So I would suggest these are wonderful goals that we saw this morning, but you don't have to it's not all or nothing. You're not like successful or you're not.
Amen.
Your mere presence in the market and the fact that these companies don't want you to get too big. I mean, we've been through many of these wars. They want you around so they don't have any trust problems. They want you, they don't want you to get big enough that you represent a threat to them, but they will react. This is what we used to call in the good old days when John and I were young, making the elephants dance.
Amen and amen.
It was 1987 when Apple produced Knowledge Navigator, and there was this kind of vision. And I think we're still, that vision is still the one that people seem to be marching for. The aspect of that vision that seems to make complete sense to me and still seems very far away is mixed mode interfaces. And am I wrong? Are there examples of mixed mode interfaces that people could point to? I mean, as a researcher, the notion of that interaction between the professor and the assistant that was fluid and interactive was so compelling, and I still don't see it anywhere really, except in what am I missing? XD.
John, I think I understand what Apple did at that time. It was fascinating. It was a fantastic demo video. But I would say teams today embrace that multimodal mixed reality universe. We got a mesh and the teams working together. You can create the Oculus metaverse interface. Teams with the browser. And the teams today got this live captioning. Every word I said, even with my Scottish Chinese accent, can be transcribed. Just like, John, you're a native speaker. And we support Azure Cognitive Services, we support over 100 languages. It's still far away from supporting 7,000, right? And we have the summary, you can do the chat, you have the video. So it is actually multimodal mixed universe. But you are interacting with the real people today. But in the future, you could interact with metaverse avatars or agent. We have even actually speaker coach. Today with Teams, if I say something bad, it's not compliant with the diversity policy, I got actually a reminder already. So it's beyond knowledge navigator. I think the Teams is one of the most important innovation because of the AI, because the immersiveness, because it is the browser to the next web metaverse. The importance is going to be, profoundly important. So that's why I'm saying the technology is changing so fast and the opportunity is tremendous. The initiative for the Stanford AI program is just impressive. Whether it's open or closed, there will be tons of new exciting opportunities. We'll have to embrace voice. There's no question about that.
John, did you?
There are a number of examples, John, to your good question. A shopping app. You know, the conventional wisdom is that we can speak 3 times faster than we can type, but we can read twice as fast as we can listen. And so a shopping app that on your mobile device, you speak to it, you make your choices, but then the selections and or the choices appear to you in icons or something like that. Multiple examples of that right now around the world. And you know, we're seeing that development, so it's not just conversation, it's not just dialogue, it is a combination of interfaces.
So I thought it was fascinating that Tony Espinosa's title includes the phrase social impact. And you know, I think we're all sort of attuned to privacy and surveillance as aspects about this technology to worry about. But here comes a new mechanism or a new platform. It will be exploited. There will be unintended consequences. And I was wondering about unintended consequences from this technology that might be beyond surveillance and privacy, which are the obvious ones. Just as an example, I think this is years ago now, I think I actually saw a news report on this in the journal that there will be the day where my mother will call me and ask me for her, she told me she's forgotten her bank password, but it won't be my mother. I'm certain that that will happen at some point. But what are the other things we need to worry about?
I was just thinking we have a company that's doing like deepfake voices. That's actually trying to help people who lost their voice or had an injury or whatever, but they can speak, or people who are dead, but you could take their voice recordings and recreate them and have an AI talk to them as if they're alive. And it's just like what's happening in video, right? So you can deepfake videos, you can deepfake voices. So that's sort of the counterpart to the security part. I do think one advantage of what Tony and what John talked about is that there is I think a vast opportunity for sort of nonprofit change using voice. Because it's sort of by definition, and that previous session really highlighted that, is just it's, you know, accessibility and cost effectiveness is still the #1 driver for lack of technology adoption. And I just think voice could be the simplest way to do some very simple things. So we're talking about very highfalutin, you know, deepfakes and things like that, but the rest of the world doesn't really need as many fancy things right now to just have access to technology. So you think about, you know, access to cloud, access to services that are on the cloud, without, you know, if you're without certain ways of interacting, either you are illiterate, like that example, or if you are unable to type or whatever, all of a sudden the world is available to you through voice. And I think that's the nonprofit angle, or maybe it is profitable, even, you know, or just totally a non sort of you know, a non-Western U.S. centric way of thinking about it.
Yeah, I want to just add to what Jerry said. The user trust is super important. Microsoft already got this. I want to say deep fake. We call custom neural voice technology. And we are actually helping BBC to announce news through the cognitive services neural voice. But this is gated service. So if you want to use this technology from Microsoft cognitive services, you have to go through the gating process. We want to make sure the user scenario is compliant to the responsible AI principle. So Microsoft as a company, we're taking this very seriously, make sure we will not let anyone misuse the technology. But the good news is BBC is able to enhance the productivity for the, you know, anchor person to announce news. This is already in production.
Chris.
I want to suggest a good news future. But I think it's whether we can sort of reconfigure the world. I mean, so the fundamental fact is, you know, our cell phones today just have an amazing amount of computing power in them, right? They have far more computing power than the huge computers occupying half a room that we used to work on trying to program, if you're my age. And, you know, for a long time that was very underexploited, right? That the phone interface was really sort of a pretty dumb device that just sent stuff up into the cloud and the computing happened in the cloud. I mean, that's starting to change now, right? Partly again through the wonders of neural networks, that there's just much more ability to do compute on device, and so people are now doing speech rec on device, even machine translation on device, as well as lots of things that aren't language related. So I think the world that we want to move to is one in which we can think of having an agent that lives on our phone who works for us. And part of that is the agent being the voice browser that Monica and Oval were talking about. But I think the concept's more general than that, because sometimes you won't be using voice, but you still like the phone to be an agent that works on your behalf. And the question is how we can change to that world, since the reality is that at the moment, several of the most powerful tech players are completely dependent on a model in which your data is going to the cloud so they can then sell you as a product to other companies. But if we could change that, then I think there are great opportunities which would fundamentally put us in a much better place in terms of security, privacy, and all these other problems.
Chris, you make a great point about the necessity to explore the architecture, and with the compute power increasing, to perhaps have a choice between local and or cloud. But John, to your question, there's another issue that I think is out there in front of us, and that is all too often when we think voice, we focus on the speaking as opposed to the listening. And the whole realm of analysis of the extraordinary richness of voice data and the inferences that potentially could be made, gender, location, dialect, ethnicity, etc., let alone the fact that it's a biometric, let alone the fact it's a biomarker, and that researchers are, there's an early indicator of COVID or Parkinson's or schizophrenia or whatever. This is an entire realm that begins to edge towards synthetic voice and deepfake, but it's one for ethical exploration, it's one for use exploration, it's one that is out there in front of us within the voice world.
So my three favorite science fiction movies all deal with voice. Of course, there's Her. I recently stumbled across a German movie that I highly recommend to people called I'm Your Man, which deals with embodied voice. What's the third? I'm forgetting the third right now. But the question is, do I need to talk to my refrigerator? What are the limits? I mean, it sort of was assumed here, but how much does voice need to penetrate our world? And by the same token, going back to the point that Tony raised, is a voice-mediated world going to be a more human society? It's a big question, but it is the most important.
John, explain the last one. What do you have in mind when you say a human? If you could explain or discuss more the
human society.
Yes, please.
Well, so the Her scenario that I worry most about is that if all of our interactions as humans are mediated by technology, we will have no human interaction. Well, COVID already made that happen, so maybe it's a moot point at this point. But you see where I'm trying to drive at. I mean, a human contact is important. Technology is supposed to make, I think Tony's point was, technology is supposed to drive human contact. And yet I can see so many points where, misinformation and where exactly the opposite has happened. The internet turned out to be a two-way street. We thought the internet was going to push democratic values to the globe, and in fact, it turned out to be the greatest Trojan horse in history. There are all these things that have unintended consequences. I guess I'm re-asking the question I just asked.
So complex issues, since in the one hand, if voice assistants sort of substitute for real humans, that can itself be breaking human connection, so that's undeniable. On the other hand, I kind of think that if we're more used to a voice-enabled world that at least has people in the mind frame where they're interacting with other agents, whether actual human beings or voice assistants, which is more connecting them with the human world than when people have their heads down in their phone, pressing on the various GUI elements. So I think there's some reason to be hopeful there that it allows a more human-centered interactional space. But, you know, it's not the whole part of the story. I mean, I think, you know, society has much thinking to be done as to how we want to build the kind of world we want.
John? Other?
I think we're years away from being able to answer. I see the next many years being just reducing kind of human friction. I'm too lazy to get up and turn off the lights. And you know, honestly, the remote control of television is going to disappear. I am going to say, I want to watch ESPN, I want to watch CNBC, whatever that is. So there's going to be some very incremental small steps, John, that will just be reducing standard friction, but the kind of general, the larger use case, I don't see changing 3 to 5, 7 years. I don't, you know, a sense.
XT?
Yeah, I'm optimistic. I think the digitization is going to accelerate. The pandemic really accelerated everything we do. You know, can you imagine, you know, we could just all use the remote meeting, remote work 2 years ago, right? So because of the technology and the acceleration of digitalization, you will be able to talk to a real person remotely. Like I'm not avatar right now, but my voice might be. Or because I'm sick, you know, I have, you know, problem. I can actually put a digital me right now. You cannot tell the difference. Technology is already there. So we are going to interface with real people physically, remotely, or virtually. So this is going to really bring the whole world together better, in my opinion. There will not be any language barriers. You know, I can talk to anyone in their own native language. Technology is getting there. So this next generation web is going to be far beyond the original vision of semantic webs. That's my personal opinion. I'm very optimistic.
Thank you. So we have a couple minutes left. I'd like to invite the audience in if there are folks who would like to. Yes?
No one mentioned. Oops. Thank you. None of you mentioned a brain-computer interface, which seems to be the next frontier. And you know, now there's a neurosurgeon at UCSF who managed to put a sensor in the brain and record what the brain sounds pre-voice before your vocal cords. And so that technology is actually here and now. And I'm curious what you think, what role that might play in the future.
Can I just actually express my personal opinion that doesn't represent Microsoft? And personally, I'm hoping that we don't need to have anything we have to wear. That's just not comfortable. And so if you can really do the remote brainwave reading, that will be a breakthrough. Anything beyond that, you have to wear these sensors on your head. It's going to take a long time to adopt.
Other thoughts, Jerry?
I don't have an answer to your question, but it's just another random thought since we're random thinking anyway. I was reminded, somebody recently told me like our brain is what, 2 trillion neurons or some crazy number, and that we're basically uses like 200 watts a day to power our brain, right? And our eyes are 5 watts of power, and we keep forgetting that, you know, while we talk about AI, the real human intelligence is the most incredible machine or whatever, the most incredible processing power consumption and intelligence unit that nature has ever created. So I think this interface between our brain and everything else, whether it's voice or visual or everything else, is is just at the beginning, but I also think my whole point is I think the more we can understand our brain, the more it's going to help all the discussions that we're having here, because we're all just trying to extend the most powerful unit of compute that I think we've barely understood yet. So,
Jerry first, then.
If I could try to address this issue, I think that we have some kind of aversion, natural aversion, to things that violate some perceived boundary of where we are, or who we are. And so the truth is, when our brains are interfacing right now. I mean, I can interface with a computer with you. I'm doing it through my mouth, through the medium of speech. I think we feel differently if I have to put something physically against my brain. Personally, I think that's okay. There was a difference of opinion here. You know, people wear glasses. You have something that's against your head. But you start to feel differently when it gets implanted physically into your body. We simply have a natural aversion. As John is aware, I've recently faced this head on, and one of the greatest ironies that I've ever experienced. I have a computer now that runs my heart. And, you know, it's inside my body. And we were just talking about interfaces to it and how it works and how I communicate to it and how it communicates to me. It's frightening and very, very upsetting. But the truth is, if it was external in some way, I would probably feel a little bit differently than I do internally. So when we talk about brain interfaces, I think we're crossing into this uncanny valley, a new uncanny valley of thinking, well, that's really gross. But the truth is we interface with our brains all the time through all of these different media.
I am always drawn to science fiction metaphors, and in this case, I'm drawn to the Borg from Star Trek. These technologies are two ways, and I think given what we saw with internet advertising, we should be afraid, very afraid. Did you have a question? Yes. Oh, sorry.
Thank you. So it took us about 20 years to record all the knowledge with World Wide Web. It was mainly done by humans. And unfortunately, the economics didn't work that well. You know, as you mentioned, a few companies managed to make a lot of money out of the data that were generated by, you know, everyone. And there's been a lot of debate about how we can fix this economics of basically data labor and privacy. Do you think that we do have a shot, we have an opportunity of do the version of WWvW in a right way that it still creates financial incentives for people to share data and it doesn't really lead to monopolies? You started talking about that at some point. I would like to hear more.
Thoughts? Is there an opportunity to do it right?
I'll step up and spear myself on that great question. Is there an opportunity? Yes, there is. Do we, and I come from Cisco and Intel, but I also come from the world of retail. Do we see consumers tossing their data out like confetti on New Year's Eve? Yes, we do. And despite all the conversations about, oh, privacy is very important to me and my data is very important to me, the behavioral reality is very different. I don't know. I would argue in favor of it. I would say it's necessary, that data sovereignty and the economic value of our individual data is very important. It's something to explore. How do we change consumer awareness? Not just the individuals, the brilliant individuals in this room, but individuals back in my hometown of Fort Wayne, Indiana, who are just tossing it out. You know, how do we change that? I don't know. It's a great question.
Just very briefly, to me the issue isn't that you're willing to give up your data, it's that you give up control of your data. That's really the key issue. I don't mind if Amazon's got a lot of information on me. What I want to know is what are they doing with it and what further control do I have over that data? And that's a whole different kind of discussion. So when we talked about, as Chris I think did, you know, well, is it on my device? That would seem to be a way simply to maintain more control over it. And so if we start to think about that as the problem, you know, what rights are you giving away when you deliver your data? that would color the conversation in a different way, and where we store it and who has access to it and all that would be much less of an issue.
One last question.
So if in a world without oval, the monopolies, if you call them monopolies, have quite a bit of power because there's only a couple of them in the first instance case. But if oval were the FCC way, if investing in oval, is that a way to lighten some of the pressure on the big companies if there is a third? Is there a role for policy in supporting oval?
Repeat the question.
Oh, do you want me to ask that again? Okay, sorry about that. Is there a role for policy as the FCC or other regulatory bodies put pressure on the large tech companies? Is there a way that by supporting or participating in a community that is not so proprietary, that helps to lessen some of that external pressure, meaning it also provides support for the oval community?
John, you want to give it a shot?
Two things in response to your great question. The first is there may not be recognition. There's recognition in Washington, but there's not action. But there is recognition in Brussels. And as we read the materials coming from the European Data Protection Board, we take a look at the EU's recent work statement, draft statement, I can't think of the right word, on IoT systems. There is a clear recognition that, let's call it a dominance, may not be in the societal interests. There's also, and this is said with love and respect for Almond, but there is an entire ecosystem of independent and increasingly open voice agents out there. And I could rattle off a number of names, and if I start rattling them off, I'll forget somebody, and then I'll be in trouble. But there's a wonderful ecosystem, and they're going to be learning from Almond and sharing back and forth. And so it's in our interest to be pushing toward standards, to be giving, I think, very high awareness of Almond, Oval, this whole initiative, as well as the other great firms out there that are offering increasingly enterprise alternatives to the dominant players. Great question.
So I think we're at the end of our hour, and could you join me in giving thanks to the panelists?
Thank you, John. Thank you, panel. Good to see you all.
Not sure when we wave we get seen.
Okay, welcome everybody. We are the post-lunch hit parade here. Thanks for sticking around, and it's good to see everybody. It's good to be back on campus. I have been out of town for over a year, and I'm thrilled to be back. It's just delightful to be here and look at these beautiful palm trees and safe and good. So, welcome. My name is Ann Grimes. I am with the Starling Lab. Hold on one second. Turn this off for me. Thank you. Turn it off permanently. Okay, I apologize for that. My name is Ann Grimes. I'm with the Starling Lab for Data Integrity, which is here at the School of Engineering. We are a new research center, and we are focused on building a fellowship program and a research program that focuses on the use and prototyping of Web3 technologies to improve data integrity as applied to information systems, including journalism and digital media. So we're excited to get that launched, and you'll be hearing more about us this fall. So our panel today, let me introduce our guests. First, in alphabetical order, Edward Chang, who is the Chief AI Advisor for Smart News. Edward is a professor of data-driven deep learning. He's an adjunct professor here at Stanford's Computer Science Department. He also serves as the president of DeepQ Healthcare, a business unit of HTC, and as an AI consultant at Smart News. Prior to his current posts, Ed was a director of research at Google from 2006 to 2012, leading research and development in areas including scalable machine learning, indoor localization, Google Q&A, and recommendation systems. Between 1999 and 2006, Ed was a full professor of electrical and computer engineering at UC Santa Barbara. He joined UCSB in 1999 after receiving his PhD from Stanford University. Welcome. Can everybody hear me, by the way? Okay. Chris Dix, down on the lower left as we look at the screen. Chris is the head of architecture and product at the BBC. He is accountable for managing technology strategy and architecture across a range of BBC products, technologies, devices, and modalities, including smart connected devices and emerging experiences. Among his many responsibilities, Chris has developed a diverse, multidisciplinary team to drive an overarching strategy across web, mobile, and voice. The team nurtures emerging technologies such as voice from initial concept through to audience-facing propositions at scale. Welcome. Thank you for staying up so late in the UK. Hugh McRory joins us from Vermont. Hugh works at the intersection of data storytelling and emerging technologies. He is the co-founder of Sonify and currently leads a Knight Foundation-funded project to make open data more accessible, mentoring teams of hyperlocal newsrooms and advisors from the blind and visually impaired community to create sonifications that enable data-driven podcast storytelling. He led creative development for Two-Tone, a free web-based open source tool for data sonification that allows users to sonify a data set without writing a single line of code. Built with support from Google. It was built with support from Google. Earlier, Hugh ran a film and animation studio in Ireland before completing a residency in 2007 at Yale with the scientists in the School of Medicine's Cellular Microscopy Lab. Since then, he has led teams from ideation to execution on 4 web-based software applications for data, virtual reality, and spatial audio. He was a finalist for the Gannett Foundation Award for Technical Innovation in the Service of Digital Journalism in 2019 and winner of the Online News Association's Journalism's 360 Award in 2018. welcome you. Good to see you. Kathy Pearl. Kathy is the conversational design lead at Google, where she is a design manager on Google Assistant. And she also is the author of the O'Reilly book, Designing Voice User Interfaces. She's been creating voice user interfaces for over 20 years and is passionate about helping everyone make the best conversational experience possible. Previously, Kathy was VP of User Experience at Sensely, whose virtual nurse avatar helps people stay healthy. She has worked on everything from programming NASA helicopter pilot simulations to designing a conversational iPad app in which Esquire magazine style columnists tell users what they should wear on a first date. Welcome. Lowell Robinson, you are down in the right corner. Lowell recently joined KQED as its first ever senior producer of voice and AI. Lowell is excited to be inventing, planning, and building new products and experiences to bring life to KQED's mission and content in the new mediums of the 21st century. Earlier, Lowell created and as digital director led the Digital Experience Lab at San Francisco's Exploratorium, a prototyping, production, and incubation group that blended emerging technologies with the Exploratorium's tangible approach to inquiry-based learning. A fantastic place if you haven't taken your children there. Welcome, Lowell. And finally, Richard Socher. Richard is the founder of U.com, which launched yesterday. Congratulations. U.com is an ad-free, privacy-preserving open search engine platform that summarizes the web for users with extensible apps, superior privacy choices, actionable results, and personalization through preferred sources. Prior to U.com, Richard was the chief scientist at Salesforce, where he led the company's AI efforts. He joined Salesforce after the company acquired his first AI startup, MetaMind. He too received his PhD from Stanford. Thank you for coming. Welcome. Okay, so our topic today and our goal is to unpack the open voice information ecosystem, to assess what's happening with the current voice ecosystem and consider the use of voice in journalism currently and in the future. So I'd like to start with those who may be the closest to the news, Chris and Lowell. You both work for two of the largest and most well-respected media outlets, one based here in the Bay Area, the other an international global force. So I'm going to ask both of you to tell us a bit about what you've got going at the BBC and KQED. Briefly, and I'll drill down a little bit, but to give a framework, what are the opportunities presented by voice, virtual assistants, in the application of news? What are the challenges? What have you tried that's worked? What hasn't? We heard a lot this morning about a lot of the technologies, and I'm hoping that this panel will bring some of the academic discussions that we had and the technological discussions that we had earlier to life, because everybody, hopefully, is interested in the news somewhat. And there's a lot of experimentation and growth happening with virtual assistants and voice in our newsrooms. And a lot of experimentation, a lot of prototyping. So, Lowell, let's hear from you first. Let's start with our local news organizations. When you and I talked, you said that you had seen a surge of smart audio listening, and especially during the pandemic at KQED. You've got a variety of voice projects and prototypes to inform workflow, content development, user interaction in a voice-first environment. So I'm wondering if you can talk a little bit about your observations on the past I don't know, couple of years with the surge of smart audio listening. And tell us more about what's happening with voice and AI at KQED, and give us some examples of the projects and prototypes you're working on.
Sure.
Turn it over to you.
It's really great to be here, so thank you for the opportunity. So this morning there was a moment where Tony Espinoza asked Jeannie for the news, and actually asked specifically for arts specific news in San Francisco, and that's a pretty large part practically of what we do at KQED. We take a look at all of the content that we produce, and we think about how we might want to reformat it or edit it to make it work in a space like that. So that if you were to one, could you find it? But if you were going to hear it, how long would you be willing to listen to? How would you know that the thing that you asked about was the thing to respond to? Because I think with audio, it's a lot more challenging from a visual part of saying oh, is this set to the right context? Is this what I was expecting? So a lot of what we do is try to think about, from a very practical standpoint, our content, does it match this medium well? And what workflows do we need to create for that? And how can we think about what adjustments we would want to do to that audio for it to fit into a voice space? So that is from the very practical standpoint, but we do go to the more experimental, where we create prototypes both internally and externally to be able to say, how might we push on voice? What more might we want to do with that? So that if we wanted to explore content further, if we wanted to be able to ask for something specifically, how would that work? And so that could be, again, more practical examples. I think I mentioned to you that we did a voter guide for California for the propositions. And so you could ask for a proposition, you could describe a proposition if you didn't know its number, and say, hey, I really want the one that talks about stem cell research. Which one is that? What's a yes or no vote mean? And to be able to have that conversation with a trusted, from the reporters that did that you're familiar with. So I think that there's a lot of opportunities for news to continue the conversation with listeners, to be able to have the intimacy of voice, of being able to almost feel like you're talking directly to reporters or to the outlets. And we definitely want to explore what that could be. At the same time, public media pushes on the idea of conversations. And I think that voice itself, because of the very nature of using voice, promotes conversation. So we've done prototypes with what would that be like to have a voice interactive that could mediate a conversation for you and your friends over a topic, right? So how maybe it could interview you. It's not so much that it needs to know what you're saying, as much as it's really getting the conversation started with you. And I think that public media is in a really good place to be able to have that trust and relationship with people. So those are some of the ways that I think that voice can be explored.
Cool, that sounds great. So how successful, quote unquote, was the California proposition initiative that you undertook? And what were your KPIs there? What was your measure of success?
Right. So in a lot of ways, what most people think about when they're using voice is the idea of I'm gonna go to my device and I'm gonna say play KQED and I'm gonna hear the live stream. Not necessarily gonna even ask for a specific piece of content. So when we're pushing into news specific areas, say in this case the California voter guide, there needs to also be a promotion that third parties need to do to be able to say hey, this is something that's available. How do you even know that it exists? So I think that we could have been even more successful with saying like this was another avenue for you to be able to find. But for the people that did find that, which was really in the hundreds, not the thousands, we saw a lot of use, a lot of engagement. So that was really promising for the future. But I do think that discoverability is something that is probably challenging for anybody in this new voice ecosystem. Like what's the thing that you use regularly, and how would you find or know that it's even there?
Okay, that's interesting. You also mentioned a local initiative that you folks undertook, KQED Now, which can you talk a little bit about how that initiative is unfolding and what its reach is and what are the technologies around that?
Sure. Yeah. Well, I mean, I think one of the things that feels pretty different about news right now is that while many of us are listening to live streamed radio over digital formats, we also hear algorithmic playlists, right? Playlisting is a huge way that many of us consume news right now. And so the idea of how we're breaking apart stories and how they're put together is what a lot of digital products are, right? And so what you might experience news on Spotify would be very different than, say, on NPR One. So KQED Now is actually an internal prototype that we're doing. It's a miniature version of us just really trying to see if we were going to be all local and take all of our stories of the day, what would that look like? And how you might have control of going through those stories to, which ones would you want to be able to have and how would that develop and how would you connect those together and give them enough context so that it made sense. So that's really something that we're doing as an internal tool in the newsroom to be able to work with editors and producers to be able to see how we would want that content if we had complete control over how that would work. Again, I think it lends itself to discoverability of how would you find that, and I think that's the part when you're deciding would I want to put that out into the world is that the way that we want to put all our eggs in that basket right now to say that's the way that you should consume news right now. I think that for the public to even know that you can go to your device and say play KQED or play the news or play NPR, like that's kind of the first step, is to let people know that they can do that before going in too deep into something really, really specific. But I do think that the possibilities are endless that way of where it could go.
Before I turn to Chris, one last question. It seems like this is an opportunity to build community on the one hand, the local news initiative, as well as interact in an interactive way with my device. And create community and conversation, which always isn't friendly, as we have seen as regarding the news, and we're going to talk about that with Ed. Did you go that far?
Right. So I think that voice does lend itself to the idea that participation can be content. So that in the same way that, let's say you were listening to Forum and you decided to call in, that you are now part of that episode. You are part of that news. We did some earlier journalistic stories and continued to do with interactive stories where the content that you can add to the content by participating in the story, that questions are asked of you and that your answers then contribute to the story as the next listener listens to that. Actually, one of the one of the earliest stories we did that with the Voice Bar Chronicles. We interviewed Kathy Pearl, and so while that was it was a story about voice, but it was done with your voice to be able to match the medium and for you to be in that space. I think that those types of experiments of how you want to like engage with this type of technology, again, sort of goes back to trust. I think that public media is in a really great position to be able to have that trust with the audience, for people to be able to contribute, for people to have that fluid interface of using voice to be able to communicate and share in ways that we haven't done so far. I think it is a really exciting space. Of course, I think the caveats that you're bringing up, which is there can be many in terms of like how does that work into this space, is for us all to sort of figure out.
Okay, great. Thank you. So let's turn to Chris. The BBC has developed OK Beep as a new way to ask for content and a way for your audience to interact with BBC. So it responds to requests from viewers and listeners for programs and content. It makes it easier for audiences to find news and entertainment. The BBC was one of the first major content providers to support voice devices such as Amazon's Echo and Google Home. How's it going?
It's busy. It has been very busy. I'll give you a little bit of background on what we've been up to.
Sure.
So we formed a team back in 2017 with a handful of people and quickly scaled it up to around 100 people at its peak. And over the last few years, we've built out a number of voice experiences and experiments, which include things like what we refer to as the BBC main skill, which provides access to all of our radio feeds, podcasts, and audio on demand. We've basically tried to go across the breadth of a lot of BBC services. So we've also built our kids experiences, which provides access to games, stories, and songs through leveraging things like branching narrative technologies. We have interactive news. We've got that very much in the UK. We did launch interactive news out in India a while ago. We also built our multi-platform chatbots that focused on bringing BBC and NHS, which is UK National Health Service, bringing that data together to bring real-time COVID information to audiences, and that went well. We brought talking articles to some BBC articles, and this is where we developed our own synthetic voice based on Microsoft's neural TTS technology. We've also, I suppose from a journalism point of view, we've also invested a create once, publish everywhere workflow, start to investigate that. So we could take a written article, generate that in the local language, and then publish across 42 languages that we support. Plus a number of games and interactive experiments such as natural language search, embedding conversational capabilities into existing BBC products, and also experimenting with synthetic video representations of written content. But whilst building out these experiences, we were able to develop a collection of technical capabilities that which formed into a platform called CAS. And CAS stands for Conversation as a Service. And this platform enabled us to assemble low latency conversational capabilities into a voice assistant pilot known as Beep that we were talking about. And building Beep really enabled us to experiment with audiences, understand what technical capabilities would need to support a multi-platform system, and how conversational capabilities could support existing BBC products in the future. It also importantly enabled us to work with industry and contribute to the Open Voice Network. I know you've got John with you today, and also contributing to Amazon's Voice Interoperability Initiative and some of the more local conversations with the European Broadcast Union. But also during that journey, we didn't just build out some really great experiences. We also tackled some key areas such as the capture, storage, and treatment of personal data, user-centered design for voice applications, and feedback loops that not only help us further understand our audiences, but as well as improving the technologies we leverage. On top of that, we've been innovating around new multimodal formats, which I refer to as polymorphic content. It enables a couple of things that the voice really brings to the table. So firstly, we can start to think about content differently that is portable. So a single piece of content that can adapt to different forms and modalities based on user context, device, and topic. But secondly, it starts to think about content that's designed to cope with varying degrees of transformation in enabling its application on a single modality or across multiple modalities simultaneously. Now, natural language capabilities play a significant part in bringing these new formats to life. So where are we now? So we've been quite busy, as you can hear. We're now at a point where we've done a huge amount of experimentation, and we're now distributing technical knowledge and capabilities, including editorial knowledge as well as technical knowledge across our products. And we have a number of future-facing work streams in place, such as polymorphic content, which I just mentioned, and also a great piece of work that we're calling knowledge services, which aims at, these are sort of underpinning services and capabilities to really empower conversation. So this aims at extracting knowledge and content and connecting it in meaningful ways. And this builds on a collaboration that the BBC's had with the University of Glasgow, where we're working together and using AI to facilitate meaningful natural conversation between a human and a machine. So we've been really busy and we've learned a huge amount, but we've only scratched the surface. And that's where we are at the moment.
That sounds awesome. So two quick questions. Following up on what Lowell said, how have your audiences responded to your new offerings?
I think the testing we've been done has been positive. Some of the work we've done, we purposely haven't put out at scale because it's really testing, experimenting before they were to go mainstream. But the interesting things that we've found is certainly reaction to understanding. Seems to be a good level of understanding. We've put the right feedback loops in place to start an analytics, to start understanding how long someone's engaged for, so you start to understand how much they're really getting out of an experience when they're fed up and they leave. Also return. So we've also built in things like conversational history, so we can pick up where you've left off from, and then we start to learn a bit more about the user and how they've interacted. So they're not always going to get the same things again. And some similar experiences Lowell was talking about as well around interactive news. So you can dig deeper into news articles, you can ask for more, you can go to different places. I mean, the opportunities are endless until you start adding in different modalities as well. So start thinking about the different contexts where the narrative changes. Again, I think you mentioned this, Lowell, as well when you were talking. It's you start introducing a screen into this as well as voice. The content changes. It has to flex and it has to be portable. So it's there's loads of interesting opportunities to dig into in this space.
That sounds super interesting. One of the challenges I wonder for you is, given that you have such a global audience, how do you find the right voice to reach that multifaceted audience?
With a lot of user research and a lot of testing. Now the voice that we built was a sort of a northern UK voice. A male voice, and it's gone down well. You know, it's not a sort of typical sort of central London Queen's English voice. It's not the typical voice that you might have thought of the BBC. It also has different tones to it as well. We spent a huge amount of time, working with Microsoft, fine tuning these voices, bringing in different tones, and it's brilliant. I mean, it's not just us saying that. There's other companies have reviewed it, had a look at it, and it's really impressive in what we can do.
So would you say that Beeb has a persona or a personality?
Yeah, to a certain degree. Certainly, there's a persona has been developed. But I say it's sort of very early days. I think one of the interesting things to start thinking about is how does someone grow up and evolve with your service? So where persona, in terms of the way you might interact with that individual, might change. It's like when with someone maybe interacting with an assistant, and they're sort of early stages of school. And then they start to grow up, and you might interact with them differently. And I think you might start feeding them different content, maybe a bit more sensitive when they're younger and less sensitive when they're older, and those sorts of things. So I think there's a lot of opportunity there.
So before we turn to Ed, I wanted to ask about, because the BBC is such a trusted news organization, and because we are in these fraught times, does thinking about the context of news figure into what you're doing practically? How do we set up a story? How do I know what I'm hearing? Does it sound like a newscaster? Does it we have such confusion over news reports and opinion reports. Can that translate into voice? Is that something you're thinking about? I mean, it would when we know we're watching CNN and people screaming at each other, it's opinion, but it's not labeled as opinion, it's labeled as news. And I think the populace at large, is my 2 cents, is very confused about all of that. And so I wonder about how you think about presenting context, news in the context around news, straight news reportage versus opinion. And does the voice change, or how does it?
Yeah, but I think the voice has to be sensitive to context, whether it's serious, whether it's not so serious. I think obviously I'm not a journalist by trade at all, so I can't talk on behalf of journalists. But attribution and context and providing clarity and transparency around the content itself is really important. Even looking at things like summarization techniques and those sorts of things, I think there's a long way to go before we can really automate a lot of these things. I mean, we did a bit of work a while ago looking at text-to-text translation into different languages and using those through and presenting those in a sort of a voice modality. It's not quite there yet. I mean, even doing text-to-text translation can very much change the narrative of a story. So there's quite a way to go, and I think that a lot of these, maybe some of the automation techniques that we're looking at around voice are more assisted techniques rather than automation techniques at the moment. So I don't think they necessarily replace anything. I mean, it would be great to take content and just scale it out to 42 languages straight off the bat, but I don't think we're there yet. Also one of the things that we've learned is content that's created for reading doesn't necessarily translate very well for speaking. So, but the other way around, the journalists that I've spoken to would say that if we'd written this for spoken language, it translates very well for reading. So, there's a lot of things that need to be. We need to dig into a lot of those areas. I think we still need to be cautious. But I think the great thing is the maturity in technology is there in a lot of cases, which is great. So, voices are sounding very natural. We can put tone in. We can deal with pronunciation. There's a lot of maturity in the technology we're using. And it's, even within the last 2 or 3 years that I've been involved in it, it's come on leaps and bounds already.
Awesome. That sounds great. Okay. I'll come back to you about what's next in a minute. Let me turn to Ed and Kathy. You both have worked for a company that has paid a lot of attention and put a lot of energy into virtual assistants. And Ed, you've dabbled in this area for a while at Google with recommendation systems, Google Q&A, and now you're consulting with Smart News, which is a popular news app that delivers culturally relevant and country-specific news from trusted sources. It's a really interesting and good service with lots and lots of, I think it was the app of the year recently. So we were going to talk about political polarization and how smart news has dealt with it, why voice, not cold text, could possibly make a difference. We can talk about bias and how that figures in, how your algorithms are structured to tackle that, style of delivery. But we're in a very, politically charged time. We just had elections last week, and it's a precursor of rock and roll to come. So share your views.
Yes, as we know of, Google, Amazon, and so on and so forth, all these social media companies, they would like to provide information relevant to users' interest. And that's really important because if you provide information which is not relevant, the user is not going to click on it, and the company cannot make profit or revenue, right? But Smart News founder Ken Suzuki, the company was founded in Japan. He has a passion of addressing this political polarization issue. And this is a very challenging problem. And let me talk about what's the current implementation and the problem we have faced. The current implementation is if you get into the politics category, you click on a news. And that news at the end will have an information dial. On the left-hand side is color blue, right-hand side is color red, right? You know what do the colors means. And you can just move the dial from the left to right. And you can see opposite opinions and when you read a particular default news. And however, there are a couple of challenges. One is not really a lot of people using that. And we were positing why, because this is kind of good social service. And by doing so, actually the company is sort of decreasing revenue, right? Then we read an article written by Chris Bell's team, and the paper was published on the proceedings of National Academy of Science. And basically, the team did an experiment, and they used Twitter to try to tweet people with different opinions of articles. And the result shows the people getting those opposite opinions, they are getting even madder. So the metrics to measure whether they like the recommendation information is whether the user will retweet the information to other people. So when opposite information get tweeted to the user, and the average retweets were decreased. So that was kind of surprising. But talking to myself, I say, well, that's reasonable, because if I read it for vaccination, for example, and if you send me anti-vaccination vaccination information, maybe I would, not only wouldn't read it, I would be kind of get upset, right? So then the question is, how can we make it effective? And using just text only to forward information which you don't like, for sure, I think most of people would just say, what's going on? The site is really stupid. But to convince another person, especially a different opinion, we start to consider maybe voice is a much better media. Because when you try to convince another person, you don't send a whole piece of text saying, hey, this is what other people said. But you want to be gradual, want to be gentle, want to be polite, and perhaps you want to add an accent, whatever, to the conversation to make sure this whole dialogue is personal, right? So that's a starting point we think about. Maybe we should, working with Monica's team, to see whether we can use voice to try to achieve our agenda and try to mitigate this political polarization problem.
That's interesting. So leading up to Kathy, you're sort of talking about the art of conversation and how people get along. And Kathy has pointed out elsewhere that the rule of how people talk to each other is called the cooperative principle. That this is a phrase coined by the philosopher Paul Grice, and it describes how people can get along in common social situations. The four maxims, as she's pointed out, are try to say stuff that is true, don't lie. Don't say too little or too much, simply say what's required to get your point across. Stick to the relevant details. Don't include a bunch of information that has nothing to do with the topic at hand. Express yourself clearly. Avoid things like ambiguity. So can those rules of the road be applied to this realm of audio news and interacting with our virtual assistants so we're not slapping them?
Right. So, and your suggestions actually also not just voice itself, even text recommendation have kind of having the similar issues. So the technologies may not be there yet, as we have heard from BBC and the ESPN, like news summarization, sentiment analysis, and exactly this particular article is on the left or to the right. Those kind of analysis, the technology is just not there. And in addition, I consider when we talk about voice, it's not really the classification itself, but the delivery of the message. How can it be more gentle, gradual, polite, rather than invasive, intrusive?
Kathy, would you like to respond to that? This is something you've experimented with for over 20 years.
Yeah, I think it is hard because there's that saying about if you design for everyone, you design for no one. So you really have to be, is there a way to design something like a general purpose assistant or a news assistant that meets the needs of lots of different people? And one way to do that is to provide something that's generic enough that maybe no one will love, but no one will hate. But if maybe you want to take a different approach where you're going to create something that's really interesting and fun, and a bunch of people will love it, but a bunch of people will also hate it. But maybe that's, and in the entertainment business, that might be a very fair choice. So it depends on what your goals are.
I'm sorry?
It depends on what your goals might be then.
So can we find a solution to these kind of fraught conversations about, can voice help us there?
I think it can. I think we're still, even though this technology has been around for a little while, we're still really figuring it all out. In that Grice's maxim, one of them is about saying too little or too much. And it's important to look for signals from your user about whether you're talking too much, just like you would as a human. Like, is the person looking at you like they're bored to death? Or do they seem engaged? Are they saying, oh, tell me more? And so we should look at those types of signals when we're saying, maybe talking about the news. If you introduce a story and they say nothing, or they quickly go to the next story, maybe they're not interested. Maybe you want to check in, as humans often do. Like, do you want to hear more about this? Would you like to hear more about this other thing? And find a way to involve them in choosing what content you are going to not just push at them, but maybe let them decide more.
And there are technological solutions for this?
I would say not just technical solutions, but design solutions. A lot of times we think that the barriers are in the technical side, but often the barriers are in the design side. Like, just thinking about at the start of COVID, we had to quickly mobilize to be able to respond to all the things that people were now asking that they had never asked for before. Like, what is COVID? Do I have COVID? All these things, and we had to quickly figure out what people were saying and figure out what to say. What about when someone says, does Kim Kardashian have COVID? What is your responsibility to respond to that? Well, one thing you could do is say, I don't understand, but maybe be more helpful to say, I don't actually know that, but would you like to hear the latest news about coronavirus? So you might find an opportunity to introduce something related, like Lowell was talking about discoverability, huge problem. Are there ways to insert things into the conversation that are relevant, that might cause them to know, like, oh, I could also ask about this thing? I didn't know that. Yes, I'm interested in that.
Cool. So looking back and looking ahead, as you've worked so hard and well on developing the best conversational experiences out there, what surprised you? You and I have talked in the past about why Siri and Alexa and other VAs needed a feminist reboot. How does that fit into this conversation?
Yeah, it's great to hear about Chris talking about the more non-standard, not just Queen's English, but a Northern accent and a male voice. I think, to me, one of the best things to do is just to expose and normalize people to the fact that there can be lots of different voices, not just male and female. You could have non-binary voices, different accents, different dialects. And one thing I actually like about Google Assistant is when you first start using your Google Assistant, it's 50-50 whether you, in the US English market, whether you'll get a male sounding or a female sounding voice. It's not enough just to provide choices to the user, because a lot of people never change their default values in an app, whether it's a voice app or any kind of app. So you need to find a way to let people know, like, actually there's a lot of different voices out there. It's normal, and not have them, gotten to this expectation that it must sound like a young white female.
Cool. Great, thank you. So Richard and you, let's turn to you guys and some new features here in Search and Sound. Richard, congratulations again on the launch of U.com. One of the current concerns about using virtual assistants is privacy. And we know from our earlier conversations this morning that there are a couple big companies that are controlling our data as we use their devices. U.com allows people to search privately. Tell us more. How does it work? And what are your thoughts for integration with virtual assistants and voice?
Yeah. I think a couple of things have changed in the last 20 years since we've had some innovation in the search engine market, which is still in the US especially the starting point for a lot of people's internet journeys. And when you think about it, 20 years ago, access to information was a problem. Nowadays, the access isn't the problem anymore. The problem is that there's actually too much information, and we don't know what to trust anymore. So we need summarization technology. We need technology that helps us actually make sense of it and help us navigate all of these things. And so that is one of the many different ideas that are behind U.com, WWw.com. I encourage you all to sign up. We just launched yesterday. It's fully open now in all browsers. You can replace it as your default, though indeed those are tough choices to make. And in some cases, platforms don't allow you to have a choice in that. So if you're on a mobile phone, you can't actually change your default to a new search engine on any of the platforms because they prevent that. But I think in terms of privacy, it's important to understand there are lots of different dimensions to it, right? I think people are now waking up more and more to the fact that they make a search on Google and then that search will follow them around the internet. And clearly a lot of different organizations know now about that. And so we believe in privacy, but also in choice. And choice is sort of reflected in many different ways. One is you can have a personalized mode where you actually have agency over the kinds of sources that you see, and you can say, I want to see more of that source and less of that other source, which then also might lead to more polarization. So at the bottom, what we're working on is to have a discovery section, is what we call it, where you see the opposite viewpoint to try to get people closer to a common language and of discourse. But you also have a choice when it comes to your privacy and be in this personalized mode that knows where you are, where you can ask like restaurants near me or my best Thai restaurant in this area. And you get the right answer, which is fundamentally not very private because you want a localized result. So somewhere, some organization and API backend needs to know where you actually are. But maybe you want to ask for some funky rash and you don't want the world to know that you have it, or whatever else you might have reasons for privacy. You can go into our private mode where we don't store anything. And I think that's something that is also important and maybe something to think about for a lot of voice assistants is how do you ask a private question and how do you ask a question that you're fine the world knowing. Like maybe you love the Foo Fighters, you just play me a Foo Fighters song and you don't really care. And then I think there's maybe an elephant in the room here, which is a lot of the underlying NLP technology for full voice, sort of straight up conversations is just not there yet, right? It's really hard to keep state around. You talk about something, you refer back to it later. And it's really hard, especially with summarization, to know what is the right level of abstraction or knowledge for a summary. Summaries are ultimately very personal. And so that's why I think agency has to come in there and people need to be able to give feedback to these systems.
And so I looked at U.com this morning, and it's a great comprehensive solution. I would encourage everybody to check it out. It's really awesome. And explain to us a little bit more about how voice, how it's integrated with voice. I can ask for these if I ask my device for, I go on u.com and I ask, how does it integrate with the VA? That's my question.
Great question. So I think, the true answer is right now we don't have any voice technology on u.com, just a level set. The truth is when you ask for like restaurants near me, you don't want to have a voice assistant tell you, you have 45 restaurants. Restaurant number 1 is 2.3 miles away, has a 4.5-star rating, and blah, and then you like 2 hours later you have the list of 45. You just want to swipe through it. So I think we have to realize also that the right voice devices are going to be multimodal. I'm excited to collaborate with folks in this community, actually also with you. And we looked at all sites to select sort of more centrist news sources too for our default options, but which is kind of similar. They let you choose the sites. But we'd love to collaborate. But I think we have to acknowledge that voice is, I think, best used often in multimodal setups where you have visual feedback and in visual interactions. The few times I use voice frequently are just very, very quick informational questions, right? You ask Siri something and you hope that if Siri gets it, you can avoid having to make a query in u.com or any other search engine. And so, yeah, that's one place where I see a lot of connective tissue.
Because many people say to go to the next step, we need to be able to search with our voices, and so you have your
we're building the platform that will allow you to search through all your favorite sources at once. You can see what does Reddit say about something, Twitter, the general news, your favorite news outlets, and have one search that basically goes through all of your favorite places in one place. And so, yeah, there's a lot of potential to connect that to voice.
Okay, well, it's part of the goal here is for people to connect, so I hope our panelists will connect because I think there's lots of opportunities there. So thank you. Let's turn to you and tell us a little bit about your exciting research and your companies at Sonify.io. We talk a lot about data visualization here, but you are talking about sonification of data. And it seems like it's a first step toward a new opportunity to integrate with voice and news in different ways.
Firstly, I'd like to give the context that I don't think data sonification is the solution to anything. It's part of a solution. And I think that, also voice is part of what can be a web that is delivered as audio, whether we have pictures or not. We haven't had this conversation yet. We haven't developed audio. Audio was always an afterthought. We built visual interfaces because our computers were enormous and they sat on a desk. But now that we're walking around cities and now that people listen to books and navigate with GPS, we can see that audio with or without pictures is something that's quite useful. It's also heads up and hands free. You can multitask, you can do all these things. And initially I was looking at how could we take data from 2D to 3D in virtual reality. And because I came from like a kind of filmmaking background, I'm like, hold on, this doesn't have any audio. This doesn't have any sound. So the entire field of data is so heavily visual that it's called data visualization. And data sonification's been around for a long time. It's just like the way you would turn a spreadsheet into a bar chart. You can turn it into music or sound. And it it's hard to explain. I could probably play a quick example in a little bit of like what that sounds like. But the whole idea is that data sonification up until now hasn't been widely adopted because audio has not been widely adopted within our communications. But now, if we're talking about an audio internet, how do you get data onto an audio internet? Apart from using a voice or an AI to read out data sets, then sonification is a great way of doing this. And if you look at the official definition of sonification, it totally defines itself by not having any voice or any speech. And in the research that I've been doing, sonification doesn't work without speech. You need context to make it understandable. So the combination of sonification and speech begins to get really interesting because, language has limitations. Whereas when you combine language with other parts of audio, like music or sound design, and all the things that they can do, suddenly we can, you don't want three voices at once, but one voice, some music notes, and a different piece of sound, I can understand all three of them simultaneously. And that has a lot of potential interesting use cases going forward. Also, language is very difficult at conveying, it's very limited at conveying emotion, whereas music is incredible at conveying emotion and building social bonds, et cetera, et cetera. So I just think that, we need to broaden out the conversation to be able to see, okay, what can voice do? What can sonification do? And then bring in other people from outside of our technical domain to bring in ideas around what music theory already knows or what sound design for movies or gaming already knows about how to set mood and how to make really rich experiences that can work with or without pictures. So that's a lot of what I've been focusing on.
That sounds awesome. And yesterday you played for me a day in the life of a Basque community.
Yeah, I played a very simple example of sonification. It's not saying this is what sonification does in a broad sense. It's just an example. So what I played was the Basque region of Spain conducted a survey where they got people to write down everything they were doing for 15 minutes during a day, like were you traveling to work, were you eating, were you asleep? And the beauty of sonification is that you just set it up and then the data creates the music. So it brings this amazing element of creativity and play and works with non-technical audiences. So I'll play you just a little bit of what we did with this. And we didn't affect the music at all. The data is creating the music. We just assigned the instruments and set the filtering. So hopefully you can hear this. So this is people beginning to wake up. Now they're traveling to work. So yeah, all of that is just generated by a spreadsheet. But what it does is it paints a picture very quickly of what an enormous amount of data contains. So it's extremely useful as a way to summarize or a way to give people a flavor of what's coming without using speech or combining it with speech so that they could know, do I want to go in and listen to that or do I want to hit skip? So yeah, I think that we need to go beyond these definitions. Most examples of sonification, like if you go to the international community of auditory displays, you just hit play and it's lots of beep, 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 beep without any context. It doesn't have the voice. It doesn't have the type of storytelling that KQED can combine. Like we're looking right now at how can we combine data sonification within news in podcasting so that the podcasting brings the stories, the personalities, et cetera, et cetera. And, you know, we've been working with a lot of advisors from the blind and visually impaired community, and also, you know, electronic musicians and sound designers around how can we use audio to tell stories in new ways. So essentially, you know, I love being on this panel because normally I'm explaining to people who do data visualization why sound is interesting. So it's super interesting for me to be able to talk to people who are wrestling with questions of voice and accessibility and new ways to interact with computers.
Well, thank you so much. This is super interesting. And unfortunately, we are out of time. This could go for 2 more days, but I hope that I'd like to thank all of our panelists. Thanks for sharing your experiences and what you're doing. I think you can see the audience that there's a lot happening in the news space with virtual assistants and audio and news, and lots of experimentation, a lot of prototyping, a lot of technical development. So there's lots to look forward to. So thank you, everybody.
Okay.
Thank you, guys.
Thanks.
Great to see you again.
Yeah, you too. So you say you've been away for a year? Have you been
Yeah, I was
living-
in Colombia last year.
Oh.
I had a year, and
Were you teaching online?
I was teaching. It wound up teaching online.
Okay.
Yeah.
But
So
you-
I was
so you
actually
were gonna go
there,
there, actually.
and then I was there for 8 weeks. And then the pandemic. So
Yeah, maybe there's some API.
All right.
And you could have a smart news app that comes up higher than a lot of the other apps. That would be amazing.
Well, thank you very much for helping with the panel.
Thank you, Kathy.
Nice to meet you.
Thank you, Anne.
Thank you. I wanted to mention.
I have to start.
So the
All right, so we are onto the next part of the workshop. We have a number of very exciting panels, and now we are onto a few sets of talks. And so we want to build, we want to scale to the WWW. We want to bring everything on voice. And what we're going to talk about in the next 3 lectures are, or 3 talks, are about how to build this ecosystem. And I'm going to start. And for this talk, we're trying to bring the technical community, is the NLP technical community together. And the idea behind this is that to foster collaboration, we want to propose a common representation so that we can all work together. And we've been working on the topic of Think Talk for the last 6 years, and we have used it for many different purposes. And recently, we have started seeing research groups using the same representation, and we believe that this is a good time to have a broader discussion with the community. And we just started working on this idea of coming up with a common representation. And we want to thank a few of our colleagues who have been giving us giving us comments and ideas about this topic, which is Abhinav Rastagi from Google, Professor Yusu, and Professor Juan Swan from Ohio, and of course, Chris Manning has also been helping with this effort. So we believe that it is very important when we have a new discipline to have a common language. If you think about the beginning of the web, right, we are just all learning how to put up the servers. And we got the language, the Java programming language. When you design the Java programming language, it kind of becomes a de facto standard, and everybody is building servers using this language. and the code gets shared across the industry, and things move really quickly. And besides Java, we have JavaScript and so forth. So what we need to do, what will bring the community together is that we have a common representation so we can work together. And what we want to do is to propose ThinkTalk as that common representation. Why ThinkTalk? Probably the most important reason is the fact that we have put together a full stack open source end-to-end virtual assistant that uses ThinkTalk. It is all available. It is the tools that matters. We want to put it out there, and we believe that this is how we can get a lot of people experimenting with virtual assistants rather than looking at it from a theoretical perspective for people who are outside of the few companies that are able to do the engineering work themselves. The other reason is that ThinkTalk is extensible. It is designed because it is a programming language for virtual assistants. As the virtual assistant grows in capability, you have to extend that representation. And ThinkTalk is absolutely designed for that purpose. And we have already tried it out, and we've used it in various applications. The focus of this discussion is transactional dialogues, which is really something that a lot of people are wrestling with today. But we have also shown that it's useful for the on-the-fly customer support and also provide interoperability across vendors and across assistants. So I showed this earlier. We have a full stack. It is all available. And out there, there's the audio stack, and then there's a dialogue agent stack. And ThinkTalk is in every part of the system. Okay, the input is represented in ThinkTalk. The context of the dialogue is represented in ThinkTalk. The semantic parser generates the state, the understanding in ThinkTalk. The ThinkTalk is executed, which directly gives you the results, and then the result is fed to the agent policy, and the agent decides what it is going to say also in ThinkTalk, as well as spitting out the natural language, which is then used as context into this contextual semantic parser. But this is only half of the story, actually. There's a second half to this. We talked about the fact that it is really expensive to train an agent, and we rely heavily on synthesis. And the synthesizer that we have is a multilingual dialogue synthesizer I kind of overviewed earlier. It accepts ThinkTalk. Okay? It actually accepts the grammar of ThinkTalk. And this is why that when you want to extend ThinkTalk, you can just change the grammar and you can feed it in, and the tools will work with this extension. The ThinkTalk really has two parts. There's a very small set of constructs. So for example, you have all the basic constructs that will get you all the database relational operations. Okay, so all the standard database operations are represented in ThinkTalk. You can do compositions and programming constructs and so forth. But the important part is that it is coupled with anything that you can supply in terms of database and API definitions. And that's where the richness comes in. For the different domains, you provide different information, and we're able to synthesize all the natural language and the ThinkTalk equivalent for all the different domains. So as you can see here, ThinkTalk is used throughout this whole, the whole software stack. And I just want to show you a little bit more about the synthesizer. We said that you start with the database queries, database and API schemas, you get an agent. So what I'm going to show you is how we generate the training data. So you start with the schemas and the APIs. And the next thing is that we want to be able to describe the same field in many different parts of speech. So for example, Spanish food or a Spanish restaurant is the same as saying a restaurant that serves Spanish food. There are different parts of speech. And we use the pre-trained language models to figure out all the different equivalent ways of saying it in all these different parts of speech, which is then used in a grammar template to generate sentences. And the sentences are clunky, so we again use a pre-trained network to generate paraphrases so that they will be they will resemble natural language. So now you have these natural language individual sentences. We have a dialogue model that will give you entire dialogues with a lot of variety in natural language. And then, because of our translation tool in this pipeline, we can now get to the different dialogues in different languages. Okay. So this is what you get when you adopt this, the Genie system. And as you can see here, everything has to work off a representation, and we are using ThinkTalk. So this is why we want to propose this as a common meaning representation. It is very important that we have a common language for collaboration. There are three main reasons. One is modularity. We have worked really hard for the last 6 years to put an end-to-end system together. It is very, very hard to find other research groups or educational institutions that can build up another full stack software chain. So what we are saying here is that we can agree on, we can use the same interfaces that individual groups, people who are focusing on natural language, natural language processing, maybe focusing on the semantic parser. There are people who want to change the compiler, they're changing the backend. So having a common representation is very important because now we can have different researchers work on different modules. And when we standardize on the representation, you can have standardized types, schemas, data sets, libraries, and tools, and this will encourage sharing and reuse. And last but not least, it is interoperability. Okay? So the way we design everything is like you have different databases and APIs. They share the common type. So results from the database can be used as inputs into APIs. So this allows interoperability. And this interoperability doesn't just have to sit inside a single company by having the same types. We can now share the information across vendors, and we can also have the virtual assistants interoperate at the same time. Okay? And so having a common representation is important, and having it publicly available with all the tools associated with it in open source is important. I want to emphasize that we have seen precedents of this already in the past. In the NLP field, Chris Manning has worked on this idea of universal dependencies with a lot of other people, and there is now a common standard for annotating grammar across languages, and there are over 300 contributors, over 100 languages. And in the compiler field, I worked on this earlier in my career, and we built the Swift compiler. It's really the first popular optimizing research compiler. At that time, I would say that about 50% of all the papers published in these compiler conferences are using our compilers because this is the first time they were able to absolutely compile programs written in Fortran, real programming languages and not just toy languages that we can do in academic settings in the past. So I think that this is very important, and if we can put this software out there and we can maintain it and establish it as a common standard, then we can absolutely move the academic and the research field. And I think that this is, from a little experience that we have done so far, we saw that it is very important because what we studied in the papers and how we reported it, all our understanding has changed completely the minute we got Genie up and running. It's like, oh, this is how the actual user interacts with a conversational agent. Okay? You cannot just do it with cooked data sets. So in the little time I have, I'm just going to give you some high-level ideas behind ThinkTalk and why we should try to, why we want to promote this as a common representation. So one important thing about ThinkTalk is it is executable. You have human on the one hand, you have computer on the other hand. Human uses the natural language. What we're saying here is that the computer should be using ThinkTalk. And that is it. There is no other intermediate representation, which is often used by many other semantic parsers. And the reason now is that ThinkTalk captures everything that the virtual assistant can do, and so there is nothing in between, and so we get the neural network has a chance to learn and translate directly from the language to the machine language. And I want to emphasize that, ThinkTalk is a programming language, and you really need a programming language to match the complexity and compositionality of natural language. There are a lot of people who are using slot value pairs for dialogues, and that is just not adequate. Let me just give you a simple English sentence that you would you can see the purpose for. Suppose I say, I would like the latest train leaving that will arrive by 9:15, please. Okay, it's a common request, it's just natural language. And you cannot just say, here's the values to the slots in a sentence. In order to capture that semantics, what I show here is the actual ThinkTalk code, right? There is no way you can simplify it. You are finding the latest train, I am sorting on the time to leave, and then it has to arrive by a certain time. This is very succinct, and there is just no way to get around it. And if I have any other intermediate representation, you would just have to figure out how to translate that into code. In our case, this is ThinkTalk. You get the code, you just execute it, and you get the answer that you need. And what it does is that it guarantees completeness. Anything that the computer can do can be described in the ThinkTalk language. The converse is that if you want to extend the assistant, then you have to extend ThinkTalk, and this is what ThinkTalk is designed for. All right, let me just show you some of the details of what it means to represent a dialogue. So suppose I have a conversation where the user has asked for food that is of moderate price. And so that's a conversation, that's the context. And the user enters the next sentence, which is, I'm looking for an Italian restaurant. At this point, we send it to the contextual semantic parser. And then it generates, it translates that into code. This is the actual ThinkTalk code that you are seeing. It is very close to natural language in a sense. I'm executing this restaurant, I need this price, and now combining the context with the sentence, I am now looking for a moderate Italian restaurant. Okay, so that's what the contextual semantic parser gives you. At this point, it goes through the compiler, and it compiles it, and then it runs the code. And in this case, it fetches a result. All this information is represented in ThinkTalk. So that's the representation of results. And that information is then used in the agent policy to decide what to do. And what we are doing is that the agent policy is coded, is algorithmic. It is not neural because many companies want to be able to control what is being told, what is being said to the end users. So for example, in this case, the agent recommends a particular restaurant. So that's a formal representation again, all that in ThinkTalk. So ThinkTalk is compositional, and I want to show you in a single sentence the kind of things that you can say match this grammar, which is when you want, it combines the when, it's a when clause, the get clause get information is basically database queries, and then you can also perform an action. Of course, everything is potentially optional. And the interesting thing is the filter. The filter says that I can qualify what I am doing with these simple operations. Let me give you a very simple example. Suppose I say, every day at 9 a.m., play the songs by Taylor Swift. From a ThinkTalk perspective, there is a when question, which is in this case, at timer 9, time equals to 9 o'clock. I am looking for a song, it's a database query. I am asking for information about Taylor Swift. The orange is the filter. And then you say, okay, you get the song, and then you can go play it. Okay, so a simple statement like this breaks up into all these different parts. This is very, very simple grammar, but the reason why it is rich is because if you have a lot of database schemas and APIs, you can hook them up together and create many, many possible combinations of sentences. So here's just a few examples. When rain is forecast, turn off the sprinkler. Book me a Spanish restaurant that is open past 10 p.m. in Palo Alto. I'm using this color to code up all the different components that match the grammar. You see, the grammar is very simple, but you can talk about many different things. Set an alarm 1 hour before my first meeting tomorrow, for example. So the meeting is maybe on Google Calendar. I need to set an alarm. So what we are talking about is hooking up functions from 2 different vendors. You say it in one single sentence, and this actually matches to a single ThinkTalk syntax. Okay? So I want to point out a few things about this language. We are completely type-based. Okay? So the minute I say that restaurants have opening hours, there's an opening hours, that means I can talk about before and after or during a period and so forth. You don't have to pick each domain and say, what are the things that I can say about that particular domain? It's just type-based. All right. So this is very powerful because most of the time people think of every bit of here is hard-coded intents associated with a particular domain. No, you just have to define the parameters, the type. Now you enable all the different kinds of conditions that you can put on the sentences. You can do arbitrary compositions. Set an alarm an hour before my first meeting. The Google Calendar returns the time, and then you are setting an alarm with it. And so this is all just based on type. So this gives you interoperability. We have a global namespace that allows us to talk about combining Yelp information to, for example, traffic and so forth. So what I show here is that a single sentence has many, many different parts. You can say it in one sentence. You can also do it in multiple turns in a dialogue. But all is captured in the same ThinkTalk language. So, I hope that with this I'm demonstrating that the importance of having an executable language and compiler. You don't want to have a simple representation in between. And the composition means that we need data synthesis. We have done a comparison with the various different representations. We'd say the closest thing to us is SM CalFlow from Semantic Machines. And I would say the biggest difference here is that we are open source. All the tools are available, whereas that is just not available today with SM CalFlow. Okay, we can go into details if you're interested, and you can come talk to me about it. So this is the basic idea. This is all about dialogues, but we have also other kinds of we have also applied ThinkTalk to other applications. Let me just quickly mention those. So today we have we have showed that you can create a customer support agent that can just read new instructions about how to do customer support, and it will perform the customer support without having to be retrained for every single task. So for example, in this case, you have information about how to redeem an Amazon gift card or create a Walmart account. Once the semantic parser is trained, you just read that and you can perform the operation. And we have seen pretty good accuracy on this. Another thing we have done is we have interoperable assistants. When we have a private assistant that we can trust, we can now use these assistants to share with each other. So here's just a scenario where you may have dad saying, okay, I can help you. Alice, you're out of town a lot. I can help you with managing your security camera when you're out. The dad can just say it in English. Alice can respond in English, in natural language, and they can negotiate. Alice says, oh, not when I am home, because you will be monitoring what I am doing. That is not a cool thing. So you have the humans on the two ends, and then you have the assistants talking to each other, all using ThinkTalk. So we have shown that ThinkTalk has been is supportive of interactive agents. And we have shown that it's good enough to express like 85% of the constraints of people wanted to do in a user study that we have done. So I really, in conclusion here, we have spent a lot of time in the design of ThinkTalk, and we want to invite the community to join us here, to look at ThinkTalk and see if you can use it in your projects. And the selling point here is that we have a lot of modules that have already been implemented for ThinkTalk. It's extensible. It has been used for various applications. Well, thank you. That was a lot of material in a very short time. But we have 2 more talks coming up. And the next one is by Paulus, and he is on Zoom.
Hi, Paulus. Welcome.
Hey, Giovanni.
1 second that we put, oh, you're on.
I'm on?
Yep.
There you go. That was quick. Awesome. Okay. Welcome, everybody. My name is Paulus Schoutsen, and I'm the founder of Home Assistant and Nabucasa. I'm going to talk today about an open Internet of Things ecosystem for voice. I will not be talking, describing the requirements, but I'm actually going to talk about the system that we've already built. The system is called Home Assistant. Home Assistant is an open source home automation platform that puts local control and privacy first. This means that if you have, it's based around observe, control, automate. Observe, Home Assistant wants to know everything that's happening in your house. Is the door open? Is the media player on? Is the light on? What color is the light? Control is the second. With control, we want to make sure we can turn on the light, turn off the TV, open the garage door. And with automate, automation is a rule set based on certain observations. You can trigger certain control. And when you want to have such a system, it's very important that it works with as many things as possible. So with Home Assistant, it integrates over 1,000 different APIs, from very big ones like whole ecosystems like Z-Wave or Zigbee, to vendors that have like a single device type like Sonos, and even like custom-made things. And Home Assistant is open source. It means that anyone can download it for free and run it for free. So you can do this on a Raspberry Pi, a $35 computer, but to make it easier, we also offer off-the-shelf hardware. And if you want to go way more advanced, you can run it on your existing home automation server or any server. So Home Assistant is 8 years old today. And it's been when I started, it wasn't like I wanted to build like an Internet of Things ecosystem. Instead, I got the Philips Hue lights and I realized they had an API. So I wanted to write some Python to talk to this API. Great. Now I had this power, but I wanted to put it to use, right? So then I wrote a small script. When the sun is setting at my location, turn on the lights. Well, then I realized now the sun is also the light's being turned on when the sun is setting when I'm not at home. So I had to add presence detection. And this kind of snowballed until 8 years later. And now we've been one of the most active projects on GitHub for the last few years. In 2019, we were the 10th most active Python project of all projects on GitHub. And last year, we were the 2nd most active Python project on all of GitHub. And we were this with over 8,000 people contributing to Home Assistant. That's a lot of people. Now, if you look at all the other active projects and most active projects on GitHub, you can see that there's often a $1 billion company behind it. Google has TensorFlow, very popular. Microsoft has Visual Studio Code, that's very popular. And then there's Home Assistant. And we do have a company behind us, but it's my company. The company is called Nabucasa, and I started 3 years ago. But by the time I started the company to kind of sustain development, because it was getting out of control and we couldn't do it in our spare time anymore, the Internet of Things world has changed. Because a few years before that, Amazon launched the Amazon Echo. And when they launched, and then Google quickly followed, they had they enter a technology field the way they do, is that they create their own platform, and if you want to play with them and integrate with them, you implement their APIs. But the problem with the APIs from Amazon and Google were they're cloud-based, and it's only one-way street. We can only send data to Amazon about the state of our devices, but after that, the data is gone. Sure, you can talk to Amazon, but they will offer you the data only what their apps allow us. It prevents experimentation, it prevents growth, it prevents new things being built on top of it. And so by the time we started Nabucasa, we decided we want to provide a private home automation system as the viable alternative to these systems. And one way we made sure that we're going to achieve this is that by deciding not to take any external money. Instead, any user of Home Assistant can opt in to support development through Nabu Casa, but doesn't have to, because we want to keep the option open for as many people as possible. And it's working. Right now, we have enough, we're profitable, we have 12 people working full-time, and we're building out the privacy-focused smart home. We no longer just work on Home Assistant, we're also building out tooling to help other privacy-focused projects actually integrate and better, be more accessible to their users. Now, if we look at Home Assistant and its community, it's all based around the foundation of openness, sharing, and experimentation. So it's open source, and it allows people to also easily access all the data. So where I previously described where Amazon and Google, it's just a one-way street. With Home Assistant, all your data is accessible through an API. So it's very easy to build things, whatever you can think of. And this actually opens up a great avenue for a lot of people that learn and use technology at their work, software engineers, data scientists. Normally when they come home, they can't really use their skills to improve their own quality of life. However, with Home Assistant, this is possible. Because with Home Assistant, you can actually write code to automate your lights turning on automatically, or send a notification when the garage door is open, or send a notification when you're at work and it's too late. And all of these things, you can experiment, see what works best for you. And then with Home Assistant, it's also very easy to share it with the rest of the community. So all of a sudden, all these people that have all these skills from around the world are working on creating automation, sharing it with other people. And so our whole community is getting better. And the best thing of all of this, it all runs local, 100%. Now, the other thing that Home Assistant is different compared to a lot of other home automation projects is that our integrations are created by the community. And this means that we don't only support products of companies that exist today and the products are being sold today. We will, any product that has an API, even if the company doesn't exist anymore or the company doesn't sell the product anymore, as long as we can talk to it, it can work with Home Assistant, including if you are able to write some custom code. If you create your own garage door opener, it can actually integrate into Home Assistant. And if you then control Home Assistant from Google Assistant, all of a sudden you can talk to your Google Home and control your custom garage door opener. Now, we actually seen many custom garage door openers pop up in our community, and people are sharing this code, creating tutorials. So there's more and more people even creating custom IoT devices, kind of experimenting what is possible, what is it that works even better than what is available today. And if we look inside Home Assistant, the way it works is that all the data from the Internet of Things flows into Home Assistant, locally, of course, into these device types: lights, switches, air conditioning, you name it, sensors. And on top of that, we offer control, we offer automation, which both I previously described. We offer history. So in history, we keep track of what happened and why did it happen, right? So if you have somebody's coming home, this is triggering automation, and then a light is turning on. We don't only store that somebody came home and the light turned on, we also store the relationship. And this is very important once we want to if people want to do machine learning on their local data, then actually this data is very relevant. Another thing that we recently introduced is energy management. As the world is heating up and we have to get to zero emissions, we want to help our users save energy. So the first step in saving energy is knowing how much you're using. So with Home Assistant, we make it very easy to keep track of how much energy your home is using, allow it to break it down into individual devices. You can keep track of your solar panel productions. And we also keep track of how many electricity your home is using, how many fossil fuels are being used. Because, for example, if you use a lot of electricity during the day in California, well, that's actually solar panels offering that electricity. So that's cool. However, in the evening, California switches on their gas generators, and a lot of the electricity we use is very uses gas. So that's bad. So we give this insight to our users to, be aware, and then they can take actions on what's best for their homes. And the last thing I want to highlight is that we have this open API. And I talked about this before, but this means that any data is available to other programs. So we see alternatives to automation, history, and energy management popping up, and they just plug into Home Assistant. You don't need to reinvent the whole IoT space. Instead, you can just use our API and then get access to all these devices. And one of the reasons why we offer all of these devices is because all our homes are just full of devices that we have accumulated through our lives. And a lot of home automation platforms that have big promises today, they all start with kind of the notion, well, throw away all your existing devices, buy everything from our brand, and then it will work perfectly. You never have to worry again. But that's a lot of pollution, it's a lot of waste, and this is just not possible for a lot of people. Like, there's a lot better ways to spend your money than to buy like another thermostat after 3 years in use. Okay, so with Home Assistant, we have this open API, and we also see a lot of different places that people are building interfaces for Home Assistant. So, of course, the reason we're all here today, voice, but there's also computers. People have apps, there's websites to control Home Assistant. There are wall panels. People have tablets on their walls in their homes. Of course, phone applications, wearables, smartwatches. But I want to focus a bit on the home because, of course, Siri, Google Assistant, Amazon, the big ones are supported. But actually, we also support Genie. And we have been supporting Genie for the last 2.5 years. So Monica reached out to us 2.5 years ago saying, listen, we're building this privacy-focused voice assistant. You're building a privacy-focused home automation system. If we both focus on what we do best and then use each other's software, this is the perfect thing for the smart home. And she's right. We at Home Assistant, we're great at integrating all these different APIs. But we're not so good in building neural networks, assistants, and all that magic that she's doing. And for her, by not having to focus on all the IoT stuff, she could actually focus on the stuff that her lab is very good at. So in the last 2.5 years, we made a lot of improvements. And now every Home Assistant user has a one-click install of installing Genie and adding it to their Home Assistant installation. So if you go to the add-on store, it's still called Almond on the screenshot because we're still processing the rebranding that they recently did. Once you install it, it will get access to Home Assistant, and you can start talking to it. First, the way you can talk to it inside the Home Assistant interface is by having this new microphone icon will show up in the top right. You click on it, and you can actually have a dialogue. So you can type your questions, you get answers. If you have a browser that supports speech to text, it will actually offer you to actually speak as well. And other people have Jackie showed it earlier today in a demo. He's using the Almond interface, which is also accessible through Home Assistant. Other people have hooked it up to Telegram so they can chat with their house while they're away, which also means it's an easy to expose interface to other people in your house that might not want to drill down in a more technical dashboard. However, this is just an assistant interface. And what we're talking about today is voice assistant. And that is actually possible too. So you can actually plug in a USB speaker and a microphone into your Home Assistant hub, and it will become a full voice assistant. I have a video embedded. I doubt it's going to work, but we're going to see. I turned on your office lamp light bulb. All right. I don't know if all of you heard the audio, but it doesn't really matter. Basically, I spoke to Genie. I said, turn on the light. It turned on the light and gave me the feedback. And now, of course, when you're using Google, Amazon Echo, you'll be thinking, yeah, well, this is the bare minimum. Duh, this works. But what is so cool about this setup here is that the moment the Genie server gets the command, it is in ThinkTalk. It will talk to Home Assistant. In this case, Home Assistant will talk to the Philips Hue Hub. Philips Hue Hub will talk to the light. The light will turn on. Confirm that it turned on to Philips Hue Hub, which goes back to Home Assistant, which goes back to the Genie server. And this whole chain is happening super fast because it's all happening local. And all the code between Genie and Home Assistant is fully open source. So anyone can actually see, verify it works. And if you're building a product today, you can actually use this code because you can actually use and add Genie based on the Home Assistant integration, for example, to your software. And this kind of brings me to my last slide, which is why do we care about Genie and why we think you should too. So with Home Assistant, we are obviously building a privacy-focused home automation system. And so voice is a big, important part of it. But we are not like exclusive privacy focused. In the end, it's up to a user to choose what they want to use. Maybe the Google Assistant works better for your use case today, or maybe you want to wait till Genie is a bit more mature. But that's great. But Genie can only get more mature, or a privacy-focused voice assistant can only become more mature if it exists. There needs to be an alternative to these proprietary systems. And the problem we've been seeing is that there's been a lot of cool new voice technology being launched in the last few years. Thanks to the neural networks, we really see cool stuff happening. But most of this technology is being developed within companies. And these companies, often with investor money, well, they want to get an exit. So a lot of these companies basically get acqui-hired. Their products get shut down, and the people working on it are getting folded into the big tech, working on their assistant platforms and these kind of things. And that sucks, because we need this alternative privacy-focused voice assistant. So that's why the Genie work by the Oval Lab is so cool, because it's actually built by academics. And it's not possible to acquire Stanford, right? So as long as Monica and her team are working on this, at least there's a spinning engine that is building out this technology. And as long as she's able to get grants from either the NSF or the Sloan Foundation, she will actually be able to there's some people working on to kind of get it to productize the product. But I think the next step should really be, we need more user-facing products to adopt something like Genie, because then as more people start using it, open source will be able to win from any proprietary solution. We see this with Linux, we see this with Wikipedia, and I think with voice, Genie can be this solution. So yeah, in short, Genie will give smaller companies and creators a voice. Thank you.
Thank you, Paulus.
You're welcome.
All right. Unfortunately, we cannot see you, but that was great. Thank you very much. And next up, we have Jimmy Garcia Meza. He was a former exec at Silicon Image, which is very interesting because they created the HDMI standard that is just used by everywhere around the world. And he is now a CEO with CloudPlux. And he's going to talk to us about the WWvW ecosystem. Thank you, Jeannie. Thank you.
I am Jeannie. Ask me any question. What do you end up with here? Okay. I don't know what you've done with that. All right.
Open the PowerPoint. Is it open? There it is.
There you go. Familiar with this on the Mac? All right. Okay, great. Well, thank you very much, Monica. So, thanks to all. It's getting late, but let's hope we can continue with the energy here. So I've been in this industry for a long time. I've been in this industry for almost 30 years now. I started my career at Sun Microsystems, spent 12 years there selling open network computing. I did some venture capital. I did Silicon Image and was part of the team that actually made HDMI possible. I ran a company. It was bought by IBM, and now I create this other company in the industrial Internet of Things for the last 7 years. And I got involved with Monica about 2.5 years ago through a common acquaintance, and I've been supporting the effort in any way I can, because I really believe in two main things. First of all, it's voice. And all of us were born at some point, and what is the first thing we did? Speak and listen. And so voice is really important, and it's just been neglected for the longest time. And now, after so many years in the history of humanity, we're finally being able to get voice to a point where we can actually use it for interaction with devices and other systems. So that's one important thing. The second one is openness. So I was really shocked, to be quite honest, to hear, a couple of hours ago, people saying open and close, it doesn't matter. And I really don't think that's true. Open matters. Close may be the winner in the short run, but as you know, in economics, there's the short run and there's the long run. And in the long run, open always wins for a very simple reason. Openness means choice. And everybody wants choice. So I think the work that has been done here and keeping this as an open source project is extremely important, not only for the people that are interested in using voice for humanitarian reasons, but also for people that want to use it for business reasons. So what we'd like to do now in the next few minutes is talk about the worldwide voice ecosystem and what it's going to take to make all this happen and make it a reality. So one of the things we need to do, if we're talking about IoT and all the work that Paul and others are doing, is we need to integrate devices and sensors and make them part of the fabric. So for that, we need to talk to everything from lights to switches to HVAC systems. And there's a bunch of protocols that go along with that, from Wi-Fi to Zigbee to Z-Wave, et cetera. And then we need to build the systems that can actually talk to devices and talk to web applications and other things. So for that, you start with a simple technology, which are the chips. So from the chip perspective, there's a lot of work that needs to be done in terms of integrating the technology and making it work from low-end to medium-range to high-end technology. So from the low-end side, the speaker that you saw from Baidu, for example, uses an all-win CPU, which is very low-powered. So the technology needs to be able to be small enough to fit in a low-powered system. Then you look at the medium range, which is the gateways and set-top boxes and everything else that's going to allow you to execute more complicated actions like what Paulus was showing a minute ago. So to build those gateways, you need either an Intel or an ARM or, let's say, a MediaTek CPU, so you can deploy those systems. So we also need to do the work on having the server technology of Genie. So there's a client piece, which is a small piece, and the server piece running and make it available in such systems. And there's the whole piece of doing all the NLP processing, all the natural language processing, all the neural network stuff, and that requires GPUs. So the current version of Genie uses the NVIDIA stack, but it can become available on AMD or Baidu Kunlun or eventually MediaTek. They have the Helio G90 AI chip. And so the whole idea of having an open source technology is that suddenly that technology can be ported to all these different chipsets, which now can be used to build the systems that applications and people can interact with. So once we have those chips, then we go to building the system. So what are those systems? So from the low-end chips, we start building smart speakers. It's like the Baidu that you saw earlier. So you can buy a very low-cost $40 smart speaker or a smart panel to interact with your systems at home or with voice services applications on the web. Then there's the mid-range, and so what you saw today was the first glimpse at what it's going to mean. So we have the integration with a Home Assistant, which has a little gateway. It runs on an ARM processor. But what's going to happen over time is that we are expecting and working with different companies so that that medium range gets filled with applications for the phone, gets embedded into TV sets, and gets embedded into a car, for example. And the next big piece is now, okay, I have the client running on the low end. I have the server running on the mid-range. Now, what can I do with the NLP part? The NLP is heavy-duty computing, and it requires a GPU. So the GPU is going to run either on a server at home or on a more powerful computer at home, on a smarter TV, or also in a car. So today during lunchtime, I met a gentleman who showed me a chip that's going to cost, he says, under $1 that will be able to run the whole AI stack of Genie. So as innovation happens, then the technology is going to become available in very low-cost infrastructure so that instead of buying a $200 NVIDIA GPU, you're going to be able to run it on a single dollar system, which can be then which can then make all this ubiquitous. So the way this works is that Genie has 3 core components. We have a client, right, that can run on a low-end system like the Baidu speaker you saw. We have a server portion that needs a little bit more compute power, and then we have the NLP portion that needs a GPU. So what's going to happen is that as people start building more and more low-end smart speakers, they're going to be able to deploy the Genie client on it. We're going to deploy the Genie server on medium-range systems, and a little bit more powerful systems are going to be able to run the full stack. Now, those more powerful systems, as we said, can be a more powerful gateway at home, can be a more powerful TV, or it can even be a car. So that's the Genie piece. And then we need to interact with the worldwide voice ecosystem and build the whole ecosystem. So from an application perspective, whether you are a business or whether you're a nonprofit organization, what you're going to be able to do is build your applications and services and have pre-trained Genie agents, deploy them on your site, and then the Genie servers running on all those devices are going to be able to interact with those agents. So when you're talking to a site and you say, one of the examples earlier, I'd like to, for example, the gentleman from KQAD, I'd like to get information about the latest polls on this proposition. If you'd made a question like in California, if you made that question today, most of the assistants are probably going to tell you, I don't know, I don't understand that. But this kind of environment is going to be able to tell you, okay, I found these 3 answers. And instead of sending you a link to those 3 answers, you're going to be able to say, read me the answer, and then the voice agent is going to be able to serve up the content in voice format for you. So there's going to be an ecosystem of companies that make their Genie agents and their content publicly available. And those can be applications, services like banking services, other content like news, commerce applications. And there's going to be the world of private companies that are going to be able to host their own Genie cloud and host their own Genie applications for customer relationship management system and other services. So it's a big undertaking, and we're working with different companies in all the different layers to be able to make this a reality. So very quickly, let's just see what the world would look like. So this is the example of how things work today with Home Assistant, which you just saw. You have Home Assistant in your home. You have all sensors. You can interact with them. Now, you add something like a Baidu speaker or a speaker and a microphone to your Home Assistant, and now you have the client at your home, the Genie server at your home, and now you can talk to the Genie NLP cloud to do all the voice processing, and then through that, then you can interact with the worldwide voice web. And then that web keeps on growing because now you have music streaming services, restaurant information, healthcare information, news, your banking, weather information, commerce, etc. Now, if you want to go all out and be fully private, then what you can do is then have more powerful hardware that will actually run the NLP service at home, and then you're not going to the cloud. All your data stays local and stays fully private, and then you can have a port open to interact with the open worldwide voice web as well. So these are the various components and how they play in that environment. If you wanted to if you're in the hotel business, and now you would like to use a platform like Genie, for example, so a lot of hotels are investing in automation and voice commands inside their smart rooms, then you can do something like this. You would deploy, they would deploy their sensors in the hotel room, a small Genie client, like a Baidu speaker, and then they would deploy the Genie server piece with the NLP stuff inside the hotel, and then that would be able to serve up all the rooms. So you arrive to a room, and you can say, turn on the lights, open the blinds, turn on the TV, turn off the TV, set the alarm for 6 in the morning, or whatever you want. And so in a typical hotel environment, they would probably keep all the NLP side locally at the hotel because they don't like to open themselves up for people to make commands from the outside. And, but they would open a port so you would be able to get your voice services from the World Wide Voice Web. And the last example is, okay, I have my home all hooked up. I have my Genie interacting with all these nice applications. And now, how about the car? So one of the things that I think is most important in the World Wide Voice Web is mobility. When you're sitting down somewhere, you can actually access your phone or you can access your computer and your keyboard. But when you're driving, or especially when you're driving, you don't have that. And today, the way it works is you want to access some information, and a lot of the current assistants like Siri, et cetera, will not be able to serve you up all the information in the way you want it. So with this kind of infrastructure, what we would do is deploy on the car a Genie client and a Genie server with a whole NLP stack so that if the car doesn't have external communications, then you would be able to still give commands to your car and hear information from the car. But then the ecosystem starts getting pretty large here because you have the car companies and then you have the telcos, which are also providing all the networking information for the cars. And then you have companies that can start offering additional services. So you may have a car service voice web where you have agents and models of servers that have different applications that run on the car. And then those models can be deployed in the car to enable different functions. All right, so we're going from a simple environment in the home to an environment where now Genie goes with me with my mobility, and then all the way to an environment where now I have my mobile phone also with Genie fully integrated into the system, and it doesn't matter where I am, I can access the information anywhere, anytime, and basically from any voice device. So a lot of the work that's being done here is to enable voice services everywhere, and with technology like ThinkTalk and enabling interoperability between virtual assistants, we think we can actually build a fantastic new world in which voice becomes a really important element. There's one more thing that's really important to I think, clarify is there was a comment on saying, when I ask for what are the hotels, I list of 45 hotels. That's not how Genie would work. That's absolutely not what this project is about. If I say, give me the restaurants in Palo Alto, Genie is going to say, what kind of food would you like to eat? And then I'm going to say Thai, and then it's going to help me with a dialogue agent and narrow down the focus of that query so that I get the right answer and I don't have to be guessing going through a list of 45 devices. So that is really important that it's clear for everyone. So we believe that this is a fantastic project. And as you saw, the technology is not easy. It requires a lot of investment. Companies invest, the closed ones invested millions and tens of millions of dollars of this. So there are three things that we need to ask for everybody that's looking at this workshop today. One is, we'd like you to start a project and talk to us about a project that we can work together on. Two, you're going to need to assign some technical resources to work with the team to make your project a reality. And three, it'd be great to get some contribution in funding for the project at Stanford because it's really important stuff. It can really, this is a game changer. It will really open up the world to a whole new world, range of possibilities, and we need your support. Thank you very much.
So we're going to take a short break. Right? And it's just 15 minutes, and we'll be back for the last session. And we have a lot of very interesting technical talks waiting for you.
Hello, everyone. Welcome to the last session of the day. And I'm Salai, a PhD student in Monica's group. And we have Giovanni and Murad, all students from Monica's group. We're going to be presenting, getting more in details of the technology behind Genie. So I will start with the first part about question answering. We'll use this to demonstrate how we use Genie to synthesize data. So we all know that question answering is an extremely data-intensive task, especially if you want to scale to many, many domains. So that's why that only some of the biggest companies can do it nowadays. So how can Genie do it with such a small team? And as you have seen from previous talks, Genie's approach is using synthesis. So Genie takes database schemas and values and synthesizes a large set of synthetic data with very high quality, and we train directly with synthetic data. And the benefit of this approach is cost effective. There's no need for labor-intensive data annotating, and it has great coverage as well, including all the long-tail questions that might not be very popular for the commercial assistant to work on. And it also guarantees correctness, which is also an issue in manually annotated data. But often, in general, synthesis often fall short in natural language variety. So to get a very high quality synthetic data with varied natural language, there are 3 key ideas behind Genie to make it work. And I'm going to start with the first one, which is the grammar-rich domain-independent templates. So for lots of the variations in natural language, they are standard. They're domain-independent, and they are well summarized in the grammar books. So for example, we have different sentence purposes. We have declarative commands, we have imperative commands, we have interrogative commands, and so on and so forth. And for interrogative, we have different pronouns depending on the type of the subject. And another example is that we can do comparison in different ways depending on the type of the property. For example, we say lighter, heavier for weight, but we say taller or shorter for height. And all this in the formal representation, they're all just greater than and less than, but in natural language, they have different ways to talk about it. And we also have different parts of speech. So even for the same fact, same piece of information, we can describe it using different parts of speech. Let's take a look at an example here. So let's say we want to search for seafood restaurant. So in ThinkTalk, we have a filter, cuisine equals to filter on top of the table restaurant. And this filter can be described in many different parts of speech. For example, we have noun phrase. So we have sentences like restaurants with seafood cuisine. It's a noun phrase. We can also use active verb phrase. So we can say restaurant that serve seafood. So it's a verb. Or we can simply use the adjective form, seafood restaurants. And because we want to train directly with synthetic data, we need to capture all these kind of variety in natural language in our templates as much as possible. So in Genie, we created a comprehensive set of over 900 templates. And it covers different parts of speech. For example, we have templates for noun phrase, so we can generate sentences like restaurants with seafood cuisine. We have templates for verb phrase, so we can generate sentences like restaurants that serve seafood. And we also have, the templates also cover the different sentence purposes, subject type, and property types. For example, from restaurant that serve seafood, we can generate a declarative command. I am looking for a restaurant that serve seafood. We can have imperative commands. Show me restaurants that serve seafood. Or we can have interactive question. What are the restaurants that serve seafood? And for interactive, we will use where when we're asking for the location. We will use when we're asking for time. And we will use who when we're asking for people. And on top of that, we have templates for different connectives to compose things together. For example, we can combine seafood restaurants and 5-star rating to generate seafood restaurants with 5-star rating. And of course, these connective templates also take into the part of speech into consideration to make the sentences look natural. So this is a lot of work, 900 templates. But the good news is that it's once for all. So all the templates are domain independent with placeholders to fill in the domain dependent content. And that leads us to the second idea behind Genie. We use we use property annotations to provide domain-dependent contents using automatic paraphrases. So property annotations describes for a certain property how we can describe it in different part of speech. And in Genie, we have a component named auto annotator to automatically generate these annotations. Let's use cuisine as example here. In the first step, we have nothing, and we start with the name of the property. So we generate a base annotation using the name. We have the property name, and we generate a starting point. So here we have value cuisine. And we have, for each property, we have the values from the database, and we have templates for each part of speech. So we can combine them to create some simple commands like restaurants with Chinese cuisine using the base annotation. And starting from there, we can use neural paraphrase model to paraphrase such starting point. And we can get a bunch of different paraphrases. And as you can see here, we have a few examples. And you can see a lot of different ways to describe this property cuisine in these paraphrases. So in the last step, we just extract them using the templates and fill them into the annotation table for this property. And in this way, we can get a lot of different ways to describe the same property automatically without any manual annotation. And all these annotations will be amplified with our templates. So it's not just for one example in the training set. It will be used in every different, in all kinds of complex questions. So this auto annotator gives us some natural language variety at the property level, but we also want natural language variety at the sentence level. So the idea 3 is that we want to do 4-sentence automatic paraphrases. So we can simply feed a synthetic sentence into a neural paraphraser and get the paraphrase sentences out. Currently, we are using a bar-based paraphraser fine-tuned on a generic back translation data set. But the problem is that the paraphraser is not perfect. It will make mistakes. For example, we found that find restaurants close to my home sometimes may be paraphrased to find restaurants near me, which have a different formal representation in ThinkTalk. And in fact, there's a trade-off between variety and correctness. We can increase the temperature of a neural paraphraser to get more varied example, but the model will also be more likely to make mistakes. For example, at high temperature, the paraphraser will paraphrase search for people who are employed by Stanford into find people at Stanford, which might confuse the model with students at Stanford. We also get things like people who were once employed at Stanford before, not currently. So we need to filter out this noise. And the way we do it is using self-training. The idea is that feeding examples that the parser already understands will still improve the parser. So first, we train a parser with the synthetic data we have. And thanks to our comprehensive set of templates and property annotations, this is already a pretty good baseline. And we use this parser to parse the noisy paraphrases. And then we can filter out those paraphrases where the new parse does not match the original label. And then we add filtered examples, filtered paraphrases into the training set and retrain the parser. And we can repeat this step for multiple rounds to include more paraphrases as the quality of the parser improves. And this component in Genie is called auto paraphraser. So this component will give us 4-sentence natural language variety. So now we have introduced all the 3 key ideas behind Genie. Let's take a look at the full picture. So we start with database schema and values, and we use auto annotator to get the property annotations. And then we synthesize a large set of synthetic data using the grammar-rich domain-independent templates. And then we apply auto paraphraser with noise filtering to get high-quality 4-sentence paraphrases, and then we train the semantic parser. And the whole pipeline is fully automatic from end to end. But of course, developers can provide additional manual annotations or manual paraphrase or other sorts of training examples to further improve the quality of the parser. We evaluated Genie on 2 question answering benchmarks. The first one is overnight. In overnight data set, we train with Genie synthetic data and evaluate on the original paraphrase data. And we achieved 70% of answer accuracy, which is the state of art for zero shot. We also benchmarked on our own dataset schema to QA. This has a much more realistic test set where the quad workers can write the questions freely given a domain and the available properties. So it's more closer to the real world setting. And then we manually annotate those questions with ThinkTalk. And on this set, we also get 73% of accuracy across 6 different domains. So it works, basically. In summary, we have introduced how Genie synthesis work. So we start with property-level prefaces to get the property annotations in different parts of speech. And then we synthesize with the grammar-rich domain-independent templates, and then apply the sentence-level prefaces with noise filtering. And the whole pipeline is fully automatic from database to a question answering agent. So that's why Genie can scale up to many, many domains. So this is about question answering. Next up, Giovanni will introduce how Genie handles dialogues.
We have 2 minutes. Do you want to take one question? Or people are just dazzled, and then we'll move. All right, we'll move on. So we heard about questions, but we want to handle multiple turns. We want to handle dialogue. So hello, everyone. I'm Giovanni. I'm a PhD student for a few more weeks working on this project. I've been working on this project for a long time. And so we care about dialogues. Dialogues have multiple turns. They have carrying over context. They have refinement. And we have seen ThinkTalk. So Monica introduced it before. This is how we can represent ThinkTalk. We can annotate every sentence with a formal ThinkTalk representation and have a precise program, a query that the agent can execute to perform the intent of the user. And so Monica introduced that the Genie dialog agent as a formal representation of the dialog state takes as input the user utterance, passes to the contextual semantic parser, produces the ThinkTalk code. ThinkTalk code gets executed by the ThinkTalk runtime. In this case, the user was searching for a particular restaurant. He retrieved that restaurant, gets passed to the agent policy. We recommend one. Now, the question and the topic of this talk is how do we train this contextual semantic parser? How do we get dialog data? And dialog data is much more complicated than question answering because there is an exponential number of paths that we can take in a dialogue. Of course, our goal is to go from schema to dialogues using a synthesis. So how do we build this synthesis for dialogues? Well, we started by looking at multi-vowels. This is a well-known benchmark, and this is for dialogue. And this is one example of a dialogue taken from the validation set. The user is looking for a restaurant. And first, there is a little bit of back and forth between the user and the agent trying to figure out which restaurant they're looking for. Then, after the user has chosen the restaurant, the agent will ask for any missing information to perform the reservation at that restaurant. And finally, the agent will perform the action, show the results to the user, and conclude. And we have observed that this structure actually repeats across many dialogues where the user is trying to get the agent to perform some action on their behalf, which we call transaction dialogues. And so we have encoded this very high-level structure into what we call the abstract transaction dialog agent. At first, the user says hello, then it searches, performs the action, the agent will go. And the interesting thing to note out of this diagram is that it's a very small state machine, but it can already generate a very large space of dialogue because there are many possible paths that you can take along this state machine. And note in particular that some paths will loop back as the user and the agent actually collaborate to get to this goal. Zooming in, every state in a state machine is now represented by templates. So out of the small result that was produced by a query, for example, the agent can say, I have this and I have that, and both are like this.
Or I have this, and it is a blank, and I don't know what it is, but I can fill in those blanks given the database. So how do we actually refer to the slots in natural language? We have seen that we annotate our skills with all the different parts of speech and all the different phrases and all the different parts of speech with every field. In this example, this is how we refer to food for restaurants. And using our vast library of grammar templates, we can generate both the questions that come out of the user, such as, what food does this restaurant have? But also we can generate the questions that come out of the agent, such as, what cuisine would you like? Or would you like to eat this cuisine, and so on. And so we can put it all together. Now we fill in the template. Out of a result, which is now concrete, is a specific query that we have executed. The agent can recommend one restaurant. I have Terun, highly recommended. Or I can recommend multiple restaurants. If the agent recommends multiple restaurants, then the user can follow up with a question. Or if it recommends one, I can ask the action, and so on. So this is how we get to a large, very large space, exponential space, automatically, very quickly, of synthesized data. Now, where's the caveat? Synthesized data, like this, what was previously called machine-to-machine data, where a simulator user and a real agent are talking to each other, it's easy to acquire. There are two computers running, so it's very fast. But it's limited by a state machine. We have defined both what the agent does, which is fine to be a state machine, but also what the user does as a state machine. And real users, unfortunately, are finicky. They don't like to stick to state machines. So we are going to deal with dialogues that are outside the simulation. So here is one example of a real dialogue from the multi-walls dataset, or a real exchange, a subset of a dialogue, which is out of simulation. The user is both trying to book a table at a restaurant and also finding a hotel. So it's two domains at once. And the real human agent in the multi-walls dataset was able to do both. We would like our agent to also do both. This is possible because you can observe there is actually a think-talk representation for this turn. So even though the turn is outside of the state machine, we do have a formal representation. As long as the agent can interpret that formal representation, then it can reply to this. And then here I put other examples of auto-simulation dialogue, such as, there's multi-domain turns, that's the most common. There's also domain switches where the agent, the user abruptly switches domain. We don't want to simulate that into a state machine because it would go all over the place if we just did it randomly. Also abandoned transactions where the user started giving us some information about reservation and then says, never mind, forget it, move on. So how do we tackle auto-simulation dialogues? We propose to combine the state machine, which we can use to synthesize a lot of data for coverage, with a small amount of manually annotated data, typically acquired from Wizard of Oz. And that small amount is enough to teach the model, which is a pre-trained language model, to generalize beyond the state machine. We found empirically that the model can combine the learning from synthesis and few-shot, and do better than either of those models alone. But the trick here is that the agent can represent everything in think-talk and therefore can execute any command, including those that are outside of state machine. To evaluate our approach, we experimented on the multi-walls benchmark, which has 5 domains and about 10,000 hand-annotated dialogues. We worked on version 3.0, which we re-annotated. We took the full test set of multi-walls and a subset of the validation set, and we re-annotated ourselves. So while there's many previous efforts at re-annotating multi-walls, they all use crowd workers because they had to re-annotate the entire training set. We could afford to do the re-annotation in-house by experts with much better quality control because we only annotated a small portion. And so we trained on 800,000 synthesized dialogues. 800,000 synthesized turns. About 1,000 turns were manually annotated data. For few shot, this is roughly 2% of the original training data. And for the rest of the training data, we applied self-training, where we automatically inferred the annotation from a model trained only on the first two pieces of data. Our metric in the experiments is turn-by-turn accuracy, where we try to verify that the think talk that we predict at every turn is correct, given the formal state of the dialogue. And note that prior work on multi-was only evaluated slots, not full think talk, and which is not sufficient to build an agent. We need a precise representation of the user intent. As I mentioned, think talk was annotated multiple times, yet the state of the art roughly on what's available is around 60%. And so the first experimental result shows that 98% of the multi-was test set can be represented in think talk. So this shows the power and the completeness of the think talk representation. And furthermore, 85% in this case of the validation set is synthesizable by a state machine. On the one hand, this means that we have built a fairly complete state machine that covers a large portion of the space of real dialogues that people are going to use. On the other hand, now we know that there is a 15% of dialogue that we have to contend with. And when we test on the whole 100% of test set, not just the 85, we find that our training strategy, including synthesized data, achieves a 79.2% accuracy. It beats training only on the small amount of annotated data. It also gets 87.5%, which is comparable to the 60% that was achievable in the state of the art, although it's on a different test set. We also evaluated our state machine. We found that 15% of the turns had a state that was already appearing in the training exactly, ignoring the actual utterance, of course, and ignoring the values in the state. This shows the advantage of having a very large training set, because we can generate as many states as we can. And on this, the model is going to have very high accuracy because he has seen that data in training at 93%. For the rest of the data that is generatable according to the state machine, the model achieves an 82% accuracy, which means he has learned the state machine very well with good accuracy. But most importantly, on data that is out of simulation, the model achieves a 63% accuracy. That means that the model is not constrained by the state machine and can generalize beyond, and our method is effective. And to summarize, think-talk dialogues are a general design of a semantic parsing-based agent. We have found that think-talk can represent Wizard of Oz dialogues precisely, and is extensible to new applications, as Monica covered earlier. We have found empirically on multi-was that synthesis can achieve very good performance. We do need a well-designed target representation. The intent and slots doesn't really work. And we do need a well-constructed state machine that covers as much of the space as possible. But we can generalize beyond the state machine using few-shot and self-trained data on which the model achieves 63% accuracy. And of course, because we're using synthesis and it's a cost-effective method, it's applicable to any domain just by providing the schema. Thank you. I have 4 minutes of questions.
Thank you, really impressive. I have a simple question. What happens when your neural parser does not produce proper think-talk code, like it's not executable, has mistakes? How do you enforce that, or how do you deal with that?
So I can say a couple things. First of all, we don't actually enforce the model to produce valid think-talk. The model learns what is valid think-talk purely from data. But what we have observed empirically is that overwhelmingly the model on normal utterances, on not the tricky ones, I suppose, the model will produce valid think-talk. So if the model doesn't produce a valid representation, yes, we do have some fallbacks. We have some further area research that are beyond what I'm presenting today, where we try to correct the errors, where we try to basically recover. We know that the model is going to make a mistake. We do observe empirically from some of our production work that model tends to make more mistakes, for example, in out-of-domain sentences. So in which case, that's a signal that we should try a different approach, try a different model. But yeah, that's...
Thank you.
So this is more about a question of the thing talk runtime instead of the synthesis. But if there's an ambiguity in a query, like let's say there are two restaurants with the same name, where a human could use deductive reasoning to figure out which restaurant a person would probably want to book, does thing talk return a clarification, or how would it manage that?
So the core design of ThinkTalk is that we want to represent what the user says, and if there is ambiguity, we'll make sure that the query returns multiple results. So for example, in the case of searching by name, the query will return all the restaurants that match. They will be ranked. Typically, the underlying service will give us some sort of ranking by distance, by recommendation. And then the agent will see, OK, I actually have multiple restaurants that match. And the agent can decide, if I have multiple songs that match, I typically just pick the first one. It's the most popular and just go with it because I don't want to ask. If I have multiple restaurants, I do want to be sure that I'm booking the right one, so I will ask and continue the dialogue. All right, I think I can cede the floor to Murad. I introduce Murad, who's going to talk about multilingual.
Hello, everyone. I'm Mehrad, and I'm a PhD student in Oval as well. And I've been working on the AI and NLP side of the project for the past 3 years. So my colleagues introduced Genie and how you can use it to effectively generate a question answering and dialogue system for new domains. But one caveat that is often very easy to overlook is that the system is built English-centric. And for example, the templates, the grammar that has been used to generate the data set is all for English. And the internals of the system, any part of it that touches text, such as tokenization, is also built for English. But the question that naturally arises here is that what are the limitations to extend this system to a new language? So there's about 6,500 languages spoken around the world, and focusing on probably like 1 or 2 doesn't sound like a great option. And the ultimate goal that we're trying to achieve here is inclusion. And as in the morning, Musa and Chris and the panel were discussing, there's a lot of use cases for this, for example, for the parts of the world that don't have access really to technology, especially illiterate people who their only way of interacting with the world is through voice. So for example, in African languages that we don't have a lot of systems. And also the other applications can be like healthcare, that you want to like book appointments for COVID and other things in languages other than English. And the benefits is not only for speakers of other languages, even for the popular languages such as English, people still want to be able to query about different local entities such as songs, cuisine names, and locations. I bet all of you have had the problem that you want to like tell Spotify to play a specific music, and it usually doesn't get it because it's in a different language, and you eventually have to type it in, and it will figure it out eventually. And we want to be able to support that through voice, of course, and again, use cases here are very vast. We have like 100,000 radio channels in many different languages that you can query, and what it comes down to is basically handling mixed code, meaning that you have multiple words from different languages in the same sentence. So the objective is democratization of voice for all languages by mostly automatic techniques, and by that we mean we want it to be fast, cost-effective, and efficient. So if you look at the space of the current virtual assistant, usually they support a couple of about like 10 to 20 different languages. At the same time, if you look at machine translations that are out there, both open source and closed source, such as Google, they're on the order of magnitude more languages. So there seems to be a gap here, and you start thinking like we should probably do something here. We can probably use NMT with semantic parsing, and build virtual assistants with that. So the ultimate goal here is basically how can we make Genie available in another language in one day. And by one day, we are highlighting the fact that we want it to be fast. Like we don't want to follow the same path that we follow for English. Otherwise, it will take months again to like build a system. And the goal is we built a system. We put all the effort into like one language. Now we just some minimal technology on top of that. Can we extend it to a new language? So the current state of the system is we have Genie, which has found its way to communicate with the computer in a language, ThinkTalk. It's not a natural language, it's not a human language, but it's very close to it. And on the other side, you have a human speaking to this system in English. And that English sentence can be represented in many other different languages. And you start thinking, how can we connect these two together to be able to speak in a multilingual fashion? So it's all languages. Some of them is human, some of them is formal, and there are multiple things that we can connect these two together. So the traditional way of doing this is usually through humans, professional translation services. And of course, the pros is that the quality is usually high. You have someone who knows the language and is doing the translation for you. And because it's localization, means that you want to adapt it to a local or specific region, they can handle the colloquial text better or the specifics of that text better. But of course, you need a lot of capital, which usually companies have that, so they can hire a lot of crowdsourcers that can do this for you. And because of that, actually, so the process is going to be actually slow and expensive. And also because you're diversifying the translation, you also get lack of consistency in the style and terminology. People tend to translate in a different way. And even if you say, I hire someone else to like go over the translations and figure it out, they have their own opinions. So you have a bunch of opinions coming from different people in, and it's going to be a lack of consistency in the final results that you have. And at the same time, if you're translating documents or websites that need a specific knowledge, then you need to train those people ahead of time, which is, again, goes back to the being time-consuming and also expensive. So in these days, usually, if you have a task that a human can do, you have a machine learning algorithm that can probably do the same, maybe not as high quality as it, but we have also neuro-machine translation, which you give it a sentence, and then it gives you a sentence in different languages. And it's example-based. Basically, you need to provide a lot of high-quality data for it to learn the representation to map these things together. And the pros are that you have one model that can handle all these different languages. It's controllable and consistent, meaning that if you run it today and tomorrow with the same hyperparameters, you're going to get the same results. You can change like temperature or stuff that is in the function, and then you will get different results. But it is tunable, and you have access to the internals of the model, and you can do all sorts of magic within it. And also, it's fast to train relatively and deploy it. And you're dealing with computers, not humans, so you can like do whatever you want there. But of course, the con is that you need a large amount of data to train those models. So let's start with a concrete example. For example, assume we have a tourist in New York and he wants to find a hotel near Times Square that has at least 1,000 reviews. And this is a ThinkTalk annotation. You can see kind of a similar construct to natural language. We are filtering on the review count, and also we want the location to be Times Square. So the slot values, basically the entities in the sentence, and the ThinkTalk annotation matches verbally. At the same time, this same command can be represented in multiple different languages besides the entity. So first one is querying, you're in US, you want to go to Times Square. In Germany, you might want to go to a different location, and so on and so forth, depending on the country you're in. The core concept here is that all these different representations are semantically equivalent. So they have the same representation in ThinkTalk modulo the entities. If you factor out the entity, they will map to the same exact string in ThinkTalk. And so the natural idea here is that you just start translate from one language to the other. And what happens? You start from this sentence that you're looking for a burger place near Woodland Pond. You translate to Italian. Instead of burger, you have hamburger, which is equivalent, but it's not the same exactly. And the location is now Stagno Bosco, which it's not a place anymore, and it doesn't even match with the annotation. So what you want is that you want Italian, or like you want the sentence to be in the foreign language, but you want the entities to still match what you have in the ThinkTalk. And after you basically align these entities, you can replace them with all sorts of names, different cuisine names, different locations, and so on and so forth to generate the actual data set. So just let's zoom in a little bit technicality here, opening the box here. So you have a translation model, which you feed it a sentence, and then it has a transformer, encoder, and decoder, and then it will go through, gets processed, and then it will output the sentence for you. And what we've added here is basically an alignment module on top of this that makes sure what the output is has the correct entities by basically post-editing the output. And if you look at the internals of this attention model, it's basically a mapping between the tokens in the input and the tokens on the output. And the way to read it is that the bright colors are the attention have the highest attention. So if you just follow the bright patches, you can see that the burger is being mapped between these two, the input and the output. And also Woodland Pond is matching basically to Snago Bosco. So once you find this mapping between the entities in the input and the output, you can do all sorts of things with it. So the methodology is twofold. One is runtime translation, meaning that I speak a sentence in Farsi, and then you just run it through the machine translation, you get English sentence, you already have trained an English semantic parser, you'll get the think talk. On the other hand, you can actually generate data with this. You can eat the English training data, you translate it to a Farsi, and then you train a model with this. So you actually generate a new semantic parser. And at runtime, you will feed in the Farsi and then you get the think talk. So we're going to talk about like the advantages and what we've seen empirically happens when you use these. So I'm going to walk you through a couple of experiments that we've done and the thought process that went for each. And the basic baseline, no-brainer baseline is the runtime. Basically, you speak something, you get translated to English, and then you run it through. But as you can see, the system is basically unusable. You're getting at best 20%. And the reason for that is that the English semantic parser has been trained to copy entities from the sentence. And if the translation model is basically outputting wrong entities, you're not going to get good accuracy. And now we can say, OK, so let me train with that data. Maybe it gets better. So now you want the semantic parser to actually does a back translation for you because you've already translated the entity. Now say, OK, I want the semantic parser to also translate back. But that's not going to work because, first of all, you have two different objectives, both semantic parsing and translation. And also, there's not only one translation for a single entity. Depending on the context, the output is going to be different. And as you can see, the result basically is the same. You don't get much out of it. Now we can say, OK, I have the original English data, which is correct. Let me add it. Maybe something happens. No, because now you have conflicting objectives. Now you have a data set with correct entities everywhere that the model is trying to copy, but at the same time, you have something that's not correct. And this confuses the semantic parser, and as a result, you won't get anything again. The moment we add alignment, we see an immediate jump because now you actually have aligned entities in the input and the output, and given the constraint that we've put on the model that copying entities, you will see an immediate boost in the accuracy, and now you basically have something usable, 60%. So the other thing is that, again, you can train on this data set, and the idea is that I want to be robust to noise. I want a model that actually has seen the language, has been trained on the language to learn the grammar and so on. And if you do this, I'm going to show the results for all the different languages. The improvements are usually about like 4 to 5%, but it's all coming from the fact that you're training, not just running it through. And now if you add English, you actually see some good improvements. And again, it's because you're exposing the model to different vocabularies, new grammars, and empirically, if the language has close constructs to English, you usually get higher improvements, and it's totally language dependent. Lastly, what has actually worked the best is adding a few human translations. And this is big, there's multiple reasons behind it. One of it is that, of course, the distribution between what we're testing on, which is human translated data, and what we're training on is different. And adding a few human translations can add new, basically, grammar, the way that we haven't been able to cover in the machine translation model, similar to the dialogues. And as a result, you usually see about like 10% jump in the accuracy there. And now if you see the results across all the different languages that we've tested on, usually see a similar pattern, and the results, so basically the two solid lines are the English ones that we have. And if you look, we have comparable accuracy to those, which is ultimately what we want. But of course, you're not going to be as good because you always have translation noise in the system, which is going to hurt you. So this is this really the best thing that we can do? Probably not. We want dialogues, conversation systems, not just single questions. And it comes with its own kind of challenges. One thing is that now you don't have a single sentence anymore. You have multiple turns, and the translation is going to accumulate over all these turns. And if you want to keep the whole history of the conversation and encode it, there's a bulk of text with a lot of noise in it, and it's not probably going to work. At the same time, you have utterances which are generally longer and have more entities. So both the translation and the alignment module are going to have probably produce more errors there. And at the same time, you have a logical dependency between the slots in different terms of a dialogue. For example, if I'm talking about the fast food, it's usually cheap. And if you just randomly substitute these values with different things, you might end up with a $500 Domino's pizza, which doesn't really sound right. So you want to probably keep these dependencies once you're doing augmentation through your system. So I'm going to skip some of the parts because it's already been discussed in the previous lectures. What we're also using here is a contextual semantic parser. And what we encode is a concise representation of the history. Instead of the full history in natural language, we just use the state, which if the annotations are correct, it assumes that whatever slot values has been mentioned by the user or the agent and confirmed up to now, up to the current turn, is being encoded. And then you have the last agent response and the user utterance, the current user utterance. You will concatenate these, feed it to the model, and you get a new state. So here the agent has said, OK, I have this restaurant for you. And as you can see, the restaurant name has been updated to the Old Maple Garden in the new state. And I have to mention that empirically, again, we have found that encoding everything as text works best, perhaps because we can use the most, we make the most use of the seq-to-seq model training. Most of these models that we're using has been trained on plain text, not formal language, and representing things as plain text works best. So we have also tried this approach on a bunch of different data sets, multi-was, cross-was, and RISA-was. Here for brevity, I'm just showing the results for one of the data sets. RISA-was is also a multi-domain, large-scale dialogue data set. The differences to multi-was is that it has usually cleaner annotation, and also it's been produced in Chinese. So what we've done here is that we've used our translation approach. We have translated this data set in German and English with and without alignment. And as you can see across the board, we are getting better results using the model that we just shown and about like 11 to 30% improvements, which shows that the accumulation of translation errors actually can be mitigated by this approach. At the same time, the alignment is useful for both closed ontology and open ontology dialogue data sets. As you can see, the results on RISA-was English without alignment is very low, meaning that you absolutely need to make sure the entities are aligned in the sentences. And overall, it shows basically we can get high-quality dialogue data sets without any humans in the loop by just pure translation. There's a drop in the accuracy, about 8%, but that's probably acceptable. So the last thing is so far, most of it has been researched, but now we actually want to integrate it into a workable system. And this is where it gets exciting, and also it's very hard. So it's basically bringing research to reality. And what we've found so far works best is a hybrid approach of using both machines and human translations. So for NLU, as I discussed so far, we just use translation of the sentences of the final data set. For NLG, however, we found that we're basically doing template translation instead of sentence. So before we actually generate the data set, we translate the templates ahead of time, and we ask humans to go over it and post-edit it. And there are multiple reasons that we need humans absolutely in NLG. And 3 things that I can just think of right now is, one of them is the output of the translation model for NLU is given to a computer. So it's consumed by a computer, and it learns to cope with the noise. Whereas in NLG, you're just showing the translation to the user. And if the quality is not good, the user is not going to use the system anymore. So you actually absolutely want to make sure that the output is correct. So you need humans to actually verify those constructs for you. The other thing is that the sentence, the data sets that we usually train on are in the order of like million examples, million turns, versus the templates is like 900. So we have 1,000. So there's a 3 order of magnitude difference there. And also, which translates to a 3 order of magnitude in money. And you can probably use that for template translation for 1,000 of sentences, examples, but not for the whole data set. And the last thing is the change over time. So the template that we have is pretty static. Like we might add to it, we might change it a little bit, but that's okay because the previous ones that has been translated, we just keep it. Versus for the data set, we actually run simulation. It's probabilistic, so the sentences absolutely change. And every time you run a new you generate a new data set, you have to translate the whole thing. And using humans there is not doesn't make really sense in terms of money and time. So this is what we have so far. And of course, there are a couple of challenges. So we need excessive testing, as this model is similar to the English. You always can run it at home and like find some bugs and fix it, but the corner cases never come out until you actually deploy it and humans use it and give you feedback. At the same time, because we are relying on machine translation, we need some certain level of quality in the machine translation model. So we probably can't handle like very low resource languages, which an NMT is not available for, the quality is not good. The thing that you can hope for is probably zero-shot or a few-shot translation. But as probably research has shown so far, the quality of those are also not usable, at least in the product. And at the same time, we want to be able to support native synthesis of the new data. So it would be basically humans generating the same grammar and similar to English. And this is the final chapter that hasn't been explored yet. And we also don't know how the quality will compare to translation after the data synthesis. And the ... means that there are unforeseen challenges that we haven't uncovered yet. And of course, after the testing, we might add to this. So in conclusion, we've built a toolkit, a semantic parser localizer that can build a question answering or dialogue system, extend the capabilities of this system to a new language. It has a very flexible design. Basically, you can integrate it into a new system, work with a new data set, or deploy any NMT model out there that you want. And these benefits come from the fact that we're doing data generation. We're not doing modeling. So the benefits of this system can go into any new system out there, any virtual assistant out there. And most importantly, the comparable accuracy. We want to build a system that has good quality and have comparable accuracy to the original system. And this is achieved yet at a fraction of cost and time compared to the previous approaches. Thank you so much. If there's any questions. Okay. So I'm going to hand it back to Giovanni, who's going to talk about the customer support agents.
All right, so all we heard so far was question answering and task-oriented dialogues. And task-oriented dialogues, like transactional dialogues, are very important, especially for virtual assistant. But another category of conversational agents or voice interfaces where there's really a lot of industry and a lot of potential, a lot of interest and a lot of potential, is agent for customer supports. And the tricky bit, of course, that while transactions all kind of look the same, customer support agents are all different. And the kind of customer support tasks that we need to do are the one where the normal interface doesn't work. That's why we need support. If the normal path works, we don't need to call anybody. But the interesting thing that we have observed is that websites have built interfaces to perform these customer support tasks, such as, in this case, redeeming a gift card. In addition, because the websites have an interest in supporting their customer, they have built very detailed and very precise help pages where they describe all the steps that one would take to, in this case, redeem a gift card. And so our observation is that we can take these instructions and convert them into instructions from an agent. So now the agent can go and execute this instruction, ask the user for the claim, go to this website, fill in the claim code, and then therefore perform the customer support task on behalf of the user based off of this instruction. And so we have built this system called RUS, the Rapid Universal Support System. The system is an automatic toolkit to build agents that take in expert instructions written from the help pages from the real website of customer support, uses a semantic parser to ground the instructions into a formal executable representation, and then further grounds the instructions into a web page. So all these instructions refer to element on the web page. You need to figure out exactly which element. Where am I entering this? Where am I clicking this? We have a model that will compute exactly the element on the page to interact, such that at runtime, the agent can go and click and drag and enter and talk to the user to perform the customer support task. This agent is built all automatically based off the instructions. We have found that to build this agent, we only really need 6 kinds of actions. there are three kind of actions that actually interact with the web page. So four kind of actions that interact with the web page. There is navigation, of course. There is entering something into a field in the web page, clicking, and also reading results out to the user. And two other operations that the agent needs to support as the standard dialog agent, saying something to the user and asking something back. It's a very limited form of dialog agent, but it's sufficient to actually perform the task. And so the formal problem statement is, how do we take an instruction that, in natural language that is meant for a user or meant from an agent acting on behalf of the user, combine it with the web page where this is going to be executed, which is abstracted into the document object model, the tree of all the elements on the page, and how do we map it to a precise action that the agent can execute against a precise element on the page. In this case, entering the order number on the input element for the order number. Our approach is to use ThinkTalk as an intermediate representation. So the model can translate the instruction into a ThinkTalk representation, which is a formal representation of the instruction, independent of any web page. So we can train a semantic parser once and for all to translate. And then as a second step, we map the precise ThinkTalk into the specific web element based on the web page, based on the state of the web page at the time of the action, at the time that the agent is taking the action. I'm not going to go into the details of the specific models, but we have built RAS as an end-to-end system. We have first to evaluate the two ML models. We have collected an evaluation data set. This contains, we've taken help pages from 22 different websites, and we collected 80 different tasks. Out of these 80 tasks, we collected 741 instructions. Then we annotated each one instructions with the web page where that instruction needs to be executed on, in its formal DOM, the ThinkTalk code corresponding to the instruction, and the action grounded, so the action on the specific web element that needs to execute. And on the accuracy just to the semantic parser, we find that our semantic parser achieves 87% accuracy. This means that we can identify the correct ThinkTalk corresponding to the instructions 87% of the time. And note in particular that, as usual in our approach, our semantic parser was trained only on synthetic training data, 1.5 million synthetic examples that we collected out of specific templates for customer support. On the subset of the instructions where the agent needs to interact with the page, we also need to run not just the semantic parser, but also the grounding model to identify that the model can actually find the correct element. And on this subset, RAS achieves a 63.6%, and it beats two state-of-the-art baselines that instead of using ThinkTalk as an intermediate representation, go end-to-end mapping natural language into a web element, which shows that our approach of using ThinkTalk as a semantic parser first and then grounding based on the formal ThinkTalk is effective. We have built an end-to-end prototype of RAS that uses the Puppeteer automation library to interact with a web browser, uses Google Voice to do the actual speech form, and can interact with the users. And we have conducted a user study with crowd workers where we ask people to perform 5 different tasks. Here are the examples. There is redeeming gift card, getting a specific account number, logging out of all your accounts, creating a new account, and so on. And across the board, over all these tasks, we find that users are satisfied with the speed of RAS. They're overall satisfied with the system, and they're likely to use it much more than other systems, the other chatbots, or much more than just doing the thing by hand on the web page. And in conclusion, RUS is a system to generate customer support agent that is trained once because it's trained against a formal representation, and it runs on any web service instruction. So out of your web page that has customer support service instruction, you can run RUS and get an agent, a basic agent. It reads the instruction, immediately it's going to answer your phone calls. The system has a 77% end-to-end accuracy, which means including both semantic parsing and grounding. And in our user study, for those 5 examples, 69% of the user prefer using RUS, prefer talking to this agent, over actually going and doing those tasks on the web by hand, following the instructions. Thank you.
I think you had a question. Okay, that's very fascinating, I must say. Really great job. And so what would it take for someone to implement this? You know, I'm a company, I have some help web pages, I want to go ahead and add voice to them. Okay, so how do I do it?
So I want to clarify, this is an experimental system.
It's okay.
This is a research prototype. It's built in 1 quarter, really. So there are a couple challenges, really, to real-world application. One thing is that the kind of agents that we generate are very simplistic. I showed there are 2 actions that in terms of the dialogues that the agent will perform. They just say something or ask a question. We do want to be able to marry the task-oriented transaction agent that lets the user jump around and are more robust than dialog trees with this kind of agents that are more fixed logic. So that's an active area of research, or how can we synthesize data basically for these structured agents. The other part is how do we actually interact with the web pages. So interacting with the web pages using web automation APIs, we have found in this work, and we have found in other work that uses multimodal assistance on web pages, works very well if the page uses standard HTML elements. It works very well if the page is static. The more complicated the page, the harder it is to actually interact with that automatically. So in a sense, this gets you a rapid prototype. It's very fast to get something. I would still recommend a real company that has to support a customer support agent should supply an API. It's going to be more robust than using an agent talking to a web page. It is on, yeah.
Hello? Okay. Yeah. It's really impressive. Actually, you know, if you ask any chatbot company, the onboarding of the customer is about like 60 or 70% of their work. I mean, you're going to take them out of business if that works at that scale. It's still not clear to me how, like, is it, like, do you use a sequence-to-sequence model that takes the DOM and translates to the instruction? How does it really work? Like,
yeah, so
I don't know if you can get the details.
I omitted some of the technical details in this presentation, but the key is that there is a retrieve. So for the grounding step, for going from ThinkTalk to the specific element, we use ThinkTalk to have a structured representation, a structured basically description of which element we are addressing. This structured description will include what type of element, relative position on the absolute position on the page, like the top buttons, relative position to other elements, the description, and so on. So we extract the features out of this retrieve call in ThinkTalk, use that to first filter the elements by rule, like I'm looking for a button, I filter out everything that's not a button. And then I can use a sentence similarity model, a pre-trained BART model, to just compute the closest matching element to the description. I don't need to compute the closest matching element to the whole sentence, which contains a lot of other stuff that is not the element. I have already extracted the description, which is likely going to be very close or even the same words if the help instructions are now going to be trying to confuse the user using different words. So the similarity becomes very easy.
So you don't need annotated data. Like you start from think talk and you synthesize them. That's the part that it's a bit.
So okay.
Anyway, we can take it offline. I don't want to take the time, but we can read the paper.
Okay.
So currently, this system relies on a support page to be able to figure out how to manipulate the DOM correctly, right?
Yeah, so it will read out instructions on the web page. It will assume that the instructions are very detailed, like step by step, which they typically are. So it will.
Do you think it would be possible? Currently, of course, it's experimental, but in the future, do you think it would be possible to extrapolate to other UIs for other sites that might not have a detailed support page, or is it too reliant on, or is it currently difficult to do without the support page?
It's a great question. I don't know the answer because I think it is the case that every website works differently. Every has a different UI language and it has different arrangements. So we do rely on the instructions telling us that the button is next to the other button, for example, and then we can filter out which button we're talking about. So if that's not the case, then it will be difficult to generalize.
Okay.
All right. We get to if there are more questions, we get to the fourth part of the talk, the session, which is a bit lighter, a bit chattier.
Hopefully. Okay, that works. 1 second. Perfect. One second, please. Just grabbing my window out. Oh well. There we go. Yep. Just need to grab the printer view out. Excellent. All right. Hello, everyone. Thank you for coming. And we're going to now be talking about Team Chirpy Cardinal's work at the Amazon Alexa Prize 4. This work was advised by Professor Chris Manning as part of Stanford NLP and Stanford Oval. So the question we're hoping to address today is, how did we build a social chatbot that talks to thousands of users per day about anything in the world? Working with a large team of 14 BS, MS, and PhD students, the Chirpy team focused on building a system that could bring emotional connections, one that might bring joy to people around the world in the US. Talking to thousands of Alexa users per day, our system placed second in the Alexa Prize competition, with our conversations often lasting over 15 minutes with people around the world. What do we mean by bringing joy to people or developing connections? Well, the goal of our system was to do open domain dialogue, which is what normal humans call small talk. Most of what we've been seeing throughout today is like task-based dialogue. So you have some sort of like thing we're trying to do, whether it's ordering coffee or it's like trying to book a hotel. By contrast, our system can talk about anything in the world that you can think of. The goal is to not just perform some task, but to create emotional bonds with users by not only interesting and entertaining them, but also empathizing with them and caring about what they have to say as people. Let's take a look at our example of our system in action. Oh, is there a way to connect audio to this?
You need to.
Excellent, thanks.
Make sure it goes out of this.
Let me check.
Are you Paul?
Yeah.
Doesn't seem to be. So, cool.
Okay.
All right, and then that should work.
As social bot. I believe we may have met before. Are you Paul?
Yeah.
It's great to talk to you again today, Paul. I enjoyed your company very much the last time we chatted. I hope you're having a lovely afternoon. It seems that a lot of people found the quarantine lonely, and other people can't get enough space away from their families or roommates. Now that we're over that hill and things are opening up, what's it been like for you?
Starting to do a lot more walks.
I love walks on trails in the mountains. They're so relaxing and quiet. Anyway, I suppose people experience the quarantine in many different ways. What a unique time we're living through. Well, do you want to hear about my favorite movie instead?
Yeah.
My favorite movie is actually Big Hero 6. Because I really love Baymax, which is the robot in Big Hero 6 that just loves to help people. Can I tell you my favorite part about Baymax?
Do you like Astro Boy?
Thanks for asking. I love Astro Boy. I think I've seen every single one of them.
What's your favorite part?
My favorite part is when the robots are fighting. I can't believe it's been a long time since I've ever seen it, since it was released in 1997.
I didn't realize it was that old.
It's alright. Baymax is just the cutest robot. He's so huggable like a giant balloon. I totally love it when he says ba ah la la la. Doesn't that just cheer you up?
It does every time.
So that's the example of our bot in action. You can see that we have a conversation on a wide variety of topics. We started on, the reopening, quarantine, and then we moved into talking on a different subject, and the user is able to take control of the conversation, chatting about their favorite topic, Astro Boy, and we're able to discuss that in some detail as well, despite not being explicitly told ahead of time, hey, we're going to be talking about Astro Boy. With that in mind, let's find out, how do we hold a social conversation? Here's the 3-step guaranteed formula to make you hold good conversations. The first one is to be consistent and not contradict yourself. You're going to want to represent the conversational state at each turn, which means we have an idea about where in the conversation we are and what we're currently talking about. As you can imagine, that's kind of important to have a good conversation. The structured approach means that we have a conversation which stays on a single topic and doesn't wander too far at a single time. And we can hold these sort of views and topics over the course of an entire conversation, bringing up things we've discussed previously at a later time. Each topic I just mentioned is managed by a different submodule, which we call response generator. There are a lot of different submodules. We heard the reopening and the movies module previously. But there's also things like music, sports, food, aliens, opinions, which are Twitter hot takes, and other neural generators as well. We have over a dozen of these, and they form different elements of a conversation. The step 2 is to be able to transition between different things we're talking about. There's only so long you can talk about movies or about music or whatever. So once we finish one topic, we're able to smoothly move into another one. We do this by remembering what people talked about previously and storing in sort of like a queue of things that we should bring up at a later time. For example, here we've been talking about France, and we say, France is such a beautiful country. Well, we've run out of things to say about France. So we remember that the user brought up food, and we combine that together to say, okay, speaking of French food, I recently found out croissants were invented in France. We'd like to talk about croissants. And then lets us smoothly transition into a foods module in a way that's much more smooth than just saying, okay, we're going to talk about foods now. Step 3 is then to find out what people feel about you. Deal with positive, negative emotions. If someone is interested in something, we make sure to navigate towards it. For example, someone here says, I want to talk about Frozen. Let's talk about Frozen, please. And so we're able to smoothly transition to that topic and ask, why are you interested in it? When did you watch Frozen? Things like that. Personal questions that will get people interested. We're then able to offer our own opinions, like I love Elsa's powers in Frozen. However, people are often actually disliking things. So if someone doesn't like things, we just take a note of that as well and are able to handle negative emotions by either retreating from it or asking, why don't you like movies? What's your problem with movies? And so we're able to get people interested in this way as well. Take what could be bad and turn it into something positive. Here's the overall structure of our system. It's an efficient parallelized architecture which runs on AWS Lambda. More technical details, if you're interested for whatever reason, are available in our paper where we go a lot into the systems consideration behind this tool. All right, so let's talk about empathy, which is a really big goal of our work. As I'm sure many of you have seen, if you've ever played with Alexa or Siri, current voice assistant technology can be super dehumanizing and cold. It doesn't really seem to get what's going on in a human way, but rather just seems to pick up on things you're saying or not. Can we instead create a system that creates emotional bonds with people? Overall, we want to motivate users to share their emotions and experiences in a respectful way. Then we want a system which responds empathetically and takes into account what people are saying. Here's an example. We've found that people that come talk to our system for long periods are often those who need to vent or discuss some kind of negative experience. People recovering from a breakup or personal issues with people in their life or other things that may be going on. In this kind of situation, standard models do really badly. They'll do things like, okay, I'm sorry your dog died. By the way, what's your favorite movie? This is not great. Instead, we want to be able to be actively listening. So we've built a system which detects these sort of negative emotions and uses them to start an active listening submodule. We listen to what people have to say and give them the space they need. Another example is our neural models, which we'll talk about in just a second. They're trained on empathetic dialogues, a special pre-training data set, which is focused on intentionally teaching neural models about empathy. This training produces a model that's able to respond in a respectful and interested way to a wide variety of situations. For example, people often talk to us on their birthday for some reason, and we're able to say, that's awesome, I'm glad your birthday, I hope you got lots of presents, which is an example of something we've said in our dialogues. So finally, let's talk about the way our modules are structured and how we deal with fluency. The standard way for social bots to produce dialogue is to use a tree. Here's a simple example that we use. In the food treelet, we start by asking what your favorite food is, and then we're able to go on about that and ask, comment on your favorite type of food, and then ask, for an open-ended comment and list a factoid. And, most of the dialogue systems bouncing around the world right now are focused on this kind of tree-based structure. For like a super simple example, just think like a phone automated assistant when you call it and it goes down a list of items. So that's fine, it works, but as you can remember from experiences with these phone agents, it's kind of limited, and after a while, it'll start to feel really repetitive, as it doesn't seem like the thing is really listening to what you have to say. Since this dialogue is handwritten, there's not much variation. So to avoid repetition, can we do better? Recently, researchers at Facebook and Google have proposed instead training a state-of-the-art deep neural network to directly do dialogue. You've probably heard of GPT-3. What we're talking about is just training GPT-3 instead of just to model text, but actually just to model dialogue instead. With hundreds of billions of parameters, these models are able to produce incredibly fluent conversations. They look really great, but the problem is they're really hard to control. They don't maintain a state, which is, remember, commandment number 1 of having good dialogue. So they're not able to continue a coherent conversation. They like to change the topic, or sometimes they contradict themselves, saying, I like movies, and the next turn they say, I actually don't like movies, and that's not great. So the question is, how can we integrate the fluency of these deep models, which are really hyped up, and control what they're saying? So here are two methods we've proposed in our research to bridge the gap between academic models and what actually works in real life. The first one is prefix generation. We start a sentence with some kind of handwritten scaffold, which I've marked in blue, and then we let a distilled model finish off the sentence with an interesting continuation. For example, we start off by saying, you know, I love fish and chips. I especially enjoy, that's handwritten. And the model's asked to fill it in. That way we know the model's going to say something they like about fish and chips that's going to be interesting and targeted. But we don't have to worry about it going into a random direction. This uses a GPT-2-like model. It's a distilled blender bot with 10 decoder layers. Another method that's novel to this work is infilling. We generate interesting emotive opinions by starting with a set of templates and filling it in. What do we mean by this? Well, if you look at the slides, you can see that we've prepared a template ahead of time. Someone handwrote the template. You know, this actor, in brackets, is really great in movie. And I especially like some text to fill in. We've trained a BART model, which is similar to the ones we've seen previously, to fill in those blanks and to be able to put some interesting text in. So we know that the model is going to say, you know, I love the actor, but it's able to give some interesting emotive opinions by filling in things that are specific to this actor and to things about the movie. The resulting comments are much more human-like and relatively interesting. Of course, there are lots of other problems. That means you can't just use deep neural language models. There's a slowness. They can run for up to 10 seconds. They can be super toxic because, as people have seen, they reflect societal biases. And they have a lack of consistency with self-contradiction. We address all of these things with different methods in our system. You're welcome to check out our paper, and we talk much more in detail about all of these techniques. One final thing I want to shout out is a current huge problem with neural networks is they don't keep up with the real world. So like GPT-2 was trained in 2018 or 2019. It's excellent for telling us facts about the world in 2019. But if you ask it who the president is, it's going to give you a response specific to 2019, not today. But it turns out humans don't just want to live in a previous year. One of the things we do as people is actually want to talk about what's going on in the real world. So how do we deal with that? Our system actually integrates with the Guardian News API, and it's able to pull relevant articles of whatever we're talking about. So for example, it says, you know, people have been talking about GameStop recently. This was from a couple months ago. And it says, do you want to hear more about what's going on? And if the user says, sure, we're able to use the state-of-the-art Pegasus neural model from Google AI to summarize what's going on into a tidbit. So we go from a gigantic article into a 2 to 3 sentence thing that's interesting to listen to, and the user can then ask questions and follow up on. So just to conclude, we've open sourced last year's bot. You can play with it online at this link. It's on the stream, and also you can Google Chirpy Cardinal to find it. It's a tool where you can just type in your stuff, and it'll respond to you in a smooth way. This year's version will be open source soon. We also hope to combine this effort with the Oval team's work on structured dialogue and task-based dialogue to produce systems that combine the best of both worlds. Anyway, thank you so much for listening to this. I just want to thank the rest of the Chirpy Cardinal team, which was really big, and really appreciate all the hard work they did to get this done. And thank you so much. Any questions? Happy to answer that. Any questions of the system we've presented here? Yes?
So you deployed your model on AWS?
Yes, so just some technical concerns. The models are deployed on AWS. It's on AWS Lambda, so it's burstable in case lots of people talk at the same time. And then all of our neural models are like distilled and placed onto EC2 instances that run remotely. So it's a pretty interesting working systems as well.
What was the final size of the model, if you know?
So the overall like dialogue manager is written in pure Python. It's not like a neural model. So that's going to be, I think there's a limit of like 64 megabytes including all of the library code. So in practice, it's more like 1 megabyte for what we wrote ourselves. Now the models themselves are going to be up to like 100 billion parameters, so we can infer what that is from there. But those are all going to run remotely, so they don't really factor in our main size. Okay. There's like a constellation of 5 or 6 different neural models that all run at the same time and help us predict things. Any other questions?
Is there a danger when you make the model too empathetic, since ultimately you know that it isn't really a person? So when you talk about death and that you feel that you're getting an automatically pseudo-empathetic response. I mean, how do you deal with that concern?
That's a really great question. Thanks for asking it. And I think that's a debate that's been going on for a very long time, especially since the first ELIZA bots, where it's obviously just repeating back what you're saying, but yet people seem to prefer it in some cases over real human therapists. So one thing, we We try our best. Of course, there are some topics we don't want to broach because our risk of offending people or just not being able to say appropriate things is just very high. But in many cases, you'd be surprised that I think people sometimes just need someone to listen to them. And whether it's even a social bot that people do know obviously isn't someone on the other side talking to them, can be a surprisingly effective way to do stuff. We're not claiming to be an intervention by any means, but you can look at the logs and see. Any other questions? Great. Well, thank you so much, and I think we're going to move into the closing ceremony now.
Yeah, closing ceremony.
Yes.
Thank you so much. It was a great talk.
Thank you.
All right. Well, we have come to the end of a very long day where we talked about this whole new concept of the worldwide voice web. And, so this is the first workshop on the Worldwide Voice Web, and I hope that it is just the beginning of many, many more conferences on this topic. And I want to thank everybody that made this program possible. I want to thank the panelists and the moderators who gave us a lot of things to think about in the various topics, from will there be this Worldwide Voice Web, what would that be like, the use of voice in humanitarian projects, as well as what it means to have a voice information ecosystem. We talked about ecosystems. We also talked a lot about the technology. And I want to thank all the people who worked behind the scenes. The staff, the AV staff that we have here, and Andrea, who is my admin, who has been doing all this work. And of course, I have to acknowledge that all the talks and demos, there was so much work behind it. And the team is here, and I think that that was a good job. I think that was really good, really exciting to have a chance to talk about all the work that we have done. We also want to thank all the people who are watching us online. There are about 400 people registered and about 300 people from the industry. And next time we have to get more people from the academia to participate. And of course, I want to thank everybody who managed to show up here. Next time we will have this workshop in person, and we can invite everybody here to come to this beautiful Stanford campus. For the people here, we have a little souvenir. This is a comic book about Almond. Almond is the precursor to Genie. And this is sent to me by my colleague, Marc Duranton from CA in France. So in 2020, we were supposed to have a workshop in Europe on the Open Virtual Assistant. It was March. We canceled it in the last minute because things we just couldn't travel anymore. And for that workshop, they prepared a little comic book. This is by the High Peak community. This is the high performance architecture and compiler community. They wrote a comic book about Almond. And it talks about what it would be like to have Almond in 2030, and it talks about the past. It talks about the WWW, and it was a conversation with somebody who remembered the earlier days. And as we were thinking about the Worldwide Voice Web, it is actually very interesting to read this comic. So he sent it to us, and it just arrived today, just in time. So I'm going to hand this out. So, all right, with that, thank you very much. And we have a reception, and please stick around. We have very, very good food. So enjoy it, and I will see you guys right now. All right, bye-bye.